You can analyze a large amount of data from different sources in real time with a service called AWS Kinesis. Think of it as a powerful mechanism for handling data flows at scale, enable applications such as real-time analytics, collecting logs and event data, and processing data from IoT devices. Amazon Kinesis is a service provided by Amazon Web Service or AWS that allow users to process large amounts of data, which can be audio, video, application logs, website click streams, and IoT telemetry per second in real time. In today's scenario, you can handle big data that becomes very important, and that's why there's a whole area known as a big data that deals with processing or handling streams of big data. That's why Amazon has come up with a solution known as Amazon Kinesis, which is a fully managed and automated and can easily process large streams of data in real time. It allows users to collect stored records and process many logs from distributed streams such as social media feeds, for example. So, we have first data entry. Amazon Kinesis will collect data or receive data from different streams, data streams such as apps, sensors, etc. The data that will be received from different sources can be in different formats such as JSON and binary. It can also receive real-time application data. Then the second step is sharding and scaling smaller chunks of data called shards. Data received from different sources and are split into smaller shards for redundancy and fault tolerance. There are no restrictions on shards, so Amazon Kinesis can scale shards horizontally depending on the requirements. The third step is processing and buffering after sharding, so your data will be prepared for further use, such as filtering or aggregating records before storage. And finally, the fourth step is making data accessible. Once you have completed all above steps, you know that the data should be accessible. It offers different ways to access and use your data streams, such as Kinesis Data Stream APIs, Kinesis Firehouse, and Kinesis Analytics. Amazon Kinesis will stream data in real time, as we already said. It will help handle it and tell you what to do with the data line in the organization goals. The following are the broader categories to get you started: real-time entry, data entry and processing. So Amazon Kinesis will retrieve data and will help in applications such as healthcare that are used to identify and regulate the patient's health, and also in case of any emergency. With the help of data, we can predict this in advance. It can also be used in OTT platform applications with which you can personalize data according to the user experience. Also, real-time data can be stored in storage and used for further research and can be used for further use. And Amazon Kinesis can be integrated with other services as well. Also, the data collected from the real-time data will be analyzed in its entirety, and anomalies, fraud attempts, or any other critical situation will immediately identify it. It will also track your key metrics that can be used to make data-driven decisions. There are 4 types of services that Amazon Kinesis offer, and there are Amazon Kinesis Data Stream, Amazon Kinesis Video Stream, Amazon Kinesis Firehouse, and Amazon Kinesis for Data Analytics. The first one is Amazon for Data Streams, Kinesis Data Streams. It provides a platform for real-time and continuous data processing. It also is used to encrypt sensitive data using key management service, master keys, and server-side encryption for security purposes. The second one is Amazon Kinesis Video Streams. Amazon Kinesis Video Stream is a fully managed service that makes it easy to secure the transfer of video data from your device to the cloud for real-time processing and analysis. With Kinesis Video Streams, you can effortlessly record, store, and process video streams for a variety of use cases, including surveillance, media streaming, as well as IoT applications. It enables seamless integration with machine learning models for video analytics and provides powerful tools for processing video data in real time without worrying about scalability or storage limitations. Amazon Kinesis Video Streams is a powerful tool provided by AWS as a service that can deliver live streams on demand in real time. So you can see what are the key features of this service, like live video from a variety of sources, real-time video processing, analyzing video content, delivery of videos and different destination, and you can create custom video applications. Also, the third part of this service or offer is data analytics. It enables the analysis and processing of data streams provided by Kinesis Firehouse, and Kinesis Stream uses standard SQL. It analyzes the format of the data and parses it automatically using the standard interactive schema editor to arrange it in the recommended schema. It also provides pre-made flow process templates that can be used to select the appropriate template for their data analysis. And finally, we have Kinesis Firehouse. Firehouse allows users to upload or transform their data streams into an Amazon Web Service and later transfer them onto them for other functionalities such as analysis or storage. It does not require continuous management as it is a fully automated and automatically scales according to the data. Finally, features of this service is that all services provided by Amazon are cost effective because they follow a pay-as-you-go model, which means you have to pay for the service on a per use basis rather than a fixed price. Therefore, it is beneficial for users to pay only for what you use, or you will pay only what you use. Also, Amazon Kinesis allows users to use and integrate with other AWS services. The services then can be integrated in our Amazon DynamoDB, Redshift, and all other services that handle large amounts of data. You can access it from anywhere and anytime. All you need is a good internet connection. Also, when you want to run real-time processing, you will be allowed to work on data that needs to be updated every time with the current changes. The most advantageous feature of Kinesis is that real-time processing becomes important when working with such a huge amount of data. Also, Amazon Kinesis is a versatile streaming data management and processing platform, offering a range of services to meet a variety of needs, from basic data entry to advanced real-time analytics. AWS CloudWatch is a tracking and observation service provided by Amazon Web Services. It helps customers monitor the performance of their AWS resources and applications, troubleshoot issues, optimize resource usage, and gain a unified view of their operational state. Amazon CloudWatch is a real-time asset tracking and observation service built for DevOps engineers, developers, site reliability engineers, and IT managers. CloudWatch provides users with data and actionable insight to track their application, stimulate system-wide performance changes, and optimize resource usage. CloudWatch collects tracking and operational data in the form of logs, metrics, and events, providing its users with an aggregated view of AWS resources, applications, and services running on AWS. CloudWatch can also be used to detect anomalous behavior in environments, set alerts and alarms, visual logs, and metrics side by side, take automated actions, and troubleshoot issues. Amazon CloudWatch Agent is something. When we talk about this agent, this is a lightweight open source tool used to collect data for the data about the resources in which they are deployed. Some of the data, for example, what are metrics? Metrics, the Amazon CloudWatch agent will record data on CPU usage, memory usage, disk input-output operations, and other system-level statistics. Logs collect all records that are used for further analysis. What are events? To running significant instances, making changes to security groups, and other events. Amazon CloudWatch is a tracking service provided by Amazon Web Service to track apps like the following: performance, application, help, monitor resource usage, etc. You can set an alarm for an app resource usage when limits are exceeded, and then you will automatically receive an email notification. Here's how the CloudWatch works. First, the Amazon CloudWatch will be configured for the resource you want to track. From there, the configure agents will be used to collect logs from the resource. Then, the service can be run locally or via AWS. CloudWatch also provides a general overview of resources with the help of a dashboard from which you can troubleshoot problems. CloudWatch also performs operational changes depending on changes made to resources, and will also perform automatic scaling of resources in AWS depending on changes that have occurred. CloudWatch performs real-time analysis based on the logs received. Also, as we already said, there is some features of Amazon CloudWatch, So metrics, it is a time order set of data points that are published on Amazon CloudWatch. All data points are time stamped. A metric is a variable that is tracked, and data points are the value of that variable over time. They are unique, defined by name, a namespace, and 0 or more dimensions. Math metrics are used to query CloudWatch, multiple CloudWatch metrics, and use mathematical expressions to create new time series based on these metrics. Dimensions, well, a dimension is a name-value pair that uniquely identifies a metric. Dimensions are unique identifiers for a metric, so whenever you add a name or a unique name-value pair to one of the metrics, you create a new variation of that metric. And statistics are the aggregation of metrics over a period of time. A few of the statistics available on CloudWatch are maximum, minimum, sum, average, and number of samples. What is alarm? It is used to automatically initiate actions on our behalf, track a single metric over a period of time, and performs one or more specific actions based on the metric value. Estimated AWS cost can also be tracked using alarms. Percentiles, it represent the relative weight of the data in the data set. It helps the user to better understand the distribution of metric data. Then we have CloudWatch dashboards. A simple CloudWatch console is available and it's used to track resources in a single view. There is no limit to the number of CloudWatch dashboards you can create, and these dashboards are global and not region specific. So we have already mentioned our CloudWatch agent. Installation is required if you want to use your agent, and it collects logs and system level metrics from EC2 instances and on-premises servers. And finally, we have CloudWatch events. CloudWatch events help you create a set of rules that match any event, for example, stopping an EC2 instance. These events can be targeted, and one or more targets, such as AWS Lambda functions, Amazon SMS DEMS, Amazon SQS queues, and other types of targets. Also, CloudWatch events continuously monitor operational events, and whenever there is any change in the state of the event, it performs an action by sending notifications, activating Lambda functions, and etc. The event indicates a change in the AWS environment. Whenever there is a change in the state of the AWS resources, events are generated. Rules are used to match events and guide them towards goals. Events on the target process. These include Amazon EC2 instance, AWS Lambda functions, etc. So the target receives events in JSON format. And we have something called CloudWatch logs. Amazon CloudWatch logs allow you to store, track, and access files from AWS resources, such as Amazon EC2 instances, Route 53, etc. They also help you troubleshoot system errors and keep logs in extremely durable storage. It also creates a log with information about DNS queries that Route 53 receives. So, this service will help you to monitor the health and performance of your AWS resources and application, quickly identify and solve problems, optimize the use of resources, and improve performance. You can gain a unique insight into your operational health, and you can automate a task and streamline your businesses. There is also something called CloudWatch Alarm, but more about this CloudWatch Alarm service in the next chapter. If you go to our console and in our search bar, we can type CloudWatch, for example, and as you can see, this is the service that uses for monitoring resources and all our application in our console. So let's go inside that service, and you can see that there is a robust service. So there is a lot of things that you can do with your CloudWatch. So there is a lot of new options, and here you can create an alarm, create a dashboard, view logs, view events. Also, you can choose your action to see live data override and period override. You can choose between these predefined times. And finally, here you can configure something called Explore Observability Solutions and configure Application Insight. So you can set up monitors and dashboards to detect issues and resolve problems with enterprise application, different databases and workloads, and there is a detailed explanation of how did this work. Also, CloudWatch observability solution is out-of-the-box over observability for AWS services and popular workloads. So you can use this, explore different solutions to simplify the process of instrumenting and gaining insight into your workloads and so on. If I click on dashboard, you can create a custom dashboard, or you can use something called automatic dashboard. So we have this predefined dashboard that is created by AWS, and if I go to, for example, application load balancer, you will get this automatic dashboard. Or you can simply create a new dashboard. You will add a name for your dashboard and simply click on create dashboard. Then if we go back to our menu, there is AI operation, artificial intelligence operation, and here you can choose to work with CloudWatch investigation, and as you can see, this is a relatively new option, and all this operation will track. So you can first create an investigation, collect findings, review findings, and close this and archive your investigation. So with AI operation blade, you have option to check all your AI options. Then we have alarm. If you go to that blade, you can set up or create your alarm. First, in the first step, you will get your metric. So you can select your graphic, for example, one of these metrics from these services. If I go to my EC2 instance, there is 132 to choose from. For example, as you can see, we can choose this CPU utilization, and then we can select our metric. Here, as you can see, we are using our CPU utilization. Statistic is average, and period is every 50 minutes. Then threshold type is anomaly detection and static. So whenever your CPU utilization is greater than 80%, this alarm will be fired. So let's click on next. So we need to configure our trigger. You can use this alarm, then select SNS topic first, then you must create your SNS topic. Check this EC2 actions. When you stop this machine, then it will also alarm the trigger. So you can only stop the instance if it's backed by EBS volume, and then you will get notified. And that's it. This is how can you create your alarm. You will find all your alarms here, and of course this is a paid service, so there will be billing. As you can see, in time of the recording, you will get 10 free alarms, 1000 free emails as notification as a part of this free tier. But this is a paid option. Also, the another blade is logs, so you can track all your logs here. For example, we have already from my Lambda function, and here I can show you that this was created 9 days ago, and you can see that I have my logs. If I go inside that logs, you can see that all logs and the timestamp and the message that I used when I work with this service. So if you go to actions, you can also view log insight, download this as CSV file, copy result, or search result. So there is a lot of option that you can do in CloudWatch with logs. Also, there is something called live trail, and you can trail all these live tail, sorry. Also, there is a log insight. So here you will be able to run your QL or SQL QL, and finally you can see our Lambda function. If I run query, for example, there is no data for now, because you can use KQL or Custo query language to learn more about your logs from different services. So this is just a simple explanation, because we are just do a simple tour on our CloudWatch. Finally, there is a contributor insight. So here you have option to read more about this insight. Also, metrics are very important. In our CloudWatch system, you can choose different metrics from different resources, and there is also an explorer, so you can track your metric and choose, for example, EC2 instance, choose your tag from one of the VM, choose your aggregate, and so on and so forth. So this is an explorer, and you can add this chart to the dashboard that you create onto your screen. Also, you can create something called metric streams, but also we have application signals and all of this. You can track all your applications here and access health, diagnose some application performance and availability. Also in the network option, you can see flow monitoring, and you can track all your networks from your ECT and so on. And we have these internet monitors. This is a major outages and impact client's location in past 24 hours. So here you can see if some of these regions or availability zones had some problems. As you can see, this red one is availability issues, the yellow one has performance issues, and we have our AWS region. This is the complete map. Also here in the synthetic monitors, you can create a monitor, collect metrics, and then observe your metrics and check your performance and ability for your network trafficking. This is also a very useful and a very, very used option. And finally, we have something called Insight. There is also telemetry configuration and so on and so forth. So this is our CloudWatch. And here you will be, from this service, you will be able to watch all your services in one place. Thank you for watching. Amazon CloudWatch Alarm is a tracking tool that monitors CloudWatch metrics and triggers action when a metric value exceeds a defined threshold. These actions may include sending notifications, for example via social media, or triggering auto-scaling. Alarms are essential for proactively monitoring and ensuring the availability and performance of AWS resources and applications. So, functionality of this service is tracking metrics. So CloudWatch Alarms track certain metrics related to your AWS resources, like EC2 instance, CPU utilization, number of AP gateway requests, and in the threshold you will define your threshold, high or low for metrics, and when that metric value exceeds this threshold, the alarm state changes. Alarm state have three states. First is okay, the metric is within a defined threshold, we have alarm, then metric has crossed the threshold, and insufficient data, so data is not available for alarm evaluation. Then actions, when an alarm enters the alarm state, it can trigger automated actions such as notifications. It will send alert via simple notification service, and you will see that we already saw how can we create these notifications, and you will receive this notification through email, SMS, or other endpoints. Then it triggers actions to scale resources up and down based on alarms. And key benefits of this service is proactive monitoring, so alarms allow you to detect problems early before they affect your users or application. It has automated responses, like triggering actions automatically, reduce the need for manual intervention, improving efficiency. Also, we have performance optimization. By monitoring resource utilization, you can identify bottlenecks and optimize resources allocation, and cost optimization. By scaling resources based on demand, you can avoid over-provision and reduce cost. You can also set up a CloudWatch alarm for an EC2 instance that triggers an alarm if CPU utilization exceeds 80% for 5 consecutive minutes. When this happens, the alarm could send a social media notifications to the administrator, warning them to investigate potential issues with the instance. We saw this in the previous chapter. Well, AWS CloudWatch Logs is a service that allows users to track, store, and access log data, log from various AWS resources and applications. It acts as a centralized logging solution, allowing users to collect logs from a variety of sources, analyze them, and create alerts based on specific patterns and events. With CloudWatch Logs, you can set an application and system log files from your assets to CloudWatch, where they can be tracked, searched, analyzed, and archived. Here are some key things to know about CloudWatch Logs. It automatically streams logs from sources such as EC2, Lambda, and CloudTrail. Log data is stored in log groups, which contain log streams for each source. It can define metrics and trigger alerts based on log patterns, allows you to track logs in real time using CloudWatch dashboards, allows you to analyze and examine logs using CloudWatch Logs Insights, provides security with IAM permissions and access controls, and it also integrates with services such as CloudTrail, VPC Flow Logs, and Route 53. Also, CloudWatch Logs provide robust features for working with log data. There is real-time streaming. You can send and monitor streaming logs data from your system. Also, you can use this for search and filtering, so you can interactively search and filter logs to isolate information. You can create CloudWatch dashboards to track logs in real time. Also, there is an option for alarm notifications, so you can define CloudWatch alarms to trigger notification for log forms. Also, you can specify retention policies for keeping log history, manage log and action access permissions, and encrypt your log data for added security. You can also share your log groups between multiple AWS accounts, and CloudWatch Log Insight perform interactive queries on log data and create visualization. Also, integration with other AWS services is very good. CloudWatch Logs support a variety of usage scenarios. So, for example, if you have some application and there is some problem with this application, you can check your troubleshooting. For example, logs provide insight into the behavior of errors of application. You can search the logs to identify problems and trace their origin. Then, data from logs can be used to analyze the app's performance, availability and usage patterns. Metrics and alerts can help track performance. You can also audit and compliance these logs. So, these logs provide a full audit trail of system activities and changes. This supports security and compliance requirements. Log analysis helps identify optimization opportunities to reduce cost. You can use this for system debugging, like servers and instance logs allow you to diagnose unexpected behavior, resource bottlenecks, and configuration problems. Also, if there is some incident, you can use these logs to allow for the reconstruction and analysis of the events that led to incidents such as an outage. CloudWatch Logs provide a centralized and scalable solution for managing and analyzing log data in the AWS cloud, enabling users to gain valuable insight into the behavior of their application and structure. Amazon Event Bridge is a serverless event management service that simplifies the creation of event-driven applications on AWS. It allows you to connect applications to data from a variety of sources, including AWS services, some SaaS applications, and your custom applications. Event Bridge acts as a central nervous system for your application, routing real data streams between different services and components between and based on defined rules. Event-driven architecture is a pattern of software design where systems are built around producing, detecting, and responding to events. Instead of making direct calls between components, one component broadcasts an event when something happens, and the other components listen to and respond to those events. This creates a loose coupling, improves scalability, and enables asynchronous communication between distributed systems. It is particularly useful for building fast, resilient systems where components can be developed independently. It provides a central place to manage event data and eliminates the need to write custom event management code, making it easier to build event-driven applications. Event Bridge supports a wide range of data sources such as Amazon S3, Amazon Kinesis data streams, Amazon DynamoDB, Amazon CloudWatch, Amazon Simple Queue Service, or SQS. With Event Bridge, businesses can quickly process and route events from any source to any destination. Event Bridge pricing is primarily based on the number of events posted or entered, along with optional cost for features such as a schema registry and inter-order event business. Event entry and delivery. You are charged per million events posted on your event bus. At the time of this writing, the cost is $1 per million events for the first 100 million events per month on the default bus. This includes targeting and delivering to one or more targets. Custom event buses have the same cost per event as the default bus, but are useful for logically separating events between teams or applications. Also, we have something called schema registry. If you use this schema registry feature, you will pay based on the number of events detected and the storage of the schema. This feature helps developers to automatically understand the structure of events. Also, cross-region and inter-account bus delivery. These advanced use cases may incur additional data transfer cost depending on your setup. So, if your system broadcasts 5 million events per month and each is one routed to a single Lambda function, you'll be paying about $5 per month for Event Bridge itself, plus all the costs for targets such as Lambda calls. Finally, the benefits of Cloud Event Bridge is easy connectivity. So Event Bridge simplifies the process of connecting different applications and services, enabling seamless communication and data transfer. Event Bridge is a serverless service, so you don't have to worry about managing your infrastructure. This means that you can focus on building your applications and let Event Bridge take care of underlying infrastructure. Also, Event Bridge allows you to transfer events between different AWS accounts and regions, so it is a cross-account and cross-region capabilities, allowing for greater flexibility and scalability. It is also cost-effective, so with Event Bridge, you only pay for what you use. It has no upfront cost or long-term commitments, making it a cost-effective solution for a data event-driven architecture. Also, Event Bridge supports a variety of targets, including AWS Lambda functions, Amazon S3 buckets, Amazon Kinesis workflows, and Amazon Step functions, allowing you to route events to the right place to be processed. Also, Event Bridge provides a central place to manage your event data, making tracking and monitoring your events more accessible. Event Bridge is also integrated with a variety of SaaS applications, making it easy to transfer events between them and your own application or services. Key features of Amazon Event Bridge. We have something called Event Bridge, of course. Event Bus is the core of the Event Bridge. It receives events from AWS services, custom application or SaaS providers, as we already know, and directs them to the right goals based on the defined roles. You can use the default bus, create custom buses for a specific domain, or receive events from other AWS accounts. Event Bridge pipes simplify integration between event sources and target by providing built-in filtering, transformation, and enrichment capabilities. They reduce the need for custom code when moving data from services such as SQS or Kinesis to Lambda, step functions, or other targets. And also we have something called planners. The scheduler feature allows you to run actions at specified time or intervals down to seconds. It's ideal for scheduled tasks, delayed events, or time-based workloads without the need for a special cron service. Finally, we have something called a registry scheme. A schema register records and stores the structure of events or schemas as they pass through Event Bridge. This helps developers understand the payloads of event, automatically generate code links, and improve validation for event consumers. Also, you have something called playback. So replays allow you to rework past events by placing or replaying them through your Event Bridge rules. This is useful for recovering from downstream process failures, testing changes, or system replenishment without modifying the manufacturer. So how this service works? First, your application, SaaS products, or AWS service generate events and send them to the Event Bridge. This is called event sources. Then with the Event Bus, this service receives these events and stores them on the Event Bus. Also, You must configure rules to filter and route events based on their attributes. And finally, when an event matches a rule, Event Bridge sends the event to a specific target for processing. This is our goal. Event Bridge is a powerful and versatile service in Amazon that simplifies building event applications of AWS, promoting loose connectivity, scalability, and reduce operational complexity. AWS Cloud Trail is a service that provides a record of users, activity, and API usage within an AWS account. It records events related to actions taken by users, roles, and AWS services, including those performed through the AWS Management Console, AWS CLI, and SDK. This allows you to audit, manage, and monitor the compliance of your AWS environment. So, you can use this service for your API activity logging. So, CloudTrail logs API calls made to AWS services, recording information such as the user or role that made the call, timestamp, source IP address, request parameters, and service response. You can also use this for event history. So CloudTrail provides a clear, searchable, downloadable, and immutable record of management events for the last 90 days within each AWS region. You can create traces to record events after 90-day event history limit. Traces can be configured to deliver logs to Amazon S3, CloudWatch logs, and Event Bridge. Also, CloudTrail is essential for meeting regulatory compliance requirements such as GDPR or HIPAA, and for security auditing allows you to monitor changes, detect unauthorized access, and ensure proper use of IAM. You can use this service and analyze CloudTrail logs, and then you can use this for troubleshoot operational issues. So you can identify and resolve operational issues such as misconfigurations of resources or unexpected behavior. Also, CloudTrail integrates with other AWS resources or services such as CloudWatch for tracking and alerting, and can be used for security monitoring solutions. Essentially, CloudTrail acts as a comprehensive audit trail for your AWS account, providing valuable insight into users' activity and helping you maintain a secure and compliant environment. Once again, we are in our console, and let's type CloudTrail in our search bar. So you can track user activity and API usage with this service. Let me click on CloudTrail. As you can see, this is a service that you can use for different purposes, and here you can meet your governance, compliance, and auditing needs for whole of your AWS resources. Here you can create your dashboard, or you can view your dashboard. You can create a trail, and you can see our event history. For example, when we work with SNS service, there was a trail. Also, if you go this on the blade event history, you can see that all events that this is our event history in the last 90 days of our management events, as you can see. So if you go inside this event, you can see the details when this event occurred, username, this is our root username, event name is delete topic, so this was deletion of sns.amazonaws.com event source, and you can see what is our access key, what is our source IP address, event ID, request ID, in what region did we delete this SNS service, and read-only is false. Also, this is our resource name, and also you can enable AWS configure for resource recording. Also, we have this event records in JSON view, so here you can see completely record in JSON view, and you can also copy this event if you want. If I scroll down, you can see that this is a delete topic. And finally, this is just of one event in our CloudTrail, of course. So this is only a read call. As you can see, event type is AWS API call and the status is deleted. If you go back to our event history, if I scroll down, you can see various dates. And for example, if you remember when we create our bucket, this is the different my IP. Event name was create bucket. Username is root. So me as a root user, this is my credentials. So this is our resource name, our ARN, and once again, complete JSON file of this event. Of course, you can look up attributes, so you can filter this even more. For example, you can check your AWS access key. You can select event ID, event name, event source, resource name, resource type, or by username. If you have more users in this account, then you will use this username. Finally, in the next search, you can enter your name. Then, for example, let's find our event source. So here, for example, event name, we can enter an event name, and there is a lot of event names, as you can see. For example, let's find EC2 or something like that. As you can see, activate EC2 remote. We don't have any event for this log. And finally, we can use our event ID, but for that we must know our event ID. And for example, if we go to our read only, we can see our event name. For example, there is a list discover resources, as you can see. And once again, our event ID, I will copy this event ID of this event. And finally, we will now look up attributes. Let me check my event ID, and I will now paste this event ID. And finally, you can search thanks to this filter. Now I will clear my filter. You can also download these events as JSON file or as a CSV file. If I download this as a CSV file, you can see how many events are fetched. And after fetching these events, it will be automatically downloaded to my desktop. Then I can open this CSV file in Excel, of course. CSV stands for comma separated value file. And finally, as you can see, the full download can take us several minutes. It really depends on the source. So I will simply cancel this, and this document will be download here automatically. And as you can see, if I open my Excel, there is event history and all events from my AWS account from previous 90 days. There is more than 3081 event. And also you can use something called Athena service, and you can also query in that service one of these events. Finally, our cloud trail, as you can see, is more than simple service. You can also create a trial if you want. If I click on create trial, we need to add some trial details, and you can set it up for multi-regional. You need to add your name, choose a storage location. You can create a new bucket from here or add existing one. For example, we will add a name here, and finally this will store your logs in that bucket, and of course this name must be globally unique. Also, you can log file with encrypt your log file with SSA KMS encryption. You can choose customer managed AWS key if you want. You can create a new one or use existing one. And there is also something called log validation. It is enabled, and SNS notification discovery, so you can enable this simple notification service to be notified. Also, you can configure to CloudWatch logs to monitor your trail logs, and you have options to be notified when with specific activity occur, of course, then you will enable this and all CloudWatch logs will be sent there. In the next step, we need to choose our log events. Let me add some random name just to go to our next page. And of course, we need to add some KMS key. This will be some random name. And here in the second step, we need to choose our events and record our API activity for individual resources or for all current and future resources in this AWS account. So you can choose between event type like management groups, data events. This will log the resource operation performed on a resource. Insight events, you can identify unusual activity errors in our account, and network activity. So network activity events provide information about resources operation on this resource within the virtual private cloud endpoint. So this is possible also, sorry. And you can choose management event if you want to read or write activity. Finally, in the next step, you can review and create all your settings and you will create your trail. So this is how can you create a trail in our cloud trail option. And then we have our insight and so on. So this was a little tour about CloudTrail service in AWS. So before we finish this section, I would like to introduce you to some more services. The first one is AWS X-Ray. This service helps developers or users to analyze and debug distributed applications, especially those built using microservices architecture. It provides a complete overview of requirements as they travel through your application, helping you identify performance bottlenecks and pinpoint the cause of errors. AWS X-Ray collects data from your application and from AWS services that are integrated with X-Ray. This involves collecting data for both incoming and outgoing requests, as well as other significant events within your application. Each trace includes metadata about the request. To enable tracking, your app must be instrumental to send this tracking data to X-Ray. For many scenarios, this may only require configuration changes. For example, if you have Java applications that can be configured to instrument all incoming HTTP requests and downstream calls to AWS services, AWS provides various SDKs, agents, and tools to facilitate this instrumentation. Some AWS services, such as AWS Lambda, and pre-integrated with X-Ray. These services can add tracking headers to incoming requests and send tracking data to X-Ray. AWS Lambda also automatically runs an X-Ray daemon on its workers, simplifying the use of X-Ray SDK. Instead of sending trace data directly to X-Ray, the client SDK sends JSON segment document to the X-Ray daemon, which listens to UDP traffic. This daemon buffers these segments in order and sends them to X-Ray in batches. The daemon is compatible with Linux, Windows, macOS, and is included in AWS Elastic Beanstalk and AWS Lambda environments. Using the trace data collected from your AWS resources, X-Ray then generates a detailed trace map that illustrates the interaction between your customer, front-end services, and back-end services involved in request processing and data storage. This trace map helps identify performance bottlenecks, latency issues, and other performance issues to optimize application performance. The price of AWS X-Ray is primarily based on the number of tracks captured, downloaded, and scanned. A trace is a request to your application and can contain multiple data points, such as calls to other services and database access. AWS also offers a free tier, which includes 1 million tracks recorded and 1 million tracks downloaded each month for the first year. In addition to the free service or free tier, the price is based on the amount of tracks processed, with cost varying depending on the region. So, for example, you have some examples on the internet if you are using US North Virginia. AWS X-Ray simplifies the process of understanding and troubleshooting complex distributed applications by providing a comprehensive view of the behavior and performance or requirements. Also, this is how this works. First, in the AWS X-Ray, you can, as you can see, analyze and debug modern applications built by using microservices and serverless infrastructure and quantity customer impact. Then first it will collect all traces. It will collect data about the request from each of the underlying application services and pass it through. Then in the record traces, it will combine data gathered from each service into a singular unit called traces, and then you can view service map. So view the service map to see trace data such as latencies, HTTP statuses, and metadata for each of your service in your account. And finally, the last step, we will get analyze issues, so we can drill into a service showing unusual behavior and identify the root of this issue. Amazon Code Guru is an AWS developer tool that uses machine learning to analyze code and improve code quality and performance. It helps developers to identify bugs, security vulnerabilities, and performance bottlenecks in their Java and Python applications. Code Guru has two main components, the reviewer and the profiler. The first one is component that analyzes your code repositories for potential issues such as security vulnerabilities, resource leaks, competitiveness issues, and deviations from AWS best practices. It provides automated code reviews as recommendations as part of your pull request. Secret Detector is a feature of Code Guru Reviewer, helps identify hard-coded secrets like passwords and API keys in your code. And then we have Code Guru Profiler. This component analyzes the performance of your applications during execution in production. It identifies the most expensive lines of code, performance bottlenecks, and areas where your code contributes to excessive CPU usage. Code Guru Profiler provides visualization and recommendation to optimize application performance and reduce operation cost. Also, this service has its own architecture, so the architecture is built on scalable and reliable AWS resource services. It uses a combination of machine learning models, data processing, and analytics to provide intelligent code review and performance profiling. Here is a more simplified overview of the architecture. We have first data collection. Code Guru Profiler collects runtime performance data from application deployed on AWS or on premises. This data is sent to this Code Guru service backend system for analysis. Then we have something called profiling. The data collected is processed by Code Guru profiling engine, which uses machine learning algorithms to identify resource consumption patterns, hotspots, and performance bottlenecks. Then we are using something called recommendation generation. Code Guru Reviewer analyzes code changes using static analytics or analysis and machine learning models. It generates contextual recommendation to improve code quality, eliminating potential errors, and adhere to best practices. And it also integrates seamlessly with popular IDEs, including IntelliJ IDEA and Eclipse, allowing developers to directly view recommendations in their development environment. It also provides integration with AWS Code Commit and GitHub, allowing for easy integration into existing workflows. Essentially, Code Guru helps developers to write better, more efficient, and more secure code by automating code reviewers and providing performance insight using a machine learning. And here it is, as you can see, this is our Code Guru. For example, if you run your Code Guru, first you will write your code, then you will review your code. If you want to review your code, you will use this Amazon Code Guru Reviewer, and then you will use your profiler to test your app. Once that your app is tested and you are satisfied, you will deploy your app, and then you will run your app. But before you run your app, you will also use this Code Guru Profiler, and you will analyze how your app work. So this is another great service for monitoring in AWS. The AWS Service Health Dashboard is a publicly available website that provides information of current status and historical data for all AWS services. It is a tool that allows anyone to check the availability of AWS services in different regions. For AWS account holders, the AWS Health Dashboard is available within their AWS console, and it offers a more personalized view, including account and organization-specific events, schedule changes, and notifications. So with the public Service Health Dashboard, This purpose of this service is to display the general status of AWS services, allowing users to see if any services are experiencing any issues. This is available to everyone, regardless of whether they have an AWS account. It provides information about the name of the event that affected this region, the name of the service, and the recent updates. So no login is required, so you can access this dashboard without having to log into your account. AWS Health Dashboard is account specific. Purpose of this is to provide a personalized overview of your health of the service, including event specific to the user's AWS account or organization. AWS account and login are required. For accessibility information, it includes open, recent, and scheduled changes, along with notification and an event log for the last 90 days. And for users within AWS organization, the dashboard can also display organization-wide health events. It integrates with services such as Amazon Event Bridge to enable more advanced tracking and automation. It also allows users to customize their tracking and alert based on their specific needs. If you go to our console and type dashboard, you can see that we have AWS Health Dashboard. Here, inside this service, you can see all this account health. So, you can use even this Amazon Event Bridge rule to get notification for events that might affect our services and resources. And here we can see open and recent issues. We have scheduled changes and other notifications, of course. And here you will, in the schedule changes, you will see upcoming events and outgoing or ongoing events in the past 7 days that might affect our or my AWS infrastructure, such as scheduled maintenance activities. In the other notifications, you will see other notifications, and here in the event log, you will see all event log, for example, for this region, as you can see. For example, we have operational issue with App Runner in Singapore region. This is AWS Health Dashboard is a global service. Then we have some operational issues with Athena service in Oregon. It is closed, as you can see, when this started and the last update date. If you click on one of these, for example this first one, you will see description and the status is resolved, and detailed explanation about all these events that occurred, these problems with some services, as you can see. So you will see exactly time when this problem started, this operation issue started, and when it is resolved. Also, if you have some resources in that regions, then this is a good place to see all your operational issues. For example, this is for Athena, Oregon, and all of these are closed because this was not particular big problems or big operational issues. So you can see that, for example, there is internet connectivity network latency between the US East 1 and US East 2 regions, and this is in Ohio. We have operational issues in Tokyo, for example, and here, as you can see, there is 7 services that was affected with these operational issues. So there is really a lot of events that you can track here. And if you go to service history, here you will see that all services on the day of this recording, and all services is working, and you can track it by day. You can see the list of services, or for example list of events. You can see where is located. For example, this is for North America, and you can also check your date. So the following table is a running log of AWS service interruptions for the past, for example, 10 months, and simply choose a status icon to see the status updates for all of these services. So this is another useful information to check your status with this dashboard. The green is good. That is the main point. Thank you for watching, and I hope this was helpful. Also, you can list events on this service history for this region. So once again, AWS internet connectivity was a problem in Ohio in June 11th, and you can see what services are impacted. This was Amazon Elastic MapReduce, for example, and so on and so forth. So there is a lot of options that you can use and choose from these services. Also, in another notification, you can use this dashboard to stay informed of important events that affecting your AWS resources. Thank you for watching, and I will see you in the next lesson. The AWS Personal Help Dashboard is a service that provides a personalized overview of the health of your AWS resources and services. It offers alert and guidance for events that may impact your AWS environment, helping you proactively manage potential issues and maintain operational excellence. The key feature and benefits if you're using AWS Health Dashboard, it has personalized view. So the dashboard displays events specific to your AWS account and organization, if applicable, providing a customized view of the services and resources that you want to use. Also, you can provide a continuous visibility into the performance and availability of your AWS services, and resources, with near instantaneously visibility of events. So it has some kind of real-time information. Also, there is an option for alerts and notification. So in the dashboard, you can send alerts and notifications that are triggered by changes in the state of your resources, helping you to stay informed of potential issues. Also, it offers a guidance and recommendation to help you understand the impact of events and take appropriate action to address them. Also, you can view a comprehensive event log of all past events up to 90 days to understand the history of events and that have impact your account. As you can see, this is just an example of how this AWS Health looks like. So as you can see, there is a lot of graphic and information that you can track on this AWS Personal Dashboard. Of course, AWS Personal Help Dashboard has a great integration with AWS organizations. So the dashboard supports events related to your organization in AWS organization, allowing you to manage events that affect multiple accounts. So if you have more than one account, then you can integrate them into AWS organization and use AWS Personal Health Dashboard for all these accounts. Also, for customers with AWS Business or Enterprise support, the AWS Health API provides programmatic access to data, allowing for integration with your existing IT management tools. Also, by providing timely alerts and guidance, the dashboard allows you to identify and resolve potential issues before they impact your application or businesses. Also, early detection and troubleshooting can help minimize downtime, and maintain the availability of all your services. And also, it has improved operational excellence. So, with this dashboard, you can optimize your business by providing insight into the health of your AWS environment and allowing you to take corrective action. Essentially, this AWS Personal Health Dashboard is a key tool for any AWS user who wants to maintain a healthy and reliable cloud environment. Well, now it's time to learn finally what is virtual private cloud, and in AWS, of course, or VPC, and here I will talk about subnet also. Well, Amazon Virtual Private Cloud, or VPC, is just a logically isolated part of the AWS cloud that allows you to run AWS resources in a virtual network that you define. It provides a private network within the AWS cloud, similar to a traditional local area network, but with the scalability and flexibility of the cloud. Amazon VPC, or Amazon Virtual Private Cloud, is a service that allows its users to run their virtual machines in a protected as well as isolated virtual environment defined by them. You have complete control over your VPC, from creation to customization and even deletion. It is applicable in your organization where data is scattered and needs to be well managed. In other words, VPC allows us to choose the virtual address of our private cloud, and we can also define all the subcomponents of VPN of ourselves, such as subnet mask, availability zone, etc. We can set up the necessary resources and manage access to those resources in VPC, a private part of Amazon that we control. A default VPC, of course, there is a mistake. We don't need the first letter is V, not W, will be generated when we register in an AWS account, which allows us to manage the virtual network environment, IP address, subnet construction, route tables, and gateways. As already said, when you open your account, by default, AWS will create default VPC in all regions that you are using. Also, VPC behaves like a traditional TCP/IP network that can be expanded and scaled as needed. However, the domain controller components you are using to working with, such as routers, switches, VLANs, etc., do not exist explicitly in VPC. They have been abstracted and redesigned into cloud software. Using VPC, you can quickly boot into a virtual network infrastructure where AWS instances can run. Each VPC defines that your AWS resources need, including IP addresses, subnets, routing, and security. So let's talk about network functionality. All VPCs are created and exist in one and only one AWS region. AWS regions are geographic locations around the world where Amazon groups its data centers in the cloud. This kind of advantage of regionalization is that a regional VPC provides network services originating in that geographical area. If you need to provide closer access for customers in a different region, you can set up a different VPC in that region. Also, this fits very nicely with the theory of AWS Cloud Computing, where IT applications and resources are delivered over the internet on demand and pay-per-use pricing, of course. Restricting VPC configurations to specific regions allows you to selectively deliver network services where they are needed, when they are needed, of course. Each Amazon account can host multiple VPCs. Because VPCs are isolated from each other, you can duplicate private subnets among VPC in the same way that you could use the same subnet in two different physical data centers. You can also add public IP addresses that can be used to access instances triggered by VPC from the internet. Also, as I already noticed, Amazon creates one default VPC for each account, along with default subnet, routing tables or route table, security group, of course, that is security group. On the other hand, the action control list. You can also modify or use that VPC for your cloud configurations, or you can create a new VPC and associate services from scratch. VPC administration is done through these AWS management interfaces. The AWS Management Console is a well-based interface for managing all AWS functions. Of course, I forgot to add this image, but you already know this. Also, AWS Command Line Interface CLI provides Windows, Linux, and macOS commands for many AWS services. AWS often provides configuration instructions as CLI commands, and also the AWS Software Development Kit, or SDK, provides language-specific APIs for AWS services, including VPCs. You can also query APIs, so low-level APIs actions can be sent via HTTP or HTTPS request. And for more information, go to official AWS pages and just check EC2 API reference. Well, VPC network service includes IPv4 and IPv6 address block, creating a subnet, route tables, internet connection, elastic IP addresses. We already learned how to work with IP addresses, network security or subnet security, and additional online services. Running a simple EC2 instance operate within a specific VPC subnet, sometimes referred to as running an instance in a subnet. For IP addressing, decider of each subnet contains a subset of VPC CIDR block. Each subnet isolated its individual traffic from all other VPC subnet traffic. A subnet can contain only one CIDR block, so you can specify different subnet to handle different types of traffic. For example, instances or a file server can run on one subnet, web and mobile application can run on another subnet, print services on another, and so on and on. Of course, we really learn about subnets when we talk about Azure, and here we are using this knowledge to understand how VPC work in AWS. Also, routing tables contain rules or routes that determine how network traffic is routed within your VPC and subnets. VPC creates a default routing table called the main routing table. The main routing table automatically connects to all VPC subnets. Here you have two options. First, update and use the main routing table to route network traffic, or you can create your own routing table to use for the traffic of individual subnets. To access the internet, each VPC configurations can host a single internet gateway and provide network access translation or NAT services using an internet gateway, NAT instances or NAT gateway simply. Also, elastic IP address are static public IPv4 addresses that are permanently assigned to your AWS account, and APs are not offered for IPv6. This is very important. So, elastic IPs are used for public access to the internet to instance, AWS Elastic Network Interface, this is our network card, other services that require a public IP addresses, so you can assign elastic IP for long-term continuous use of this network. Before you start configuring your VPC, you need to take a look at Amazon Shared Responsibility model. According to Amazon, security and compliance are a shared responsibility between AWS and its customers. For your AWS account and configurations, AWS is responsible for cloud security, while customers are responsible for cloud security. Generally, AWS is responsible for the AWS cloud infrastructure, like hardware, cloud software, networking, facilities that powers these AWS services. Customers or us are responsible for what they run in the cloud, such as servers, data, encryption, application, security, access, operating system, etc. Finally, the shared responsibility model determines who is responsible for certain issues when you experience an AWS downtime, security breach, or loss of business. It's important to understand these limitations while setting up your AWS or VPC configuration. So, if you remember, when you create your account, you get default VPC. In that VPC, you will place your instance. And imagine that there is some outage in some data center where you host your machine. Then this is AWS responsibility. And you will get some kind of compensation in money or some other. It really depends on type of outage. Then key components of VPC. First, we have subnets. So subnets is just a string of IP addresses in your VPC. You run your AWS resources, such as EC2 instances, into that subnet. Then we have gateway. Gateway connect your VPC to other networks. For example, an Ether gateway allows your VPC to access the internet. Then we have route table. Route tables route network traffic inside and outside your VPC. We have security group. Security group acts as a virtual firewall, control traffic to and on from your instances. We have something called VPC peering, allows you to connect two VPC together, allowing communication between them using private IP addresses. And as you can see, here is some basic infrastructure. Let me just grab my pen and I will explain this more. Here, as you can see, this is our region. So, example, this is North Virginia region. In that region, we have, of course, North Virginia has 6 availability zones, but imagine that we have 3 AZs. In that AZ, we create one VPC, for example, by default, in this region. And then, in that VPC, we have automatically 3 subnets. And now, imagine that in these availability zones, I want to, for example, add a set of instances that will run my application. This set of services or instances will run, for example, DB or databases. And here is just my jump server, for example. And finally, these machines are located in something that we call subnets, of course. And if you want that this machine have connection to internet, then you will use something called internet gateway. So with internet gateway, we are allowing this machine to have access to internet. But with our security group, we can define rules, and that rules will be inbound or outbound rule. And finally, in the route table, you can define your route to the internet. But this is just a simple explanation. Let's go to the next chapter and learn more about virtual private cloud or VPC and subnets in our AWS cloud provider. If you go inside our console and if you type VPC, you can see that we are getting our service, and VPC is just isolated cloud resources. Let's go inside our VPC, and we are now, as you can see, in our dashboard, and you can see resource by region. So we are using North Virginia as our default region, and here we have one VPC. This is all default VPC, as you remember. If you choose some of this other region, then you will get another information. And then we have 6 subnets for this region, as you can see, and here there is a list of all regions and how many subnets you have in each of them. So for example, we have 3 in United States, Ohio, 2 in North California, for example, 3 in Asia Pacific, Mumbai, 3 in Asia Pacific, Osaka, 4 in Seoul, 3 in Singapore, 3 in Sydney, 3 in Tokyo, 3 in Canada Central, and so on and so forth. Then we have Europe, of course, all 3. In London we have 3. And the only one with 2 is for now in US North California. If I click on this number 6, you will get to the new window, and here there is a subnet listed, and all this VPC has its own subnet. And of course, all these availability zones has its own subnet. If you go, for example, in another VPC, for example in Ohio, you will see that we have another subnets. Then, as I already told you, you can see the number of VPC in all regions. By default is 1. This is all our default VPCs in all of our regions. And here you can list all route tables. Of course, there is a one route table. This is all default route table in all of these. And this is our route table. As you can see, we have these 2 default routes. The first one is destination is internet, and we are using our target. This is our internet gateway. And the second one is local one, and all local traffic is active, as you can see. This is our routes in our default route table. And just to finish my story, all these default VPCs, subnets, route tables, internet gateways are created by AWS and by default. Let me go to our VPC dashboard once again. If I click to internet gateways, as you can see, in North Virginia we have 1 IG, and all these regions here also have 1 IG. Also, we have egress only gateway. Internet traffic there is 0, and all others, endpoints, instance connect endpoints, endpoint services have, and net gateways, we don't have any peering connection. We have action control list, network action control list. By default, this is a 1. Let me open this in a new tab, and here is our network ACL, and this is associated with all 6 subnets. Here we have security group, of course. If you open this in a new window, you can see that this security group is default and is associated to our VPC. We don't have any customer gateway, virtual private gateway, site-to-site VPN connection, or running instances. So we don't have anything. Just like that, you can create a new VPC right from here, and here there is two options. You can create VPC and create this automatically if you choose this AWS network, and you can choose only VPC. Here you need to add a name. For this, choose your IP CIDR option. This is IPv4 CIDR manual input. So we'll, for example, add 10.0.0/24, and you can also add IPv CIDR block for IPv6. And simply choose our tenancy. It will default or on dedicated. Dedicated is paid option. And finally, if you want to use tags, simply click on tag. If you choose this other version, you can see that this will auto-generate our VPC. There will be two subnets, one in EastUS 1A and 1B. Then it will create, as you can see, one public and one private subnet, and here route tables will be one private and one subnet and one IG. So if you have option to deploy this automatically. You can choose your availability zone, number of public subnets, number of private subnets. You can also include NAT gateway, but NAT gateway is a paid option, and you can choose also the number of availability zone in which you can create NAT gateways. Finally, you can use VPC endpoint. So endpoints can help reduce NAT gateway charges and improve security by accessing S3, for example, directly from VPC. And also you can enable DNS hostnames and DNS resolution. So this is more granular option, and you can see. And now I will add a tag for my simple VPC. Let me add some CIDR name, IPv4 10.0.0/24, for example. And finally, let me you can remove or edit this tag and simply click on VPC. And just like that, we created a new VPC. And now in this VPC, you can see that we don't have any network connection, routable traffic resource, and we don't have any subnets, of course. Here you can see actions. You can create something called flow logs, delete this VPC, manage tags, edit VPC settings, edit your CIDR if you want, and manage middle box route. And here, if I type delete, this will delete our VPC. So as a first example, I just want to show you how can you create your VPC. And as you can see, there is only a few clicks that is necessary to create this. Also, if you click on global view, you can see all EC global view, and if you go to VPC dashboard, there is also an option to launch an instance directly from here. If you open this in a new tab, you can simply scroll down, and as you already know, you can edit your network settings, create this. When you create new network, you can choose to run this network. Also, this is our default network. You can create a new subnet from here, or choose these 6 that we have by default. You can enable or auto-assign public IP address, enable or disable, choose existing security group, or create a new one. And finally, here you can set up your inbound security group rules, remove them, and so on and so forth. So this is just a simple view on VPC and subnets in our AWS service. It's time to learn more about route table, internet gateway, and NAT gateway. Well, routing tables within the VPC are used to route network traffic, including traffic designed or destined for the internet. By connecting the routing table to the IGV or internet gateway and configuring the appropriate routes, you allow instances in the subnet to access and be accessed from the internet. First, we have something called internet gateway. IGV, in short, is a horizontally scaled, redundant, and highly available AWS component that acts as a gateway between your VPC and the internet. It allows instances in your VPC to connect to the internet and allows inbound traffic from the internet to your VPC, providing that routing is configured correctly. Then we have a routing table. Routing tables are used to control the routing of network traffic within your VPC. Each routing table contains a set of rules or routes that determine where network traffic should be routed based on its destination IP addresses. When you create a VPC, the main routing table is created automatically. You can also create custom routing tables for more accurate traffic management. A route in a table or a routing table consists of a destination and IP address range such as 0.0.0/0 for all IPv addresses, and a destination like IGV, NAT gateway, VPC pairing connection, or VPC connection. Then, enabling internet access. You need to enable internet access, of course, and if you want to provide internet access for a subnet, for example, you need to connect it to a routing table that has a route that routes traffic destined for internet. This is 0.0.0/0 to IGV, to internet gateway. If a subnet has a route to IGV, it is considered a public subnet. If its subnet does not have a route to IGV, it is considered a private subnet and cannot directly access to the internet. Then we have gateway routing table. Gateway routing table are routing tables associated with an internet gateway or virtual private gateway. They allows you to intercept and redirect traffic entering your VPC through the gateway, potentially to intermediate devices such as security devices. You can use gateway routing to implement more complex routing scenarios. Essentially, IGV provides a connection to the internet, and the routing tables determine how many traffic flows to and from IGV and other destination within your VPC. NAT gateway is just a network address translation or NAT service. You can use NAT gateway so that instances in a private subnet can connect to services outside of your VPC, but external services can't initiate a connection to those instances. Finally, when you create a NAT gateway, you must specify one of the following connection types. First, it is public by default. Instances in your private subnet can connect to the internet via public NAT gateway, but instances cannot receive unwanted incoming connection from the internet. Also, if you create a public NAT gateway in a public subnet and you need to associate an elastic IP address with the NAT gateway, when you create it, you are directing traffic from NAT gateway to internet gateway for VPC. Alternatively, you can use a public NAT gateway to connect to other VPC or your local network. In this case, you are routing traffic from the NAT gateway to a transit gateway or a virtual private gateway. Also, we have private connection. Instances in a private subnet can connect to other VPCs on your local network via private NAT gateway, but instances cannot receive unwanted incoming connection from other VPC or the local network. You can also route traffic from a NAT gateway to a transit gateway or a virtual private gateway. You can't associate an elastic IP address with a private NAT gateway. Also, you can connect a VPC internet gateway to a private NAT gateway. But if you route traffic from a NAT gateway to an internet gateway, the internet gateway will discard traffic. The NAT gateway is intended for use with IPv4 and IPv6 traffic using DNS64 and NAT64. Another option to allow only outgoing internet traffic communication over IPv6 is to use only the outgoing internet gateway. Both private and public NAT gateways map the original private IPv4 address of the instance to the private IPv4 address to the NAT gateway. But in the case of public NAT gateway, the internet gateway then maps the private IPv4 address of the public NAT gateway to the elastic IP address associated with that NAT gateway. When sending a responsible traffic to instances, whether it's a public or private NAT gateway, the NAT gateway translates that address back to the original source IP address. So, it may sound a little bit confusing, but trust me, it's very easy to work with a route table, internet gateway, and NAT gateway. Just, you must know the difference between these three. Thank you for watching. And once again, we are in our console. Let's go to our VPC. we are in our North Virginia region, and as you can see, this is our North Virginia, just to remind you. And as you can see, we have these default options. I don't have any other resource, and we have, as you can see, one route table, and one internet gateway, and you can see all other settings. And we have one network ACL, security group is one, and one VPC, of course, and 6 subnet. If we go to to route tables, you can see that we have our default route table. I will now go to the routes of that route table, and you can see that we have our destination that is attached to our target, and as you can see, this is active. This is default route to the internet. So, and this is using for local. This is our CIDR of our, as you can see, if I go to subnet, for example, this is our subnets, and you can see the IPv4 CIDR for all subnets. Let me now go back to our route table, and if I click on actions, you can also view details, edit subnet association, edit edge, edit route propagation, and so on. Finally, let me go to actions, and you can also edit subnet association, so you can change which subnet are associated with this route table. Also, our subnet is associated, and simply click on save. Also, you can edit these routes. You can edit local traffic, so here you can choose your target as an instance, network interface, or gateway load balancer endpoint, and you can also remove this route. I can add a new route if I want. For example, from this list I can choose a different route, then I can choose my target. There is a lot of target, and simply click on save changes. Of course, you must add a port, and here you can also edit your route. This is exactly the same thing, or simply go and delete this if you want. Now, if I go to route tables and click on create route table, I must add a name for this route table, and then simply associate to my VPC. And if I click on create, this will be created. So if you go to NAT gateways, here you can create a new NAT gateway. Let's create a new NAT gateway. First, we need to provide a name, then to select our subnet. This is our default subnet. Then connectivity type, you can choose between public and private. Finally, you will allocate your elastic IP address here. Then you must click allocate elastic IP, and this address will be added from the available pool of AWS public IP addresses or elastic IPs. And in the additional settings, you can also choose your primary private IPv4 if you want, and simply click on create NAT gateway. This is how can you create your NAT gateway. If I go to subnet and simply click on create subnet, I can choose my VPC. This is my default VPC. Here you can see that what is our CIDR range, and from here I can choose my availability zone if I want, choose my CIDR block, and here I will specify my IPv4 address, and you can also create a new subnet, more than one subnet in one creation. And finally, as you can see, we have a lot of options, but understanding these fundamentals is very important to understand how networking work or how VPC work in AWS. Finally, as you can see, this is our subnets. We have 6 subnets in this region, and all these subnets are attached to our VPC. Finally, you can see what is IPv4 CIDR for all of this subnet. And if you go to our internet gateway, this is our default internet gateway. It is attached to this VPC. And finally, you can also attach or detach from VPC. And finally, you can see who is the owner, and this is our account number. And this is, of course, our IGV ID. All these resources starting with IGV, for example, and then your ID, Then if you go to, for example, VPC, there is VPC dash and so on, your ID. Finally, if you go to our region explorer in our global view, you can see after fetching how many regions we have and how many VPCs do we have in each of this region. As you already know, it is easy and very easy to create our VPC. You can use VPC only. You need to provide your name, choose IPv4 or IPv6, for example, or if you want to add more, create all these necessary resources in one hand, you can use this option and create not only VPC, just subnets and route tables. Also, let me just show you how can you create internet gateway. Simply add a name for your internet gateway, click on create, and then go to action and associate this internet gateway. We have also create internet egress only internet gateway. This is a virtual router that connects a VPC to the internet. Simply choose a VPC, add a name, and you will create egress only internet gateway. Also, we have carrier gateway, but we need to find our wavelength VPC. This is our 5G for 5G networks, and simply a carrier gateway provides connectivity to the carrier network for resources, for example, AT&T, and that's it. Then we have DHCP option sets, our elastic IP. You can add your prefix list here. As you can see, this is our domain name, and with this DHCP you can create this again, but DHCP is simply using for adding private or IP addresses as a router to your new VPCs and so on. And we have also elastic IP. As you can see, we have manage prefix list. You can allocate elastic IP. Simply click on allocate, choose your from Amazon pool of IPv4 IP addresses, choose your network border group and simply click on allocate. And finally, this manage prefix list. Here you will find your whole prefix list, and you can also create your list. And then we have route servers, and that is not a part of this course. Just wanted to show you all these other options, so we learned really a lot. Thank you for watching. Now it's time to learn what is network ACL and security groups and what is the difference between these two options in VPC. But first, AWS Network Access Control List, or NACL, is an optional security layer for your virtual private cloud, or VPC, that acts as a stateless firewall to control traffic in and out of subnets. It defines rules for incoming and outgoing traffic, allowing or denying access based on factors such as IP address, port, and protocol. You can create also a custom NACL according to your requirements. These NACLs define the inbound and outbound rules for the subnets present in the VPC. These NACLs also have almost the same functions as security groups. The only difference is that network ACL works at the subnet level, and the level security groups are defined for instances and other resources. So this is the main difference. Well, key features of network ACL is stateless. Unlike security groups, NACLs are stateless. This means that a rule that allows inbound traffic does not automatically allow corresponding outbound traffic, and vice versa. Subnet level control. So, as you already know, NACLs operates at the subnet level, which means they control traffic entering and exiting entire subnet rather than individual instances. Also, NACLs using rules as a evaluation. So, when rules are evaluated in a descending order of their number of rules, if a traffic match is found, the appropriate action, allow or deny, is applied. If the rule does not match, then traffic is implicitly rejected. We have default NACLs, so each VPC comes with one defaulted network ACL that allows all incoming and outgoing IPv4 traffic and all incoming and outgoing traffic, IPv6 of course, traffic, if IPv6 is enabled for that VPC. Also, you can create your own custom network action control list to implement specific security rules for your subnet. Also, a subnet can only be connected to one NACL at a time, but a single NACL can be connected to multiple subnets. A security group controls the traffic that is allowed to reach and leave the resources with which is connected. For example, when you connect a security group to an EC2 instance, it controls inbound and outbound traffic for the instance. When you create a VPC, it comes with a default security group. AWS security groups help you secure your cloud environment by controlling how traffic will be allowed on your EC2 machines. With security groups, you can also ensure that all traffic flowing at the instance level only goes through your established ports and protocols. When running an instance on Amazon EC2, you need to assign it to a specific security group. You can also add a rule to each security group that allow traffic to or from specific services, including related instances. And then, just like whitelists, security group rules are always allowed. It is not possible to create rules that prohibit access. For example, you may have traffic coming from an elastic load balancer to a subnet with web servers. Your AWS security group can list that LB as its only allowed source. Security groups are status-based, which means that if an incoming request passes, then the outgoing request will also go through. To establish a secure network environment, you need to properly configure your VPC security groups. This involves defining the rules for incoming and outgoing traffic. Incoming rules manage incoming traffic to your EC2 instances. Traffic can be requested from web servers, API calls, or SSH connections. Outbound rules, on the other hand, manage traffic that leaves your instances, such as outbound traffic to the Internet Gateway or to the AWS services. The default security group that comes with your VPC allows all outbound traffic, but prohibits all incoming traffic. One of the best practices is to limit all traffic, both inbound and outbound, and then selectively allow only the necessary connections. Finally, VPC security groups and network NACLs. What is the difference between them? Well, both VPCs and network access control lists or NACLs are used to protect your AWS resources. They work at different levels. VPC security groups operate at an instance level, controlling traffic to your instances or EC2 instances, but NACLs, on the other hand, work at the subnet level, managing traffic to and from subnet within your VPC. Understanding these differences is crucial when designing your AWS network topology and implementing firewall optimization strategies. For example, security groups and network ACLs are similar in that they allow you to traffic access or control access to AWS resources within your VPC, but security groups allow you to control incoming and outgoing traffic at the instance level, while network ACLs are similar capabilities at the VPC subnet level. AWS security groups and NACLs are both firewalls that control traffic in AWS, but they operate at different levels and have distinct characteristics. Also, security groups act as a virtual firewall for the EC2 instances controlling inbound and outbound traffic at the instance level, but NACLs on the other hand are a stateless firewall that controls traffic at the subnet level. And finally, in this table you can see all the difference between security group and network access control list. For example, just to recap all this that we learned in this lesson. For the security group acts as a firewall for associated Amazon EC2 instances. On the other hand, NACLs act as a firewall for associated subnet. So, just to recap once again, this security group work at the instance level and NACLs run or work at subnet level. That's it. Then security groups control both incoming and outbound traffic at the instance level. NACLs control both traffic at the subnet level. Also, security group, you can secure your VPC instances using only security groups, support allow rules only, and it is stateful. So that means that it return traffic is automatically allowed regardless of any rules. Also, it evaluates all rules before deciding whether to allow traffic. On the other hand, network access control list control both traffic at the subnet level There are just an additional layer of defense, support allow rules and deny rules, and it is stateless. Return traffic must be explicitly allowed by rules. Also, it evaluates rules in number order when deciding whether to allow traffic, starting with the lowest numbered rule. So imagine that you have two rules, for example, in network access control list. Deny is 150 and allow is 160. Then that deny rule will have this order. Finally, security groups applies only to instances that is associated, has a separate rules for both inbound and outbound traffic. A newly created security group denies all inbound traffic by default, and also a newly created security group has an outbound rule that allows all outbound traffic by default. On the other hand, it applies to all instances to its subnet it is associated. So if you have in that subnet, for example, if you have 6 virtual machines, then all rules will be applied to all these instances or virtual machine. Also, has a separate rules for inbound and outbound traffic. A newly created necklace denies all inbound traffic by default, and a newly created necklace denies all outbound traffic by default. So you must specify these rules. Security group instances are associated with the security group and can talk to each other unless you add the rules and allow that. And in necklace, each subnet in your VPC must be associated with the network ACL. If none is associated, then default NACL is selected. And the last one, security groups are associated within network interfaces on your instances. And network security groups, you can associate a NACL with multiple subnets. However, a subnet can be associated with only one network ACL at a time. Once again, we are in our console, and if you go to our VPC in the same region, so in the North Virginia region, and if I scroll down, you can see in the security blade that we have two options. First one is security group. As you can see, we have one security group created by default by AWS, and it is attached with our default VPC, as you can see. And also the other blade is network ACL. If I open a new tab, go to our EC2, and if we, for example, scroll down, we have also network security group here. So you can see that this is exactly the same network security group in our EC2 section. Here you can manage stale rules. You can copy to the new security group. You can check inbound rules, outbound rules, and if you select your group, you can see that we have by default added our security group rule ID. All traffic from all protocol and ranges will be, our source is a custom, so all traffic is supported. Then you can create your own custom, and for example, we can add HTTP, TCP protocol and protocol 80, and you can add your source. Finally, you can click to add this security group. And then we have outbound rules. Also, we have exactly the same outbound rules, but as you can see, this is our outbound rule. All traffic to all port to the internet is allowed by default. Then we have something called sharing. We have VPC association, and that's it. In the details, you can check all details. Also, you can create your own security group. If you need to provide a name, add a description, choose your VPC, and finally you can add a rule, or outbound is by default, or you can add your security inbound rule if you want, and simply click on create security group. That group will be created. I will now open a new tab. Again, I will go to my EC2 instance. If I go to instances, click on launch instance, and when we add a name, choose our image, type create a key pair. In the network settings, there is an option to create security group or select an existing resource group or security group, sorry. And then you can also compare security group rules, and here when you choose to create a to create a new security group, also you can add your rules. Finally, you can create a placement group, but placement group is a different thing. We'll learn what is a placement group. If you want to add your VMs close to each other, then you will use placement group. Security groups are, on the other hand, is some kind of firewall that allow or deny traffic, which allow traffic to your, or restrict traffic to your instances. And if you go to network ACL, as you can see, we have one default ACL associated with all 6 subnets. So just to remind you, network ACL is based, will work on our subnet level, and here you can also check these details in the inbound rule. As you can see, by default, with the number 100 rule, all traffic is allowed, and you can also see what is outbound rules and what is our subnets. In this United States, North Virginia, we have 6 AZs, and it is attached to our default VPC. We have 2 inbound rules and 2 outbound rules by default, and you can see that we are the owner of this network ACL. So here you can also play around with this, and it is very easy to create a new NECL. Simply add a name, select your VPC, and click on Create Network ACL. So this is an optional layer as security, as firewall, that will control our traffic in and out of our subnet and work on subnet level. Security group, on the other hand, run on instance level. And that's it. Thank you for watching. Now that you know the basic parts, what are the basic parts of our VPC, let's learn about flow logs. Well, VPC flow logs is just a feature that allows you to collect information about IP traffic going to and from the network interfaces in your VPC. Log data can be published in the following locations: Amazon CloudWatch logs, Amazon S3, or Amazon Data Firehouse. A configured delivery path and permissions are allowed that allow a log of network traffic to be sent to a destination, such as CloudWatch logs or S3, are called subscriptions. After you create a flow record, you can download and view the flow log records in the log group bucket or delivery flow that you can have configured. Flow logs can help you with a number of tasks, such as diagnosing overly restrictive security group rules, monitoring the traffic that arrives at your instance, determining the direction of traffic to and from traffic or network instances or interfaces. Log data is collected outside the path of your network traffic and therefore does not affect network bandwidth or latency, so you can create or delete flow logs without any risk or affecting network performance. Also, data entry and archiving fees for sold records apply when you publish the flow record. To track cost from the publishing funnel records, you can apply cost allocation tags for your destination resource. Subsequently, your AWS cost allocation report includes usage and cost aggregated according to these labels. You can apply labels that represent business categories, such as cost center, application names, or owners, to organize your expenses. You can also create a flow log for a VPC, subnet, or network interface. If you create a flow log for a subnet or VPC, every network interface in that subnet or VPC is monitored. Flow log data for a tracked network interface is recorded as flow logs records, which are log events and that consist of fields that describe the flow of traffic. For more information, you need to see flow logs records. To create a flow log, you must specify the resource for which the flow logs needs to be created, the type of traffic to be recorded, like accepted traffic, rejected traffic, or all traffic, destination to which you want to publish your flow log data, and if you start an instance with in your subnet and you create a flow log for your subnet or VPC, then we will automatically create a log flow for CloudWatch logs or a log file for Amazon S3 for the new network interface as soon as network traffic for the network interface appears. You can create a flow logs for network interfaces created by other AWS services, such as Elastic Load Balancing, Amazon RDS, Amazon Elastic Cache, Amazon Redshift, Amazon Workspaces, Net Gateways, and Transit Gateways. Regardless of the type of network interface, you must use the Amazon EC2 console or the Amazon EC2 API to create a flow log for the network interface. You can also apply tags to your flow logs. Each label consists of a key and an option value, which you define. Tags can help you organize your flow logs, for example by purpose or owner. If you no longer need the flow log, you can delete it, and deleting a flow log disables the flow log service for the resource, so no new flow logs records are created or published, and deleting a log does not delete an existing log data. Once you deleted a flow log, you can delete it directly from your destination where you are done with. If you go to our VPC in our North Virginia, and if I go to my VPC and check this box in my default VPC, here you can go to flow logs, and from here I can create my flow logs or do some action, but let's hit on create flow logs. Here I can add a name, and as you can see, our resource ID is our VPC, our default VPC in our North Virginia region. Here we must provide a name for this flow log. Then for the filter, you can type of traffic to capture accepted traffic only, rejected traffic, or all traffic. Then maximum aggregation interval, so it sets a maximum interval of time during which a flow packet is captured and aggregate into a flow record. You can choose between 10 and 1 minutes, and also you can choose your destination. Where do you want to publish this flow log? Send to CloudWatch, Amazon S3 bucket, Data Firehose at the same account, or Data Firehose in a different account. And then you must add the name, for example, or the CloudWatch. If you want to send this to some bucket, you need to provide your ARN for this bucket. And finally, you can choose your log. You can also create a S3 bucket right from here, and this you must add Firehose stream name, and that's it. This will be published. Also, you have option to add or create your Firehose right from here. Also, in the service access, you can use an existing service role or create a new one. You can also check your log format record. You can specify the fields to include the flow log, or you can use a custom format. Here you can choose your service role or create a new one if you are using the new record. Also, there is additional metadata that include Amazon EC2 metadata, and this will include this metadata. Also, you can choose or check your log format and simply choose your standard options by checking these fields. And finally, when you're finished with this, finally click on create a flow log, and your flow log will be created. Also, you can add a tag, and this is optional. Then simply click on flow logs. It really depends on what you select in these settings. AWS VPC peering is a network connection that allows you to route traffic between two virtual private clouds or VPCs using private IP addresses as if they were part of the same network. This allows resources within connected VPCs to communicate securely with each other without going over the public internet, VPNs, or AWS Direct Connect. It is an AWS networking feature that enables secure and direct communication between different VPCs. By using the VPC peering feature, organizations can establish private connections that facilitate the secure or smooth transfer of resources and data between different VPCs in the AWS cloud. By establishing communications between different environments and maintaining the integrity of each VPC environment, VPC peering facilitates network management. In the AWS ecosystem, VPC peering is an essential service for creating scalable network infrastructure structures. Amazon peering provides an efficient way to connect virtual private clouds and offer powerful network capabilities within AWS. In this lecture, the complexity of VPC peering is addressed with an effective explanation. This article, if you are reading this or if you watch this And then this is our chapter, how to establish smooth communication between different cloud environments in AWS. Well, AWS VPC connection lifecycle. To establish a connection have some rules. First, we have start. The lifecycle process begins with the initiation of the request to establish a connection between two VPCs. These requirements include an indication of the VPCs to be established in their respective settings. Then we have approval. After the request has been submitted, the VPC administrator receiving the link must accept that link. This step involves both parties agreeing to establish a relationship. And then we have establishment. When one and both parties approves the connection, the VPC connection is established. This allows communication between two VPCs. If they are on the same network, it allows instances at one VPC to communicate with instances of another VPC using a private IP address. Then we have configuration. Once the connection is established, the administrator can configure routing tables and security group to control the flow of traffic between established VPCs, and these steps ensure the communication is carried out securely and it follows the desired network path. So, when you configure these connections, you must add a routing table that approves this, or add a security group role. Simple as that. With these established connections, the resources within the established VPCs can communicate with each other and without any problems. This provides various use cases such as data replication, resource sharing, and application integration across multiple VPC. When we talk about monitoring and maintenance, administrators continuously monitor the performance and security of the VPC peering connections. They can also perform maintenance tasks such as updating routing tables or setting security group policies as needed to optimize connection performance and ensure its reliability. And after that, there is some optional settings. This is called completion. If the need arises, administrators can request the completion of the VPC peering connection. This effectively serves as a network connection between VPCs and prevents further communication between them. If you have multiple VPCs peering connections, they are allowed for a network topology where multiple virtual private clouds or VPC are connected to each other. This provides granular control over communication between components or environments within an organization cloud infrastructure. Each peering manages independent channels and support configurations between specific VPC pairs. Administrators can strategically deploy and manage multiple peering connections to support many use cases such as multi-tiered application architectures, separate development environments, or distributed microservice deployments. These VPCs can be in different regions and are therefore known as inter-regional VPCs peering connections. AWS VPC peering generally offers low latency communication between paired VPCs located in the same region. Traffic flows over the network, latency is generally minimal, making it suitable for real-time applications and services. Latency generally depends on factors such as the geographical distances between VPCs and potential network congestion, which may have a little impact on latency. But AWS VPC peering is designed for efficient and reliable connectivity with minimal latency for communication between VPCs. AWS VPC peering connection offers scalable, high bandwidth communication between paired VPCs. The bandwidth between AWS VPCs depends on the type of instances and their network communication capabilities. Also, AWS Direct Control or AWS VPN connections can be additionally used to improve bandwidth between VPCs and local networks if necessary. Amazon VPC peering is an online feature provided by AWS. It is excellent and secure method for connecting different virtual network clouds, and this concept is explained along with an explanation of its importance. VPC peering is useful for connecting different environments. If you have, for example, development, testing, production, you can share resources between these VPC. For example, if you have 3 VPCs and in one VPC you have, for example, 2 instances. On that instances you have your application that is running behind, for example, Elastic Load Balancer. Then first VPC will be development, the second one will be testing, the third one will be production. You can establish connection between these VPCs using VPC pairing, and then you will be able to share resources between this VPC and establish with this enabling communication. You can use a different department's organization with the same company. So that's the whole story of this. And you can see in our map, this is how it looks like. So let me grab my pen and explain this more efficiently. So as you can see, we have VPC A, for example, and VPC B in different regions. And now I want to, of course, our VPC A and VPC B has its own subnet. This is our private subnet, for example. And in these subnets, we have 3 instances that is running some kind of application or database. It really doesn't matter. And now, as you already know, these VPCs are isolated by default and they cannot talk to each other. If you want to establish connections between these 2 networks, you will use this VPC pairing. And that's it. This is the whole point of this pairing. Let's hop to our portal and see how can we establish connections. Welcome back. We are in our North Virginia region in our console, and I will go to instances. First, I will create a new instance. Let me choose launch instance. I will add a name for this instance. This will be VM1 Linux. I will choose my Amazon Linux, choose my t2.micro as an instance type. I have my key pair already created, and in the networking settings I will edit this setting, choose my default VPC, and we can also create a new VPC if you want, but here I will use this default one. And finally, if I go back just to show you in our VPC service, you can run this VPC, or you can create this more complicated infrastructure. Let me add a name for my VPC. I will add a new VPC, choose my IPv4, choose my default tenancy, and we must add our IPv4 side range. Let me add 10.0.0.0/24. So we're creating our VPC and our subnet. Sorry, we don't have any subnet, but we have our route table. And right from here, you can also edit this VPC if you want, and you can enable DNS resolution, for example, and some other settings. Let me now go to my VPC. As you can see, this is our VPC. We can create another VPC. This will be, for example, VPC B. I will add another IPv side range. It must be valid, so let me just add some different number. We can add, for example, 192.168.0.0/24. Let's see if we can have this. Yes, we successfully create another VPC. So we will establish connection between these 2 VPCs located in the same region. Now in my subnet, I can create 2 subnets. First, we need to add our VPC ID. Let me add for VPC A. Then here I will add my subnet name. This will be subnet A. You can choose your availability zone. I will choose the first one, 1A. Then this is our CIDR range and CIDR block, sorry, and I must specify my IPv subnet CIDR block. Finally, we are ready to create our subnet A. Let me add another subnet. This will be subnet B. I will associate our VPC B. Let me add a name. This will be subnet B. I will choose different availability zone. And here we need to provide our IPv subnet CIDR range. It will be 192.168.0.20/24. Let me click on create subnet. Our second subnet is created. So as you can see, we have two subnets. And let me now go to my EC2. I will create my first instance. I will now launch my instance. This will be VM1 or VM A, sorry. We'll use our Amazon OCI TC2 instance type. Key pair is here, we already have. And now in the networking settings, I will click on edit. Choose my A VPC that we created. Choose my subnet A. It is automatically created or selected, and I will enable auto assign IP address. Here we can create a new security group. This will be VMA security group, VMA subnet, or sorry, HG. And I will copy this to my description. This is required, and here we will leave everything as it is. So we are launching our first instance. Also here you can choose to upload your file or add your file if you want to get a message from this VM. I will simply click on launch instance. As you can see, our VMA is successfully created. Then we can go and launch. First, let me refresh this page. So as you can see, our VMA is still pending. But in the meantime, let me create a new VMB. And for VMB, we will use exactly the same image, exactly the same instance type, exactly the same key pair. But in the networking settings, I will edit network settings, choose my VPC B, and as you can see, automatically it is selected subnet B, and we will auto assign our public IP address, and here we will add VMB dash or underscore SG. I will now copy this and paste it to description that is required, and finally we will hit on launch instance. So we have our both VMs or instances that is located in different VPCs, but in the same subnet, in different availability zone. So now we will be able to establish connection between these two VPCs, and both of our VPCs have one instance, VMA in VPC A, VMB in VPC B. So you can check your details of your VMs, and finally, as you can see, this is our subnet, this is our instances is running. We are waiting for our status to be initialized. And if you go to VMB, you can see all information about VMB. Now I will go to my VPC service. Here we can see that we have 3 VPCs and 2 subnets, 2 new subnets, and of course when you create your VPC, route table is automatically here, and we have 3 network ACLs and 5 security group. If you go to peering connection and click on create peering in the virtual private cloud, as you can see, and click on create peering connection, I need to add my name for my peering connection. Then we need to select our local VPC to pair with. First, we will select our VPC A. This is our requester, and you can see that status is associated. Then we need to select another VPC that we want to pair with. You can use this from your account or from another account. Also, you can use in this region, this is US region 1, or another region. I will add the acceptor. This is our VPC B. And finally, we will click on create peering connection. And as you can see, there is a pending acceptance by our VPC, by our VMB. So you must accept or reject this peering connection request using by in action menu, as you can see. Otherwise this will expire. So we must, as you can see, this is our requester VPC and acceptor VPC. If I open a new tab, as you can see, this is our VPC B, and now I must accept this request or reject this. I will accept this request, and as you can see, the status of our peering connection is active. So it is very easy to set up a peering connection, and now both of these VPCs are connected. And now if you want to share the traffic, you must go to your security group and add a rule, but this is how can you establish a peering connection. I will not go to security group because I just want to show you how can you create your peering connection between these 2 VMs. You will add a simple route that accept a traffic from one VPC to another VPC, and in another VPC you will add another rule, and that's it. This is a very easy to connect. Now you can also view details of this connection. You can edit DNS settings, for example. You can manage tags. You can also go and see or simply delete this connection. So there is a lot of option, but the most important thing that I showed you, how can you connect to virtual networks using VPCs, peering. And if you go to our peering connection, we must check our peering connection. You can see that our status is active, and if you want to delete this connection, this status, you're finished with your job and want to quit this, simply go and delete this peering connection in the actions, and here you type delete, click on delete again, and as you can see, status is now deleted. Now we can complete this peering connection, or we can go to our AWS, go to our EC2 instance, and if you go to instances, you can simply check your both machines or instances, go to instance state and click on terminate, delete this instance, and this instance will be deleted. Also, you must go and to VPC and delete. As you can see that our packets and CPU utilization, so this connection was successful. And if you want to delete your VPCs, simply go to VPC service and you will delete all your VPCs, both for VMB and VMA, and you can also delete our subnets and all other things. If you go to security group, you can see that we still have our VMA XG and VMB XG, and we can also delete this if we want. But after, as you can see, our instances is terminated. After 1 hour, both of these machines will be vanish from this service. The AWS VPC endpoint allows you to privately connect your virtual private cloud or VPC to supported AWS services without the need for an internet gateway, NAT gateway, VPN connection, or AWS Direct Connect. This keeps traffic within the AWS network and improves security and performance. There is private connectivity, so VPC endpoint facilitates private communication between your VPC and certain AWS services, meaning your traffic doesn't cross the public internet. No public IP addresses required. Instances within your VPCs can communicate with AWS services over an endpoint without the need for public IP addresses. Also, by keeping traffic within the AWS network, VPC endpoints reduce the attack surface and potential vulnerabilities associated with public internet access, so you can see that there is also improved security. Also, there is a reduced latency. Private connections can offer lower latency compared to going over the public internet. Also, in some cases, using VPC endpoints can reduce data transfer cost compared to using public gateways or NAT gateways. Then there is a lot of type of VPC endpoints. The first one is endpoint interface. This powers AWS private link and provides access to a wide range of AWS services. They act as an elastic network interface with a private IP address in your subnet. We have gateway endpoints. Currently, gateway endpoints are used to connect Amazon S3 and Amazon DynamoDB. They act as a target in your routing table for traffic directed to these services. So, key benefits of endpoints or VPC endpoints is secure access. It provides a secure and private way to access AWS services from your VPC. It has reduced complexity, so simplifies network configuration by eliminating the need for internet gateway, NAT gateways, or any VPN connections to access supported services. Also, there is improved performance. It can reduce latency and improve network performance to access AWS services. Cost savings. It can reduce data transfer cost in certain scenarios. So, when do you want to use VPC endpoints? When you need to access to AWS services from your VPC's private subnet, when you want to keep your VPC traffic within the AWS network and avoid the public internet, when you need to reduce latency and improve performance to access AWS services, and the VPC endpoint allows you to privately connect your VPC to supported AWS services and VPC endpoint powered by private link without the need for an internet gateway, NAT device, VPN connection, and AWS Connect. Here it is. As you can see, how can you use your VPC endpoint? So it, as you can see, provides a secure way to connect your endpoints. If you go to our console and scroll down in our VPC, you can see that we have private link and lattice. We have also option to create an endpoint, and this will create a VPC endpoint that supports the service network, or resource which you want to connect. When you want to add a name, then you want to choose the type. We have AWS services, private link, ready partner services. It connects to some SaaS services which have AWS service already ready. We have AWS marketplace services. It connects to SaaS service, software as a service, that you have purchased through AWS marketplace with an interface endpoint. Then we have EC2 instance connect endpoints, an elastic network interface that allows you connect to resources in a private subnet. So you can use this, and we have resources, service networks. This is a new option, and you can choose endpoints that use network load balancer or gateway load balancer. So you can use for a different purposes, you can see. And if you want to choose AWS services, you can connect to services provided with this Amazon and internet interface endpoint or a gateway endpoint. If you use EC2 instance, then in this connect endpoint, you will use your network interface card to connect to a resource in a private subnet. So this is a very, very useful option if you use endpoint. Also, there is, as I already mentioned, AWS services and all others. So here you will see what services are available, and here you will choose your service. For example, you can type gateway, and it will filter your interface and gateway. As you can see, this is our DynamoDB and S3. As I already mentioned, this is only available for now for DynamoDB and S3 service. For the first one, it will use interface. For the second one, it will use gateway. And here you need to specify your network settings, and finally you will choose your policy to control access to this service, and choose your route table, and simply scroll down and click on create endpoint, and your endpoint will be created. So as you can see, it's easy to set this up, and that's it. Then we have endpoint services. You can create your endpoint service if you want. If you go to our endpoint service, you can connect your network or gateway. Then you will choose your available load balancer, or you can create a new load balancer from here. Check your support region to enable cross-region access to your application or service. You can acceptance required, and then you can choose between IPv4 and IPv6. And that's it. This is how can you set up your endpoints and endpoint services. There is a lot of options here in your VPC service, but we are learning the most basic ones. AWS site-to-site VPN is just a service that establishes a secure encrypted connection between your on-premise network and your AWS resources, specifically your virtual private cloud. It uses IPsec tunnels to create a private, secure path over the public internet to transfer your data between your local network and your AWS environment. This allows you to extend your network to the cloud, allowing communication between your on-premises workload and your AWS resources as if they were part of the same network. This service creates encrypted connections between your data center or branches and Amazon VPC, protecting your data and ensuring your privacy over the internet. It's a popular solution for multi-site businesses that need a reliable way to stay connected and share resources. AWS site-to-site VPN encrypts all data transmit between your on-premises network and AWS. This encryption creates a secure path for sensitive data, preventing unauthorized access or interception. It allows organizations to effortlessly connect their on-premises network to the AWS cloud. This allows on-premises network resources to securely connect to AWS resources, resulting in a hybrid architectural arrangement. Amazon CloudWatch logs allow you to track, store, and access log files for the connection logs of your AWS client VPN. Relevant log data is available from CloudWatch logs. AWS site-to-site VPN eliminates the need for leased lines or hardware based on VPN equipment. This reduces the cost of maintaining and administrating traditional network infrastructure. Many companies store and analyze sensitive data in local networks. By establishing a secure connection with AWS, you can securely transfer data to and from the cloud. Certain industries and regulatory regimes impose strict safety and compliance requirements. By securely connecting on-premise networks to AWS, organizations can meet these standards while protecting privacy and integrity. Organizations often use a hybrid architecture that combines on-premises infrastructure with cloud resources. secure communication enables seamless integration of the two environments, allowing for more efficient operation and data transfer. Encryption and authentication option for site-to-site VPN. So, you can use IPsec VPN. IPsec is among the most widely used security protocols for site-to-site or virtual private networks, and you are provided with a high level of encryption and authentication. In addition, encryption protocols such as IS-256, SHA-256, and RSA are supported. SSL VPN, this allowing connection to be established through a web browser, gives you flexibility and security for your site-to-site VPN networks. SSL VPN additionally supports strong encryption and authentication. Also, we have certified-based authentication, so organizations can use digital certificates to enable more secure authentication. A certificate authority, or CA, manage certificates using a public key infrastructure, or PKA. Here, a more detailed overview. Well, what is a secured connection? AWS site-to-site VPN encrypts all data transmitted between your local network and your AWS VPC, ensuring secure communication over the internet. IPsec tunnels, it will use IPsec tunnels to create a secure encrypted path for your data. Then we have this service is fully managed, so AWS handles the complexities of settings up and managing a VPN connection, including the underlying infrastructure and maintenance. High availability, so AWS site-to-site VPN offers redundancy by using multiple tunnels across availability zones, providing high availability for your connection. Then we have different connectivity options. You can connect your local network or branch to your AWS VPC, or you can connect multiple VPC together, potentially via transit gateway. You can choose between static or dynamic BGP routing for your VPN connection, which affect how traffic is routed between your networks. AWS site-to-site VPN has an hourly rate for active connections and charges for data transfer outside of AWS. This is a very expensive service, so if you want to try this. Then we have something called AWS Direct Connect. This is a network service that provides an alternative to using the internet to connect a customer on-premise location to AWS. The data is transmitted over a private network connection between AWS and the client data center or corporate network. Well, there is some advantages like reduced cost when using a large amount of traffic, increased reliability, predictable performance, increased bandwidth, predictable bandwidth, and reducing latency. Also, each AWS Direct Connect connection can be configured with one or more virtual interfaces, or VIFs. Public VIFs provides access to public services such as S3, EC2, and DynamoDB. Private VIFs provide access to your VPC. Public IP addresses on public VIFs must be used. Private IP addresses must be used on private VIFs. Then layer 2 cannot be used via Direct Connect, L3 only. From Direct Connect, you can access to all AZ within the region. Also, you can establish IPsec connection through public virtual interface to remote regions. Then route propagation can be used to send user side routes to the VPC. You can only have one entry of 0.0.0.0/0, all IP addresses per routing table. Also, you can connect more ports for more bandwidth, and virtual interfaces are connected to connect to public AWS services like EC2 or S3, or private services like VPC-based resources. Also, direct connection is charged per hour of port operation and data transfer. AWS Direct Connect is a network service that provides a dedicated private connection between your local network and AWS by passing the public internet. So this is the difference: AWS using public internet and Direct Connect using AWS infrastructure. Also, this dedicated connection can offer several advantages, including reduced network cost, increased bandwidth, and a more consistent network experience compared to internet connection. Here's a more detailed explanation. You have private connection, so Direct Connect establishes a dedicated private network between your infrastructure, data center, office, or co-location environment, and AWS. This connection allows you to bypass the public internet, which can be subject to bandwidth fluctuation and latency. Also, you can create virtual interfaces, public or private, through this link to access public AWS services such as S3 or your VPC. By using Direct Connect, you can achieve higher bandwidth and more predictable network experience, which is crucial for applications that require low latency and high bandwidth. In many scenarios, direct binding can lead to a reduction in network cost, especially for large data transfers. Also, you can establish a direct connection through dedicated connection or through AWS partner network or APM partner, so you can use multiple connectivity options, different multiple connectivity options. And AWS Direct Connect locations are available in different regions and are associated with network-specific AWS regions. A leg or link aggregation group, this is a direct linking support legs, allowing you to combine multiple links into a single logical interface, increasing bandwidth and redundancy. And finally, here it is. This is how can you, for example, use AWS site-to-site. So, for example, let me just grab my pen. If you have some customer network, as you can see, this is our on-premise or local network. Here we have our client and we have our mobile client. We have our servers, and here if we want to connect this left side to your customer network, then you will use site-to-site VPN, and you will use our internet, and we will use something called IPsec VPN. Here we have this is our AWS cloud. We have our region. In that region we have one VPC and virtual private gateway, as you can see, and in that VPC, this virtual private gateway connect to the internet. All traffic will go to this internet, and here we will use AWS site-to-site VPN to connect these two locations. Of course, in our VPC we have two availability zones, zone A and B, and here we created our private subnets, and in this private subnet we have one instance in A and one instance in B, and finally in that instances we have some kind of, for example, application, and that's it. This is how can you connect these two locations. Thank you for watching. Here we will say a few words about transit gateway and private link. But first, let's learn what is a AWS Transit Gateway. Well, this is just a service that simplifies network connectivity between private clouds or VPC and on-premise network by acting as a central hub. It provides a scalable and efficient way to manage network connections, replacing complex peering configurations with a hub-and-spoke model. This allows you to connect thousands of VPC and local networks through a single gateway, making it easier to scale and manage your network infrastructure. Here's a more detailed explanation. So, as already said, this is a central hub, and the transit gateway acts as a central router connecting multiple VPC and local area networks. This service eliminates the need of complex VPC peering point-to-point connections and reducing the management burden. The transit gateway is designed to handle a large number of connections, making it suitable for growing cloud environments. This model simplifies network management by routing traffic through a central transit gateway rather than directly between all connected networks, so you can use something called hub-and-spoke model. Also, we have interregional peering. Transit gateways can be connected across different AWS regions for global applications. And when you talk about security, AWS manages the security of connections, so you can configure security groups and routing tables within the transit gateway to control the flow and the traffic. Also, integration with VPN and Direct Connect can be used with different types of VPN connections and in AWS Direct Connect for hybrid cloud environment, and it has centralized routing, so a transit gateway manages routing for all connected networks, simplifying network management and reducing the risk of misconfigurations. AWS Transit Gateway is a highly scalable and scalable service, an available service for consolidating AWS VPC routing configurations for a region with a hub-and-spoke architecture. Each spoke VPC only needs to connect to the transit gateway to gain access to the other connected VPC. AWS Transit Gateway supports both IPv4 and IPv6 traffic. You can leverage several transit gateway routing tables, associations, and propagation to segment your traffic within the same transit gateway. You will be able to manage different routing domains, for example, production and non-production traffic, from a single point of management, ensuring that these routing domains will not be able to communicate with each other. You can also leverage hub and spoke architecture created by Transit Gateway to centralize access to shared services such as a traffic inspection, access to VPC interface endpoint, or outbound traffic through a NAT gateway or NAT instance. This centralization simplifies the complexity of managing these resources across several VPCs and allows for better control over how you expand your space in AWS. Transit gateways can be connected to each other within a different or the same AWS region. AWS Transit Gateway traffic always remains on the global AWS backbone and never crosses the public internet, reduces threat vectors such as common exploits and DDoS attacks. With a large number of VPCs, Transit Gateway provides simpler management of communication with VPCs through VPC peering. In some architectural solutions, you will often use a private link. So we will get acquainted with this service here. AWS Private Link allows you to connect to some AWS services hosted by other AWS accounts called endpoint services, and support AWS Marketplace partner services through private IP addresses in your VPC. Interface endpoints are created directly within your VPC using elastic network interfaces and IP addresses in your VPC subnets. This means that VPC security groups can use to manage access to endpoints. And here it is. This is how can you use your transit gateway with other transit gateway. So if you have some, let's say, different VPCs, then you will use this region and connect to this transit gateway with another region or with another AWS transit gateway that is located in another region. So if you have, for example, let me just grab my pen. Imagine that you have 15 VPCs in this region, and here you have another 15, for example. Then it is a real mess. So we'll use AWS Transit Gateway, for example, to group these VPCs into one transit gateway, and another 15, for example, in another region but in different AZ or availability zone, to group these 15 in another transit gateway. Then imagine you have region number 2. In this region you have 50 Amazon VPCs, and then you want to connect all these VPCs into a peering connection. Then you will create another transit gateway, and after that you will only connect this transit gateway to this to this, and simply here to here. So this transit gateway is a central hub for your VPCs, and with using this AWS Transit Gateway you will be able to connect all these VPCs without any additional burden. So thank you for watching, and I hope this is now more clear. In this chapter I will show you how can you use a NAT gateway in our AWS service. So we are once again in our console. As you can see, I have one VM that is currently running, and this VM has public IP address and private IP address, and status is initializing. Also, if you go to our instances, let's create a new instance. I will add a name for my VM. This will be simple name, something like VM2. We will use our Ubuntu image, Amazon AMI Ubuntu. Of course, instance will be t2.micro. And finally, I will use my key pair. Let me choose appropriate one, or you can simply go and create a new one if you don't have. I will now create VM2 key pair just for the simplicity of this demo. And as you can see, we are downloading our private key on our laptop, and here we can set up our network settings, our VPC, subnet, availability zone. You already know how can you create this. So I will use my VPC. But if I go back to our, let me find my VPC service. I will go to my VPC. Let's create a new VPC. I will add a name. So we are using this first option to create a VPC only. This will be simple name VPC only. We will be using our IPv4 CIDR range. I will add this CIDR range 10.0.4.0/16, and here I will not use any IPv6, and simply let's hit on create VPC. But first I need to add /24, of course. And as you can see, our route traffic is automatically created. Then in our EC2, we will now go to launch instances. Let's click on launch instance. Now I will add VM2 name for this VM. We will choose again exactly the same Ubuntu image. Then t2.micro, our instance type. We will use our key pair that we created in previous step, and here we will edit our network settings. I will choose my new VPC, and as you can see, I don't have any subnet. And right from here we will create our new subnet. I will select my new VPC as our VPC ID, and here we will add our subnet name. This will be private subnet. We can choose our availability zone if you want. This is our CIDR block, and finally I will add my IPv CIDR block 10.0.4 .20/24, of course. And finally let's hit on create subnet. This is our subnet. We can now go back to our instances. Let me refresh this, and finally this is our subnet. And I will disable auto assigned IP address. We can use or create a new security group, and let me now just copy the name of my VM, and I will paste this name into this empty field and add _SG. I will now paste this once again and paste it in our description. And finally we will hit on launch instance. Our instance is successfully launched. You can check your logs if you want. Let's go to instances. I will now refresh my page, and as you can see, our machine is running. So you can see we don't have any public IP address, so this VM cannot access to internet. I will now go to my security group. As you can see, we have a lot of security groups here. VM2 SG is our existing, and we have only outbound security rule, and we don't have any inbound rule. So that is very important. And now I will go to our VPC, and here in the NAT gateway we will create a new NAT gateway. I will add a name for my gateway, choose my subnet, this is our private subnet, and connectivity type you can choose public or private. This will be private. I will allocate my elastic IP and click on create NAT gateway. As you can see, this NAT gateway is still in creation, in the phase of creation. And if we go to our route tables, this is our route table for our new VPC. If you go inside that, you can see that we only have local active route, and if I edit route, let me add a new subnet. I will choose 0.0.0/0 and choose my, let me check my NAT gateway, and let's associate my NAT gateway. Let's click on save, and just like that you can now use this VM, and this VM from private subnet will have the connectivity and can reach internet thanks to our NAT gateway. And finally, you can see for yourself. Thank you for watching. Let's see how can we add a DNS resolution for our instance. As you can see, we have exactly the same public and private VMs from previous chapter, when I showed you how can you set up an Bastion host using just the VMs. And now I want to add this DNS resolution to my VM. As you can see, this is our public VM, and we have private VM of our public VM, but we don't have public DNS. And I want to add this public DNS. Let me go to my VPC. This is demo VPC, and you can click on edit CIDR. Here, I can go to actions, and here I will edit my settings from this VPC. And simply in DNS settings, we will enable this enable DNS hostname. And let's click on save. We successfully modified our settings for this demo VPC. And now if you go back to our instances, and if you refresh all this and simply check this public VM, you can see that we now have this public DNS for our VM. You can also open this VM, but of course you must install some on that VM. And of course, as you can see, it's very easy to use this DNS resolution. If you, for example, go to our Route 53 service, go to hosted zone, and if you expand this and click on create hosted zone, you can add your domain name. I will add my domain name. Let's type, for example, something like internal or private zone. Then I will choose my private hosted zone, and here I can choose my region. Let me choose my North Virginia or some other region, and here I can add my VPC ID. Let's choose our demo VPC, and finally let's click on create hosted zone. So we are adding our VPC. This is our demo VPC, and finally, as I already told you, let's click on create a hosted zone. As you can see, you must enable DNS hostname and enable DNS support for each VPC that you want to associate with this private hosted zone. So this is why it is enabled. This is important to enable DNS hostname and enable DNS support. Finally, you will hit on create hosted zone, and this zone will cost you about $50 for a month, and you will be able to use this. You will create this hosted zone, and you will use this private zone for your internal traffic inside your VPC account. So if you choose public hosted zone, then you will be use this for traffic that will be routed on the internet, and this private hosted zone will be used for route within your Amazon VPC. So this is very important, and this is how can you enable this DNS resolution for VM and exactly for your private hosted zone in Route 53. We already know how to work with Route 53. We take a very good and deep look about this service, and now, as you can see, we know how to set up our private zone. Thank you for watching, and I hope this was helpful. But before we go, as you can see, we still have our public IP address, public DNS, sorry. I want to delete all my resources that we used in this two demonstration. So I will go to my VPC, and our demo VPC is already checked. If you try to delete your VPC, you won't be able to delete your VPC, because you must first deassociate some of these resources. First, we will delete our instances. Let me click on terminate, and you can see instance is in shutting down state. So as you can see, there is a lot of traffic that we used in this. You can see all in this monitoring tab. Now we will go to our VPC. I will check this demo VPC, go to action, click on delete VPC. So we are still not able to delete our VPC because we have, as you can see, two network interfaces. First, we must delete our network interfaces, then we must delete our route tables, for example. First, let's delete our route table. But first, we must deassociate our route table. So if we try to delete our IGV, you can see that we don't have option to delete our demo IGV. So first, we need to wait for our machine to be terminated, and then we will be able to delete all other resources that we used in this demonstration. And now, thank you for watching, and I will see you in the next. Welcome back, and in this chapter we will learn how can we make a network load balancer. All this time, all these chapters, we talk only about application load balancer, but now it's time to see how can we configure network load balancer. As you can see, we are in our console again, and I will go to our VPC, and we are using North Virginia region. Here I have my default VPC, and I can create a new VPC. We will create our VPC. This will be VPC LB. Let me add my IPv4 side range. This will be 10.0.1, for example, 0.0/16, and I will hit on create VPC. So we created successfully our new VPC, and let me go to subnets. I have these default available subnets, and we already know a lot about these subnets. We talked a lot, I showed you a lot, and finally, if I create a new subnet, we need to associate this subnet with our VPC. I will add a subnet name. This will be VM subnet, for example. And here I will choose my availability zone. I will add my IPv4 subnet. .1.0.0/24. Let me click on create subnet. So we created a subnet. I will create another subnet. We are using exactly the same VPC. This will be VM subnet 2. Let me choose my different AZ in the same region, of course, and the IPv4 subnet side range will be 10.1.1.0/16 or 24. And finally, let's hit on create subnet. So we have two subnets. Let me now go to my VPC, and as you can see, we have two subnets. Then I will open a new tab or go to our console. Let's go to our EC2 service, and let's go to instances. Here we will create our new instances. We have our VM2 and VM1, but these machines are terminated, so it's time to launch a new instance. I will add my name. This is VM1 Linux. We will choose our Amazon Linux, as you can see, as our image. Let me choose my T2 micro. I can use my existing key pair, and you can also create a new key pair if you want, if you don't have any available. And let's go to edit. Here I will choose my new VPC LB. I will choose my VM1 subnet. This is our VM Linux. I will copy the name of my VM Linux and paste it here in our security group. We will enable our public IP, and here we will create our new security group, and we will add the name for this security group. And finally, we will go to advanced detail, and here we can add our bin bash script to install our Apache server. Let me copy this, and I will paste this into our user data. And finally, let's hit on launch instance. So we created our first VM, and now it's time to create another VM or instance, as you like. If you check our logs, everything was succeeded, and let me refresh my page. Our machine is pending, and very soon it will be in running state. Let's go again to launch instance. Here I will add a name for my VM. This will be VM2 Linux _ of course Linux. We will choose our Amazon Linux Amazon machine image. Instance type will be t2.micro. We will use our key pair login. Here I will edit my network settings. Let me choose my VPC LB. We will choose our VM subnet 2. We will enable our public IP address, and finally let's create a new security group. But for that we will again copy the name of our future instance. I will paste it here and paste in this description that is required. And finally, let's go to the advanced part, and once again I will copy my bin bash script, and this will install our HTTPD or Apache server. Let me paste it here, and let's click on launch instance. So we created our VPC, 2 subnets and 2 instances. As you can see, if I refresh my page, our VM1 is running and VM2 is still in pending state. And now let's go, and finally, as you can see, our machines are running and it has been initialized. Finally, I will scroll down, go to my load balancer, and first we will create our target group. I will click on create target group. We will choose instances as target type, and this time we will add a name for this target group. This will be TG1 or 100. For the protocol, this time we will be using there is a lot of different, as you can see, protocols, but this time we will use TCP that listen on port 80. This will be IPv4. Let's add our VPC LB. Health checks will be HTTP, and here you can check all these advanced settings, but I'm happy with everything. And finally, let's click on next. Here I will choose my available instances and add this to our target group. Finally, as you can see, our target group is here, and that's it. We successfully created our target group and added our targets to this group. Now let's go once again and check our registration. Everything is fine. So the next step we need to do is, as you can see, both of one of our target group is not associated, so I will go to load balancer, but this time we can create our network load balancer, because we didn't create network load balancer. All this time we worked with application load balancer. And if you don't know the difference, go back to one of the previous chapter and for our theoretical part, and you will see and learn the difference. As you can see, network mapping is already selected, so we need to add our name for this load balancer. Let me add, for example, NLB or LBN. This will be 100. This will be internet facing. We will be using our IPv4. We already selected our VPC. We are using our AZs. As you can see, this is our subnet 1 and subnet VM subnet 1 and subnet 2. Then this is our security group. We will add both of these security groups. As you can see, listener is TCP that listen on port 80. And finally, we will select our target group that we created in previous steps. And here, I don't want to add any listener. I don't want to use AWS Global Load Balancer. And this is our summary, as you can see. This is a global load balancing across multiple regions. So this is accelerator. And finally, let's click on create load balancer. There is an error. And we must, let's see what we need to do. Let me open a new tab, go to our VPC. Let me just check my VPC. Let's go to actions and edit VPC settings. So we need to configure this IG, and we need to create a new internet gateway, of course. Let me add a name for my gateway. This is detached, as you can see. And finally, I will now go to actions and attach this gateway that I just created to my VPC load balancer. And now we are set up, I think, everything. And let's go to our load balancer and let's try again. So now it's successful after we added our internet gateway for this VPC. So you must follow all the steps. And as you can see, this is in provisioning status right now. But if you check all these options, you can see our network mapping. We are using 2 AZs. We have one listener that listens on port 80. And of course, there is a capacity that you can check. And here, as you can see, we are now in our resource map. We have one listener, this is our target group, and this is our target. So it still is in process of registration. So we need to wait for this network load balancer to be provisioned, and after that, when status comes green or active, then you will be able to use your network load balancer. So, as you can see, it is active. This is network. As you can see, type is network, not application. And this is our DNS name. And now, if you copy your DNS name, paste it here, then one of these machines will be shown here. But it takes time to this load balancer to be provisioned, and that's it. This is how can you, as you can see, create your VMs. And now initial health checks is in progress. We have 2 targets, 0 and healthy, and everything works fine. So this is our architecture, and in this resource map you can also check all your or troubleshoot your load balancer architecture. You can see how it's easy to set up complete architecture. And finally, you can go to actions. You can also delete this load balancer. Now that we are done, let's hit on confirm. There's really no need to wait to this to be fully provisioned, because we already know how can we set up this load balancer. Now we have, as you can see, 2 total targets. This target group is not associated with any load balancer, and now we can delete our target group. I will delete another target group that I used in some of the previous chapter. So you can check your security group. You can delete both of these security group. But this will be deleted when you delete your VMs or instances. Let me go to instances. I will now select my instances, go to instance state, and click on terminate these instances. But I will need these instances in some of the next chapter, so I will leave them. Thank you for watching. A DDoS, or distributed denial of service attack, is a malicious cyber attack that overloads a targeted server, service, or network with a flood of traffic, rendering it inaccessible to legit users. Essentially, it's like a huge jam traffic or traffic jam that blocks legit users from accessing a website or online service. Also, there is difference between DOS and DDoS. A denial of service attack originates from a single source, while DDoS attack uses multiple compromised devices, botnets, to launch an attack. How it works? Attacker uses botnets, network or hijacked computers, smartphones or other devices to send a huge amount of traffic to the target. What is the purpose of this attack? Well, the goal is to disrupt normal service by consuming the target's resources, such as bandwidth, processing power, or memory, making it impossible to respond to legit requests. DDoS attacks can cause websites to become unresponsive, applications to crash, and services to be unavailable, leading to loss of revenue, reputational damage, and operational disruptions. Type of dynamics DDoS attacks. Well, volumetric attacks, they flood the network with a huge amount of traffic. Protocol attacks exploit vulnerabilities in network protocols. Application layer attacks, they target specific application and services. AWS DDoS, or Distributed Denial of Service, refers to the protection service and features offered by Amazon Web Service to mitigate attacks aimed to disrupting the availability of a website and application hosted on their platform. AWS offers both free and paid options, including AWS Shield Standard, which is free, and AWS Shield Advanced, to defend against various types of DDoS attacks. Security is a shared responsibility between AWS and the customer. AWS is responsible for protecting the infrastructure that underpins its cloud services to protect its infrastructure, and also AWS uses native protection against DDoS attacks on the infrastructure at layer 3 and 4 at no additional cost. These protections are provided through the Shield standard and are based on the following components. Monitoring system analyzes various sources such as net flow from network devices and service flow to detect DDoS attacks. Cleaning systems clean traffic from DDoS attacks using deep packet inspection, firewalls, and traffic shaping. For services like CloudFront and Route 53, cleaning systems are deployed within their points of presence, or POP, enabling detection and mitigation in less than a second. In contrast, for regional services such as ALB for EC2, cleaning system devices mitigate attacks upon detection, usually within minutes. Shield response team initiates rapid resource or resolution of DDoS attacks, and they are not automatically detected or mitigated by monitoring and cleaning systems. In a shared responsibility model, your responsibility for DDoS protection depends on the AWS cloud services you use, which determines the amount of configuration work you need to do. For example, exposing file from an S3 instance instead of EC2 instance reduce the security controls you have to implement against the DDoS attack. Regardless of the services used, AWS provides the ability to protect, monitor, and respond to DDoS attacks within your area of responsibility. So, in DDoS attack, attacker flood the target system, such as website or application, with a huge amount of traffic from multiple compromised sources, rendering it inaccessible users to legit users. So, AWS Shield Standard, this is a free service that provides basic DDoS protection for resources such as Elastic Load Balancing, Amazon CloudFront, and Amazon Route 53. It automatically mitigates common network and transport attacks. AWS Shield Advanced, this is a paid service that offers enhanced protection against more sophisticated and larger DDoS attacks. It also includes functions such as flow-based monitoring and active application monitoring to detect and mitigate attacks at all times. Always on in-app detection and auto mitigation to minimize app lag and latency. Always on network monitoring to protect against attacks at the infrastructure layer, layer 3 and layer 4. Application layer 7, DDoS protection up to 50 billions AWS WAF or WAF. Request per month for AWS Shield Advanced customer, and cost protection against DDoS attacks to protect against increased cost due to spikes in usage during an attack. Access to the Shield response team or SRT for customers with business or entrepreneurial support. So this is a little recap of what is DDoS and AWS DDoS services. Also, AWS WAF complements AWS Shield by providing application level protection and can be integrated with AWS Shield Advanced for enhanced security. AWS uses a variety of techniques to mitigate DDoS attacks, including traffic shaping, prioritizing legit traffic and rejecting malicious traffic, speed limiting the number of requests from specific sources. Also, they are using blacklisting, blocking or allowing traffic based on IP addresses or other criteria, filtering, removing malicious traffic based on specific patterns, routing, redirecting traffic away from the source of the attack, and benefits. By using AWS Shield and other related services, organizations can ensure that availability of their application, minimize downtime, and reduce the impact of DDoS attacks on their businesses. By using AWS Shield and other related services, organizations can ensure that availability of their applications, minimize downtime, and reduce the impact of DDoS services on their businesses. AWS penetration testing is a security assessment that simulates cyber attacks on the AWS environment to identify vulnerabilities before malicious actors can exploit them. It involves testing various aspects of the AWS infrastructure, including EC2 instances, S3 bucket, and other services, to detect weaknesses in configuration, permissions, and overall security posture. The goal is to help organizations to improve their security practices and ensure the protection of their data and applications within the AWS cloud. Penetration testing in AWS is the process of simulating real-world cyber attacks on AWS infrastructure in order to find vulnerabilities in its security measures. Penetration testers, or penny testers, use techniques that real hackers use to exploit security flaws present on the AWS platform. The result of AWS previous testing is a report that includes the vulnerabilities found during the process, their severity of impact, and steps to fix them. Penetration testing on AWS should be done regularly to ensure that your security measures are strong enough to protect sensitive data and the information stored in it. AWS uses a shared responsibility model where cloud users are responsible for securing their workloads and data, and in most cases, organizations have poor security measures in place in relation to their cloud security responsibilities. Therefore, penetration testing is necessary to find any weaknesses present and take care of the necessary steps to prevent unauthorized access. Many AWS resources do not have multi-factor authentication, proper network segmentation, using AWS security groups, or don't provide excessive permissions. Penetration testing helps identify these security gaps in a large-scale cloud deployment. In addition, it helps to categorize and eliminate these security gaps. Amazon allows users to perform penetration testing on AWS assets. However, there are certain terms and conditions about what you can do and can't test on different platforms. Here, this is a list of allowed AWS penetration testing: web application scanning, port scan, injection, exploitation, scanning or checking the vulnerabilities, counterfeiting, and fusion. Also, what is allowed in penetration testing? Security tools that remotely check AWS assets to identify software names and versions. For example, checking a banner. The goal of this is to compare with vulnerable versions for denial of service attacks. And what is also allowed, you can use security tools or services that temporarily or permanently crash a running process on AWS assets for a local or remote exploitation. However, it is not allowed to overwhelm resource requirements or overwhelm protocols. You can run this security test remotely on AWS assets, locally on virtualized assets, or between AWS assets. AWS allows you to conduct this security assessment, such as penetration testing, to verify your security measures. However, AWS also ensures that these tests do not affect other AWS users or the quality of the AWS services. Here, what is not allowed in AWS penetration testing: DNS zone walking, hijacking or farming, protocol flooding, port flooding, denial of service and distributed denial of service, simulated DOS or DDoS, request flooding, API request flooding, login and request flooding. Users are responsible for verifying and validating that any security test performed by or on behalf of the customer complies with these policies. Those who violate these policies will be liable for any damage suffered by AWS or AWS users through their security testing activity. In this chapter or lesson, we will talk about encryption. So, as companies increasingly rely on technology to facilitate day-to-day operations, strict security controls are necessary to protect sensitive or confidential data from unauthorized access. Unauthorized access to data can jeopardize user privacy and expose companies to significant financial risk. To combat this, encryption or encryption of different types of data is crucial. Data encryption is just a process of transforming data into unreadable code using a cryptographic algorithm so that no one can access it without permission. The encryption algorithm uses secret randomly generated keys to encrypt data that can only be decrypted and returned to readable information using a single matching decryption key. Corporations, governments, and individuals use encryption to protect the data stored on their computer systems, as well as the information that enters and exits their organization. The latter issue is particularly important for multinational companies as the UA has established new compliance standard for data traded between the US and UA member states. What makes modern encryption algorithms so powerful and secure is the number of combinations that they can use to create unique values that would take hundreds of years to decipher. A hash value or hash code is a unique string or characters generated by hash functions or algorithms. Hash functions or hashing take data inputs and return a string of bytes of a fixed size that appear as a string of numbers and letters. For example, you can convert your password Azure123 to this combination. They are designed to be one-way operations, which means that they cannot be reverted to their original input, which is essential for security. Cybersecurity hashing is used for a variety of purposes. For password storage, instead of storage actual password, security systems create password values, making them impossible to compromise. Digital signatures, messages with signatures are hashed or hashed and signed with a private key that is sent to the recipient, who would be the only person who can see the signature. Data integrity check, by generating the hash value of a piece of data and comparing it with the previous hash value of the same data, we can see it has been modified. Also, essentially, hashing is an essential part of encryption algorithms. Without which cybersecurity and forensics would not be possible. All data can be classified into three different states: data at rest, data on the move, and data in the use. These states represent where the data is in the system and how it's been used at any given time. It's important to know that the data can change its state quickly, and that in-depth understanding of each state is important for choosing the right encryption strategies for everyone. Data at rest is the data that does not actively travel between devices or networks or is used in any kind. It is usually stored on hard drives, personal computers, or databases. Because it is often stored in cold storage or on a secure server, it is much less likely to be hacked or accessed by unauthorized personnel. However, since most crucial data is at rest, it's the most valuable type of data for hackers looking to harm you. Data at rest can be information stored in a database or data stored on a hard drive, computer, or some other type of portable device. Then we have data in motion, or data in transit refers to information that travels from one point to another, which includes email, instant messaging, collaboration tools, or any other communication channel. Due its nature or transmission, this type of data is accessible to interception attacks, which is the most common way data can be stolen. This makes data in motion one of the most vulnerable types of data that must be protected by the most sophisticated encryption algorithms. Data in use refers to data that users or other softwares actively access and process. Data is the most vulnerable at this stage, whether it is read, processed, or updated, as it is immediately accessible to the individual, leaving them vulnerable to attacks or human errors. all of which can have serious implications. While each software has its own encryption methods, this is crucial to protect this type of data from any unauthorized access. Protecting your data is important and requires putting in place appropriate privacy system for each type of data. All types of data have different risk. For example, data in use and in motion has significantly more risk than data at rest. It is crucial to know how to protect each type of data. Firewalls and authentications are basic but powerful network security technologies to defend against malicious attacks and hacking attempts. A variety of data security solutions include automatic rules that prevent dangerous files, warn users when they are in danger, and automatically encrypt data in transit. Email encryption guarantees that its content is safe and that all attachments are encrypted. A data loss prevention, or DLP, solution helps businesses to prevent the loss of IP addresses, customer data, and other sensitive information. Implement data controls, increase identity management, as well as use various legal data protection rights. Use end-to-end encryption for drives, mobile phones, and other devices that store sensitive data. The next question is, what kind of data needs to be encrypted? Protect when to encrypt them, what types of encryption to use, and what type of protection is the best. Many types of data should always be encrypted to ensure protection against unauthorized access. These include personal data, financial records, customer information, confidential business data, and any other information that may lead to a breach of privacy or legal implications. Encryption should be applied to all the three data states to ensure maximum protection. Your data should be encrypted at all times while it is not in use, which means whenever it is stored or sent from one place to another. Encryption of other data ensure that no one can access their information, and encryption in transit ensure that no one can even drop while you're sending or receive data. It's great when someone wants to read and use this information, and in this situation it should be decrypted while it is in use and encrypted as soon as its use is no longer needed. There are three types of data encryption. Symmetric encryption uses a single key for both encrypt and decrypt data, which makes it quick to perform encryption, but it's easy to crack if someone gets the key. Asymmetric encryption, this encryption uses a pair of keys, one for encryption and the other one for decryption. These keys can be public or private, allowing them to be easily shared and secured. Hashing is one-way encryption method that converts data into fixed size values based on mathematical formula. Hashed data should be irreversible and used as a verification mechanism. Also, currently AS 256-bit encryption is the most secure encryption standard available. It uses a key length of 256 bits and is widely used in symmetric encryption as a very secure and robust option for data protection. AS256 is an evolution of the AS1 to 8-bit encryption standard that has never been broken in the past and will take hundreds of years to break. This means that AS256, which is much more advanced, will securely keep all data safe without a reliable way to break it. In addition to all of the above, it is always necessary to pay attention to whom and when we give access to sensitive data, especially if these are companies with a large number of users whose personal data could be compromised if there is a security breach. So all of the above is the utmost importance, hence the need to explain in detail, because the consequences can be incalculable if there is abuse or any other kind of omission. So in this segment I want to introduce you something called KMS, or Key Management Service. We already saw how can we use this service, but this is a key management service that you can securely generate and manage AWS encryption keys. If you go inside this service, you can see that this is a regular service, and here you can also create a key by simply clicking on this create key. You can see there is a detailed explanation of how it works, what are benefits and features, and what is related tools and services. If we go to our AWS managed key, you can see that we already have some AWS managed key, and when we use these services, AWS create these managed keys for SNS, FS6, Lambda, S3 and RDS service. As you can see, this is our key ID and this is a free managed key. So this is our key ID. So if you go inside of one of these keys, you can see that general configuration is alias. This is AWS S3. This is our current key, material ID. Status is enabled. Decryption, default key that protects my S3 objects when no other key is defined. When this created, and regionality is single region. So as you can see, the AWS key managed is created, managed and used on your behalf by this AWS service. So you have detailed explanation. Let me read that. So you as a user have permission to view the AWS managed key in your account and audit their use in AWS CloudStream logs. However, we cannot change any protection of AWS managed key, rotate them, change their policies, or schedule them for deletion. So this is a free version. Also, if we see, we have our ARN, Amazon Resource Name, and this key is for S3. So you can see, if you go in any of this key, you will see your status and decryption. And finally here there is a key policy, and as you can see, this is our statement ID, allow access through S3 for all principals in the account that are authorized to use S3. Action is all AWS services. Effect is allow, as you can see. Action is encrypt, decrypt, re-encrypt, generate data key and describe key. Here this is our resources. You can see what is our resources and what is our region. This is our caller alert, as you remember. This is our key ID or account ID, and also there is another list that allows direct access to key metadata to this account. So as you can see, we can describe, get and list all. And here we have our cryptographic configuration. Key type is symmetric, origin is AWS KMS, key specification is symmetric by default, and what is, so if I click on this link, you will learn more about this unofficial documentation page on AWS, as you can see. So there is a lot of information that you can learn here, and there are also specification for your KMS key, what is our symmetric encryption, key default, and so on and so forth. So you can go to these official pages and check all this information. And also this key is used to encrypt and decrypt. So this is AWS managed key. We can go inside any of them and that's it. Then we have customer managed key. So you as a customer can create your own key that will be used for encryption. Here, first step, you must configure your key. We have also symmetric or asymmetric key type. Then key usage, you can use this key usage to encrypt and decrypt data or generate and verify MAC or hash-based message authentication code. In symmetric, as you can see, a single key is used for encrypting and decrypting our data, and asymmetric, there is a public and private key pair used to encrypt and decrypt data. That's it. Also, you have here, if you click on asymmetric, you can encrypt and decrypt, sign and verify, and key pairs using this key agreement, using key pair as a shared secret. So we can choose one of these type of key material for asymmetric key, and you can use another key usage. As you can see, there is a lot of options to choose from for your key. And if I check this box for encrypt and decrypt, you can use RSA, and you already know how we can work with this when we create our VM or instance and when we create our key pair. So it really depends on what do you want to achieve. Then there is a lot of options that you can use. Also, we can see there is advanced option. Key material origin is a KMS key property that represents the source of the key material when creating this key. So you can use this KMS. So AWS creates and manages the key material for the KMS. You can use external key, AWS Cloud HSM key store, and external key store. So you can read all about them here. And finally, if we use this KMS, we can check our regionality for single region key or multi-key. So you can use this key for multi-region, and that is also available. If I go to next, you can add your labels or alias. Then we can go to next. Here, okay, we need to add our name. Let me add some random name. Let's go to next step. This is step number 3. You can use administrative permission, and this is optional. You can use your IAM users and role authorized to manage this key via the KMS API. Also, there is a different roles that you already created here, and there is 14 roles, as you can see, by user or simple role, and you can check this box to allow key administrator to delete this key, or you can uncheck this. Then another optional usage is to define key permissions. So we have roles and IAM roles, user roles for this account. You can use for another account. In the next, you can edit your policy. This is also optional. And here next in the review, you will be able to see all the settings that you set up, and finally click on to create. This is a paid version. Also, you can use this Cloud HSM key store and external key store. So you can create an external key store. Add a name. You need to add a name for this key store. Then use public or proxy connectivity. We have our VPC endpoint. For the public endpoint, you will use this if you want to communicate with external key store proxy. And also, you need to provide your URI proxy endpoint and also some other information. And simply click on create external key. So this is the whole process of. Also, you can upload configuration file. Also, this is the whole process, but the main goal for us is to see this AWS managed key that was created by AWS on our behalf. So this is once again free encryption. Thank you for watching. AWS Certificate Manager, or ACM, is a service that simplifies SSL and TLS certificate management to secure AWS resources and applications. It allows you to securely and easily secure, manage, and deploy both public and private SSL and TLS certificate. ACM addresses the complexity of procuring, renewing, and applying certification, freeing you from manual processes. Key features and benefits of this service are they have central management, so there is a central console, and you can use AWS CLI or APIs to manage your certificates. ACM automatically processes certificate renewals for integrated AWS services, ensuring that your application remains secure without manual intervention. Also, ACM supports both public certificates issued by Amazon Trust Service or ATS and private certificates, which can be used for internal resources. And AWS Certification Manager has a great integration with other AWS services, and you can seamlessly work with various AWS services such as Elastic Load Balancer, Amazon CloudFront, and API Gateway, allowing you to easily secure resources. In some of the previous chapters, I showed you how can you integrate with Elastic Load Balancing or balancing. You can also import third-party certificates into ACM for centralized management, even if ACM does not manage their renewal process. It is a cost-effective, so public certificates issued through ACM are generally provided free of charge. How it works? First, you can request a new certificate through ACM or import an existing one. So there is request or import option. Then integration. As I already mentioned, ACM integrates with various AWS services such as Elastic Load Balancing, Amazon CloudFront, and API Gateway to secure traffic. Then we have auto renewal. ACM automatically renew your certificates before they expire, ensuring continued security. Essentially, ACM simplifies the process of securing your AWS infrastructure by addressing the complexity of certificate management, freeing up to focus on your application and service. A web application firewall, or WAF, helps protect web applications by filtering and monitoring HTTP traffic between a web application and the internet. It typically protects web applications from attacks such as cross-site forgery, cross-site scripting, or XSS, file inclusion, and SQL injection, among others. A WAF is a protocol layer 7 defense in the OSI model, and it is not designed to defend against all types of attacks. This method of attack mitigation is usually part of a suite of tools which together create a holistic defense against a range of attack vectors. By deploying a WAF in front of a web application, a shield is placed between the web application and the internet, while a proxy server protects the client machine's identity by using an intermediary. A WAF is a type of reverse proxy, protecting the server from exposure by having clients pass through the WAF before reaching the server. A WAF operates through a set of rules, often called policies. These policies aim to protect against vulnerabilities in the application by filtering out malicious traffic. The value of a WAF comes in part from the speed and ease with which policy modification can be implemented, allowing for faster response to varying attack vectors. During a DDoS attacks, rate limiting can be quickly implemented by modifying WAF policies. A WAF can be implemented on 3 different ways, each with its own benefits and shortcomings. First is a network-based WAF. This is generally hardware-based. Since they are installed locally, they minimize latency, but network-based WFS are most expensive options and also require the storage and maintenance of physical equipment. The second one is a host-based WAF, and this may be fully integrated into an application software. This solution is less expensive than a network-based WAF and offers more customizability. The downside of a host-based WAF is that consumption of local server resources, implementation complexity, and maintenance cost. These components typically require engineering time and may be costly. Cloud-based WAFs offer an affordable option that is very easy to implement. They usually offer a turnkey installation that is as simple as a change in DNS or redirect traffic. Cloud-based WAFs also have a minimal upfront cost, as users pay monthly or annually for security as a service. Cloud-based WAFs can also offer a solution that is consistently updated to protect against the newest threats without any additional work or cost on the user's end. The drawback of a cloud-based WAF is that users hand over a responsibility to a third party, therefore some features of WAF may be a black box to them. A cloud-based WAF is one of the type of cloud firewall, so you can learn more about cloud firewalls in the upcoming lessons in this course. Of course, you can see in this little diagram, you can see how web application firewalls work versus network firewall. And you can see that and how it works, of course. In the next set of chapters, we will look at how to implement WAF. First, we will look at prevention mode, then in detection mode, and then we will see how can we work with multiple policies of our WAF. AWS WAF, or Web Application Firewall, is a service within AWS that protects your web application from common attacks and unwanted traffic. Here's how it works and why it is useful. What does AWS WAF do? It filters HTTP or HTTPS traffic to your applications on CloudFront, API Gateway, application load balancer, etc. It detects and blocks attacks like SQL injections, XSS or cross-site scripting, brute force attempts, and others. It enables rules you define yourself, like block an IP address, limit the number of requests per second, and apply a capture challenge. How it is used? You can create custom rules or use manage rule sets that AWS already offers. The rules apply to layer 7. This is our application layer, which means it focuses on the content of the HTTP request. Also, there is a great integration with AWS Firewall Manager, which allows you to centrally manage rules across multiple accounts and resources. If you go to our management console in AWS and go to search, let's type WAF. You can see that we have our AWS and Shield. It protects again DDoS attacks and malicious web traffic. So this is a great security service, and we can go inside that service and see what are they offer. So here we are, as you can see, and as I already told you, AWS WAF protects your web application from common web exploits. And here you can see all benefits and features. You can see that it is agile protection against web attacks, save time with managed rules, and it offers a very great capabilities. So if I, for example, go to IP sets, here we can create the group of IP set, and for example, for our main region, this is our North Virginia region, and here you can check all resources, all regions, and here we can create a set of IP sets that you can deny from availability on this region, for example. So you can set an IP set collection or IP addresses. Let me add my name for this IP set. This will be IP set. Description is optional. Here I will choose my region. We are using right now US East North Virginia, and IP version, you can set the list of your IP version, so you can add IP addresses. These IP addresses can be, here it is, this is the list, and here as you can see we added successfully created IP set with a set of different IP addresses. So with these IP sets you can restrict access to your application, for example, or deny them or block them, or allowed access. If I go to Web ACL and choose my US East North Virginia, as you can see I can create web action list. Here there is a few steps that we must use. We have global resources like CloudFront distribution, CloudFront distribution tenants, and AWS Amplify applications. Then we have regional resources like Application Load Balancer, Amazon AP Gateway REST API, Amazon App Runner Services, AWS App Sync API, Amazon Cognito, User Pools, and AWS Verified Access Type. So the first one is for global resources, and the second option is for regional resources. So we can describe our web action control list and associate this list to our AWS resources, and then you will choose your resource type if you want to choose global resource or regional resource. It really depends on you. If you choose a regional resource, you can choose your region. For example, we are using, in this demonstration, we are using US East North Virginia. We can add a name for this list. Let me add some list. This is our WAF ACL1, and here we can, this is our cloud metric name, as you can see, CloudWatch metric name, and finally you can choose this. This is an optional resource. You can choose to add your resource and your resource type, and then select the resource you want to associate with this ACL. I will choose my application balancer, but I need to have this application balancer in place, so we will select, when you select application load balancer, in this resource option you will choose your resource and add to this group. In the next step we need to add our rules and rule groups. Here a rule defines an attack patterns to look for in web request and the action to take when a request match the patterns. Rule groups are a usable collection of rules You can manage the rule groups offered by AWS or find some or from some resellers on AWS Marketplace. You can also set up your own rule. Here, as you can see, in the rules, we can add our rules. So in this drop-down menu, we don't have any rule for now, but as you can see, there is a great explanation. If a request matches a rule, then it will take the corresponding action. The rules are prioritized in order they appear. So when we add a rule, you can edit this rule or delete this rule. Then in this web ACL capacity units, this is WCU used by your, let me first add my manage rule groups. If you remember, we create our IPA set. You can add your own group set, and here you will use your WCU as some kind of currency, and the 5000 is free to use, and if you're using over 1050 is free. Anything that goes beyond that sum will be charged. So the total of WCU cannot exceed 5000 because this is our limit. Also, if you go to AWS WAF pricing, you will see the pricing for this option, and this is some kind of currency that you need to take care of this. And also, this WCU used by the web ACL will be less than or the equal of the sum of the capacity for all the rules in your web ACL. So there is a different option that you can choose, but there is also a limit of how much can you spend. And here you can see this is a resource type, and you can see the price. For web ACL it is a $5 per month, rule is $1 per month, and requesting $0.60, spend 1 million requests. Also there is additional cost for bot control and fraud control. So all these are already calculated. You can also use CAPTCHA or some kind of challenge, and there is also great protection, but everything has its own price. So here it is. You can check all this pricing on official aws.com WAF pricing page. And if you scroll down, you can also define your web ACL action for requests that don't match any rule. If I go to add rules and click on add rule, you can see there is a lot of rules that are managed by group provider, and also there is a charge if you choose one of these from the marketplace sellers. So there is a companies whose job is to create these rules, and then you as a user will use this rule and pay some fees to use them. So if you go to AWS Manage Rule Group, there is a paid rule group, as you can see. So for example, name of this account is account creation and fraud prevention. You can, in the action, you can toggle this option, and you can see this is capacity of 50 WCU, and it costs $10 per month. Also there is free model, but if you want to add to this ACL, simply toggle this option to yes, or until it gets blue. Also there is account takeover prevention. With this description you can see how much it costs and what is the real price. Anti-DDoS protection for layer 7 attacks, bot control, and everything is explained here. So there is a lot of feature that you can use. Also there is a free rule group, so you can use this. You can see what is the capacity and what action does it takes. So it really depends of these categories and what do you want to do. So this is AWS Manage Rule Group. We have some other, for example, Fortinet Manage Group. You can see that capacity is 1000, and you can buy this in AWS Marketplace. This is Fortinet Manage Rules for AWS Policy, APIs Policy, and OWASP Top 10, the complete rule set. So you can add this, just like GeoGuard manage rule group, Imperva, threat stop, and so on. So this is official companies, and they selling their products here, and you can use them if you want. So simply you can add this group. Then when you add manage group, you can set the rule priority, and that's it. If we go back to our create web ACL, let me once again add this name to this ACL. Let me add some random name, and finally, if I go back to our second step, I already explained this rule, and you can add your own group set. You can set the rule type as IP set. If you remember, we already created our IP set, and here we can add a name for rule. So we can use this IP set to identify a specific list of IP addresses. I will now add block IPs sets, and I will now add this group of IP sets that we created in earlier section in our IP set, and here IP set to use as originating address. This is our source IP address. So when the request comes through a CDN or other proxy network, the source IP address identifies the proxy and the original IP address that is sent it in header. Then it will use the caution with option and IP address in header, because headers can handle inconsistency, and you can also choose what do you want to use. You can use source IP address or IP address in the header, and then you will take an action to allow, block, count, use captcha, or challenge. So you can choose this action to take when the request originates from one of these IP addresses in our IP set. Then when you are ready, you can add this rule, and you can see if you go scroll up, there is a block set IP that we added. Capacity is 1, and default web ACL action for requests that not match any rules. You can allow or block this action. Let me choose block. Let's go to next. And finally, here we need to set our priority rules. This is our rule builder, so you can create a custom rule from here, or there is a rule group. You can combine then rules into a single logical set. So you can use this rule visual editor or rule JSON editor to create your own. And finally, as I already mentioned, here you can add this priority, capacity, and so on and so forth. So as I already mentioned, there is a rule visual editor, and if I request, for example, this will be in JSON file. So here, as you can see, you can use add a name, you can use regular rule or rate based rule. So if a request, for example, matches the statement, so you will add your statement. First, of course, you need to add a name for your rule. For example, block SQL injection. We are using a regular rule. Here you can choose between these options: matches the regular statement, matches all the statement, or at least one of this statement, and does not match any statement. Then you can choose your statement. Let me find appropriate statement. Originates from country in or originates from IP address. So you can use these components to get even more granular, and we are using our body, so you can use content type as plain text or JSON. So you can go even deeper with this rule and create your own rule. So you can add this plain text that it contains SQL injection, then action will be block. As you can see, here I will find some different transformation, and here you can do what do you want to AWS WAF when this, what do you want to do, to inspect, match the thread or no match, then thread the web request as no matching the rule statement, and so on. So there is really a different option, and you can go more granular to create your own rule. There is also a sensitivity level. You can specify how sensitive you want this inspection for SQL injection attacks to be. Then you can be low or high, and there is a explanation so you can read it for yourself. Then you can choose action when this request matches the statement that we just configured for our SQL injection. And here, if you choose high, for example, you can add to block this. So this is how can you use IPset builder or builder to create your own rule in this wizard. So this is just a simple example, and we are using our SQL injection as our example. So if that request contains the SQL injection, that it will be blocked. Let's add our rule, and if I scroll up, you can see that we now have two rules, both are block, and you can set up capacity. So the capacity is 1 for block set IP and 30 for block SQL injection, and also you can move this up, so then this block SQL injection will be our first on that list. You can also add CloudWatch metrics to monitor your web request. This is our step number 4. Let's click on next again. You can choose your request sampling options if you want, and finally in the review and create, we can see everything that we added, all settings that we had in our web ACL, and finally we will hit on create to create this. Here you can see to create this web action control list, and you can see that we are using 31 of 5000, and finally let's hit on create, and this is our web ACL. So if I now go to our rule group and create a new rule group, you can see that we can again create a new rule and add this group to this web ACL. We can use also IP group of IPset. So I will now delete this rule. Let me type delete. And this is the simplest version. How can you use AWS WAF and shield and to protect your application. Let's delete everything that we created, and I hope that this was helpful and that you now have more understanding about this resource. So you can see we don't have any ACL, and finally you can also add your resources to this list, and all these IP addresses and SQL injection option that we added will be for this application load balancer, for example. Thank you for watching. The next service is AWS Artifact. Key features of this service is that users can access and manage compliance information through the user interface. This is a centralized location for all compliance documents and agreements. So AWS Artifact acts as a hub for all these documents and agreements. Also, it includes various certification, attestation, and audit reports such as SOS, SOC, ISO, and PCI. Simplifies the process of demonstrating compliance with safety standards and regulation. Essentially, AWS Artifact helps organizations to verify the security and compliance of their use and AWS infrastructure, making it easier to meet regulatory requirements and pass audits. This is a key feature of AWS Artifacts, and report section is a key feature, so you as a user can access and download a variety of reports that confirm the security and compliance of AWS infrastructure and services in compliance with various international regulatory standards. Here are some of the main reports commonly accessed through AWS Artifact. SOC reports. These are Service Organization Control reports, including SOC 1, 2, and 3, that provides insight into AWS control and processes related to the security, availability, integrity of processing confidentiality, and system privacy. Also, there is ISO certification. AWS provides a number of ISO reports such as 27001, 27017, and 27018. These certifications are essential for customers who need to adhere to international standards and for managing information security and protecting personal data in the cloud. Also, there is some PCI DSS compliance. This is Payment Card Industry Data Standard reports that are vital for any organization that process credit card transaction. These reports confirm that AWS services are secure to meet the requirements of the PCI DSS standards. You can use these reports to continuously monitor, audit your suppliers. You can check your operational effectiveness of AWS security controls, prove the compliance of your own AWS infrastructure, and more. AWS Artifact contracts contain the contracts you have with AWS. You can use AWS Artifact contracts to review, accept, and manage contracts with AWS for your individual AWS account or AWS account within your AWS organization. One of the key benefits of this service is that you can access or decline reports for the entire AWS organization. Only the management account can accept agreements in the AWS Artifact Organization Agreements tab. Here are some of the major contracts that you can access through AWS Artifact. There is customer agreements. Standard AWS customer agreements define the general terms and conditions under which AWS services are provided. They are necessary for all AWS customers to understanding their rights, responsibilities, and operational boundaries of these services. So you can find them at AWS Artifact Contract tab for the order. Terms of service. Specific terms related to AWS services can be found here. They detail additional obligations of usage limitations, providing clarity for the implementation of specific AWS solutions. Also, there is something called DPA, or Data Processing Addendum. This is crucial for clients who are concerned about data protection and privacy, especially those operating in GDPR-regulated jurisdictions. DPA provides conditions for the processing and security of personal data. Business Associate Supplies, or BAA, this is for customer subject to US health regulations such as HIPAA. BAA is required for compliance with highly protected health information, or PHI, on AWS. And here is how it works. You can see we have our AWS Artifact. This is our access compliance related information that matters to you on demand. You can download this report, access AWS or third-party compliance report. You can accept the agreement. You can review, accept, and manage agreement for specific regulations. And finally, in the manage notifications, you can set up notifications when certain reports become available. So if you go to our AWS Artifact and if you go to agreement option, you can see there is a lot of agreement, and you can check all these agreements. For example, AWS Australian Notifiable Data Breach Addendum, it is inactive. And here you can see all these agreements that you can download, for example. And description. So here you can download this agreement, you can accept this agreement, or if you download or simply terminate this agreement. You have organization agreement. So when we have an organization, an AWS organization, then we can use this organization agreement. Also, we have reports. There is, as you can see, 344 agreement. And here you can also see all the regulations and reports about this agreement. So this is all available in AWS Artifact. So if you go inside this service, you can see AWS reports. You can use this to find any reports. For example, I saw, here it is, some statement, and here it is. We can now download this report or copy this URL for this report. So also we don't have any third-party reports for now. And finally, the next tab is notification. So we need to contact our administrator to set up this, but as you can see, there is also availability to be notified if some of these agreements become available. And also there is a great documentation about Artifact on the official documentation page in Amazon, so you can read more about Artifact here, about security and compliance, but the main option is agreement and reports, so you can check this out. Thank you for watching. AWS Secret Manager is just a service that allows users to securely store, manage, and retrieve classified data throughout its lifecycle, and it helps to protect access to applications, services, and IT resources by providing a centralized and secure way to manage credentials, API keys, and other classified data. Key benefits of AWS Secret Manager that it offers a secure storage for secret information that is encrypted addressed using AWS KMS keys and securely transmitted over TLS. This is a centralized management for classified information, and it is stored and managed in this central location, making it easy to control access and monitor usage. AWS Secret Manager integrates with AWS IAM to provide fine-grained access control, ensuring that only authorized users and applications can access certain secrets. Also, in the classified information can be rotated on a schedule or on demand, which help minimize the risk of compromise. Also, integration with other AWS services are great, so you can integrate with services such as Amazon RDS, Amazon Redshift, and more. Also, you can integrate with Secret Manager to store and retrieve database credentials. There is a reduced hard coding. By dynamically downloading secret at runtime, developers can avoid hard coding sensitive information in their application, reducing the risk of disclosure. Of course, this is also a cost-effective service, so you will pay per use service with no upfront cost or no long-term commitments. Here is how it works. First, users can store secret such as database credential, API keys, or other sensitive information in the Secret Manager. Then, access to secret is controlled using IAM policies, which allow users and applications to download only the secret they need. Third, you can download secrets, so application can download secret during execution by calling the Secrets Manager API. And also there is a secret rotation. The Secret Manager can be configured to automatically rotate secrets on a schedule or on demand, ensuring that long-term secrets are replaced with short-term ones, reducing the risk of compromise. AWS Secret Manager is a secret management service that helps you protect access to your application, services, and IT resources. This service allows you to easily rotate, manage, and retrieve database credentials, API keys, and other secret data throughout their life cycle. Using Secret Manager, you can secure and manage secrets that are used to access resources in the AWS cloud, on the third-party services, and on-premises. AWS Secret Manager protects access to your application, services, and IT resources without the upfront investment and ongoing cost of maintaining your own infrastructure. Secret Manager is intended for IT administrators who are looking for a secure and scalable method for storing and managing secrets. Security administrators responsible for meeting regulatory and compliance requirements can use Secret Manager to track and rotate secrets without the risk of impacting applications. Developers also who want to replace hard-coded secrets in their applications can programmatically download secrets from Secret Manager. Amazon Guard Duty is a threat detection service offered by AWS that continuously monitors your AWS account, workloads, and data for malicious activity and unauthorized behavior. It uses artificial intelligence, machine learning, anomaly detection, and threat intelligence to identify potential security threats, providing detailed findings and remediation. Guard Duty actively monitors your AWS environment, including accounts, workload, and data, to identify suspicious or malicious activity. It uses a combination of artificial intelligence and machine learning techniques, anomaly detection, and threat data to detect a wide range of threats. Also, when the potential threats are identified, Guard Duty generates security findings that provide detailed information about detected activity, including the affected resources and the type of threat. Guard Duty sites can be integrated with other AWS services such as Security Hub and CloudWatch, as well as third-party security tools, enable security response and automation and remediation. Also, Guard Duty analyzes various data sources, including AWS CloudTrail data management events, VPC flow logs, DNS logs, Kubernetes audit logs, RDS logging activity, S3 data events, and more. It is cost-effective, so you will pay only what are you using. It also allowing you to scale your threat detection capabilities based on your needs. AWS is offering a free trial, 30 days, for the new users to explore the features and benefits of Guard Duty according to AWS documentation. Also, Amazon Guard Duty, as I already told you, is a threat detection that continuously monitor, analyze, and process AWS data sources and logs in our environment. It uses threat intelligence feeds, such as list of malicious IP addresses and domains, file hashes, and machine learning models to identify suspicious and potentially malicious activity in our AWS environment. So, here are a list of overview of potential threat scenarios that Guard Duty can help you to detect. For compromising stolen AWS credentials, stealing and destroying data that can lead to a ransomware event, unusual logging event patterns in supported versions of the Amazon Aurora, and Amazon RDS database engine indicating anomalous behavior, unauthorized crypto mining activity in our Amazon Elastic Cloud or EC2 container instance and workloads, the presence of malware in our EC2 container instances, and workloads in newly uploaded files in our Amazon Simple Storage buckets, operating system network, and file levels events that indicate unauthorized behavior on our Amazon Elastic Kubernetes service, clusters, Elastic Container Service, Fargate Task, Amazon EC2 container instances, and workloads. In the next chapter, we will talk about AWS Inspector. Amazon Inspector is an automated security assessment service provided by AWS. It helps improve the security and compliance of your AWS resources by continuously scanning for software vulnerabilities and inadvertent network exposure. It automatically detects and evaluates workloads such as Amazon EC2 instance, container images, and AWS Lambda features. Here are more detailed explanation. So, Amazon Inspector is primarily a vulnerability management service, identify potential security vulnerabilities in our AWS environment. It automatically scans our assets, including EC2 instances, container images in Amazon ECR or CI/CD tools, and Lambda functions without the need for manual intervention. Inspector provides a risk assessment to help prioritize remediation effort, reducing time to resolve or MTTR. Also, it has a great integration with other AWS services such as AWS Security Hub, providing a comprehensive overview of our security posture. Inspector uses a knowledge base of policies mapped to security standards and vulnerability definitions, which are regularly updated by AWS security researchers. The inspector automatically detects our AWS resources, including EC2 instances, container images, and Lambda functions. Also, it generates finding data and detects software vulnerabilities or network configuration problems. The inspector continuously scans our environment, allowing vulnerabilities to be detected in near real time. With AWS Organization, you can manage the inspector across multiple accounts, delegating administrative tasks to a specific account, and also centrally manage multiple Amazon Inspector accounts. In our AWS environment, if you have some multiple accounts, we can centrally manage our application through a single account using AWS organization. Using this approach, you can designate the account as a delegated administrator account for Amazon Inspector. Amazon Inspector can be activated for our entire organization with just a single click. In addition, you can automate the activation of the service for future members whenever they join the organization. The Amazon Inspector delegated administrator account can manage data on findings and specific settings for members of the organization. This includes viewing aggregated details or finding for all members' accounts, activating or deactivating scans for members' accounts, and viewing scanned resources within the AWS organization. With AWS Inspector, we don't have to manually schedule or configure a scan for evaluation. Amazon Inspector automatically detects and starts scanning our eligible assets. Amazon Inspector continues to assess our environment throughout the life cycle of our assets by automatically rescanning resources in response to changes that could introduce a new vulnerability, such as installing a new package in an instance on EC2 instance, installing a patch, and when a new common vulnerability and exposure or CVE is released, the effect is a resource. Unlike traditional security scanning software, Amazon Inspector has a minimal impact on the performance on our fleet. When vulnerabilities or open network paths are identified, this service produces a finding that you can investigate. The findings include comprehensive detail about the vulnerability, the affected resources, and recommendation for remediation. If it remediates the finding appropriately, Amazon Inspector automatically detects the remediations and closes the find. An Amazon Inspector collects this information about our environment through scans. It provides severity ratings specifically tailored to our environment. Amazon Inspector examines the security metrics that make up the National Vulnerability Database, or NVD, core score for vulnerability and tailors them to your computing environments. For example, the service may reduce to Amazon Inspector finding result for an Amazon EC2 instance if the vulnerability can be exploited over the network, but no open network path to the internet is available from the instance. This score is in CVSS format and is a modification of the common vulnerability scoring system base score provided by National Vulnerability Database. The Amazon Inspector dashboard offers an overview of findings from all over our environment. From the dashboard, we can access to details of these findings. The dashboard contains simplified information about the scan coverage in our environment, our most critical findings, and which resources have the most finding. The risk-based remediation panel in the Amazon Inspector dashboard displays the findings that affect the largest number of instances and images. This dashboard makes it easy to identify the findings with the greatest impact on our environment. You can review the details of the finding and review proposed solution. Amazon Inspector is available in most AWS. AWS Config is a service that allows you to evaluate, revise, and evaluate the configurations of our AWS resources. It provides a detailed overview of your AWS resources, including the configurations, relationship, and how those configurations have changed over time. Essentially, it helps us to understand, track, and manage the compliance of our AWS environment. AWS Config keeps a record of our AWS resources, including their configuration and relationship. It records changes to these configurations, allowing you to track how resources have evolved over time. You can define rules within AWS Config to assess the compliance of our resources with your desired configurations on security standard. Also, AWS Config then automatically evaluates our resources against these policies and flags any non-compliant resources. By providing a detailed history of resource configurations, AWS Config helps you troubleshoot operational issues and identify the cause of the problem. AWS Config plays a critical role in maintaining a secure and compliant AWS environment. It helps you implement security policies, track changes, and identify potential vulnerabilities. Also, AWS Config can also be used to track resource configuration across other cloud services or service providers or on-premise environments, expanding its usability beyond AWS. Integration with other services, so you can integrate this service with CloudTrail, CloudWatch, System Manager to provide a comprehensive overview of our AWS environment. When you turn on AWS Config, it first discovers the supported AWS resources that exist in our account and generates a configuration item for each resource. AWS Config also generates configuration items when a resource configuration changes and maintains historical records of our resource configuration items. From time to time, you run the configuration recorder. By default, AWS Config creates configuration items for each supported resource in that region. If you don't want AWS Config to create configuration items for all supported resources, you can specify the types of resources you want to track. Before specifying the type of resource that AWS Config will monitor, you must check resource coverage by region availability to see if the resource type is supported in AWS region. Where are you setting up AWS Config? If AWS Config supports a resource type in at least one region, you can enable recording of that resource type in all regions that AWS Config support, even if that resource type isn't supported in AWS region where you are setting up this AWS Config. AWS Config also track all changes to our resources by calling the describe of list API for each resource in our account. This service uses the same API calls to record configurations details for all collected resources. For example, removing an exit rule from VPC security group causes AWS Config to run a describe API call on the security group. AWS Config then calls the describe API on all instances associated within that group, security group. Updated configurations of that security group or resource and each instance or related resources are recorded as a configuration item and are delivered during configuration to the Amazon Simple Storage Service or Amazon S3 bucket. AWS Config also tracks configuration changes that are not triggered by the API. AWS Config periodically examines resource configurations and generates configurations item for configuration that have changed. If you use AWS Config rules, AWS Config continuously evaluates your AWS resource configurations for the desired settings. Depending on the rules, AWS Config will evaluate your resource either in response to configuration changes or periodically. AWS Config, when this service evaluates your resource or resources, it calls AWS Lambda rule function. The function returns the compliance status of the estimated resource. If a service or resource violated the terms of the rule, AWS Config marks the resource and the rule as non-compliant. When the compliance status of the resource change, AWS Config sends a notification to your Amazon SNS DEM. In the next chapter, we will learn about AWS Make. In our console, in the search bar, we can type simple config, and you can see AWS Config. Here is our service that will track resource inventory and changes. So if you go inside our AWS Config, you can see that there is a lot of options, and let's first click on our link. And here it is, we are in our service. Here you can simply get started and check all the features, benefits, and use cases. If I go to set up AWS Config, first we need to see all these recording methods. So you can choose to customize AWS Config to record configuration changes to all supported resource type, or the only resource support specific resources. If by default it is already selected all resource type with customers overrides, so AWS Config will record all current and future supported resources types for this North Virginia region. Also, there is an option for specific resource type, so this service will only record the resource types that we specified. And you can see in the default settings, we can set up our recording frequency. By default, here is our specific resource type, so we can choose our resource type from the list of this. For example, you can choose EC2 let me find some EC2. We can set up, for example, EC2 fleet, and here you can choose your frequency if you want to record this continuous or daily. So this is a specific resource type, and you can add another one and choose another frequency, and that's it for a specific type. If you go back to our old resource type with customizable overrides, we can use this continuous recording, and it will record configuration changes continuously whenever a change occurs. Or you can choose daily recording. It will receive configuration data every day if a change has occurred. So it also, by choosing one of these, this will impact the cost of your bill. As you can see, in the override settings, we can use something called resource types to override. You can override this recording, and you can choose an override. If you see here, this is our daily recording. First, in the override settings, we can add our resource type. So as you can see, once again, we can check our resources. And finally, we can add a new type and choose our override. I will now remove this, and we can add our data resource type, and here in the data governance, IAM role for AWS config will be created by link service, or you can choose a role from our account. So if we have some pre-existing roles, we can add this role, but first we need to create this role, of course. Here it will create automatically, and if you want delivery channel, you can add your bucket, choose a bucket from our account, or choose bucket from some other AWS account, as you can see. And it is possible to do anything. And here you can also stream configuration changes to our Amazon S3 topic. So here you can create a topic, choose a topic from your account, or choose a topic from, of course, another account, and you can add your topic name, as you can see. So in this config option, you can set up a really granular option, and there is a various option that you can choose from. If I go to next, first we need to provide our bucket name. Let me add some random name to our bucket. And here, this is rules, as you can see. So here there is 154 rules. So in the step number 2, we can choose our rules, for example. And here, if you check this box of one of these rules, you can see all trigger type and resource type and description of this rule. So let me find a resource type, for example, one of AWS EC2 instance. I will check this, and for example EC2 volume, and click on apply. Here you can see all the names or rules that we can add, and simply by adding these rules in the review step, we will you can add your changes, edit your changes, and if you choose confirm, this will set up our AWS config. So this is how can you work with AWS config, which is a which can record and evaluate configurations of our AWS resources. Amazon Macy is a security service that uses machine learning and pattern matching to detect, classify, and protect sensitive data stored in Amazon S3. It helps users identify and manage sensitive information, assess security risk, and automate data protection, especially in relation to personal information, or PII. Key features and functionality of this service: So Macy automatically scans your S3 buckets to identify and classify sensitive data such as personal information, financial information, and credentials. It provides an inventory of our S3 bins, including information about their size, number of objects, and whether they are encrypted or publicly accessible. Macy also generates findings related to potential security and privacy risk, such as publicly available buckets and data containing service-sensitive information, not bins, not buckets. Macy also allows us to exclude buckets from automated detection to help us manage and reduce cost, and it has great integration with other services such as AWS Organization for multi-account management and Amazon Event Bridge for event-driven workloads. We can also use Macy findings to initiate automated actions such as data masking or access control changes to protect sensitive data. How it works? First, you will enable Macy on our AWS account and specify the region where you want to use it. Then the second one is data inventory. Macy starts by providing an inventory for our S3 bucket. The third step is to detect sensitive data. It then uses the machine learning and pattern matching to analyze the object in our buckets and identify sensitive data. The fourth step is to see what are security findings. So Macy generates security findings based on its analysis, which you can view on the Macy console or through other integration. And the fifth step is remediation. You can use our findings to initiate automated actions or manual interventions to address potential security risk. So Amazon Macy is a data security service that detects sensitive data using machine learning and pattern matching, provides insight into data security risk, and enable automated protection against those risks. To help you manage and secure posture with your organization, Amazon Simple Storage Service database, Macy provides you with an inventory of your S3 general buckets and automatically evaluates and tracks that buckets for security and access control. If Macy detects a potential security or privacy issue with your data, such as shopping cart that becomes publicly available, Macy generates a finding that you can review and remediate if necessary. Macy also automates the discovery and reporting of sensitive data to give you a better understanding of the data your organization stores in Amazon S3. To detect sensitive data, you can use the built-in criteria and techniques that Macy provides, custom criteria that you defined, or a combination of these two. If Macy detects sensitive data in S3 object, Macy generates finding to notify you of the sensitive data it found. In addition to findings, Macy provides statistics and information that provides insight into the security status of your Amazon S3 data and where sensitive data may reside in your data estate. Statistics and information can guide your decisions to conduct deeper research into specific S3 groups and objects. You can view and analyze findings, statistics, and other information using the Amazon Macy console or the Amazon Macy API. You can also take advantage of Macy integration with Amazon Event Bridge and AWS Security Hub to track, process, and remediate findings using other services, applications, and systems. AWS Detective is an AWS service that helps security teams investigate potential security issues and suspicious activity in their AWS environment. It automatically analyzes log data from various AWS services and builds a graphical model to visualize the relationship between resources, users, and security findings, making it easy to identify the root cause of security incidents. Key features and functionality of AWS Detective is that the Detective collects and analyzes data from CloudTrail logs, VPC flow logs, and EKS audit logs, Security Hub findings, and Guard Duty findings. It uses machine learning, statistical analysis, and graph theory to create a visual representation of the visual between security findings and affected assets. Detective helps security teams quickly understand the scope and impact of security problems by visualizing the connections between different events and resources. Also, it integrates with services such as Guard Duty for threat detection, Security Hub for secure findings, and Amazon Security Lake for centralized log storage. Detective provides visualization and summaries of safety findings, helping teams quickly triage potential issues and conduct thorough investigation. The Detective helps to determine whether security findings are really concerned by providing context and connections to other related activities. How it works. First, you will enable detective for your AWS account and it start collecting data from your AWS resource. Then the detective analyzes trillions of events from a variety of data sources, including IP traffic, AWS management operations, and potentially malicious activity. It creates a graphical model that represents the relationship between different entities, like users, resources, etc., and security findings. Then you can use the graph visualization to explore connections, identify patterns, and understand the scope of the security incident. Essentially, Amazon Detective acts as a co-pilot of a security investigation, helping security teams quickly understand what happened, who was affected, and what is the potential impact is. The detective automatically extracts time-based events such as login attempts, API calls, and network traffic from AWS CloudTrail and Amazon VPC flow logs. It also lists the findings discovered by guard duty. From these events, detective uses machine learning and visualization to create a unique interactive view of the behavior of your resources and the interaction between them over time. You can explore the behavior graph to examine various actions, such as failed login attempts or suspicious API calls. You can also see how these actions affect resources, such as an AWS account and Amazon EC2 instances. You can customize the scope and timeline of the behavior chart for different tasks, quickly investigate any activity that is out of the norm, or you can identify patterns that may indicate a security problem. Understand all the resources that are affected by the findings. Detective-friendly visualization provides the basis for account information and summarize it. These findings can help answer questions such as, is this an unusual API call from this role? Or is this spike in traffic expected from this instance? With Detective, you don't have to organize any data or develop, configure, or tweak your own queries and algorithms. There are no upfront costs, and you only pay for the events analyzed with no additional deployment, software, or other fees to subscribe. AWS Security Hub is a cloud-based security posture management service that provides a comprehensive view of your security posture in AWS. It helps you analyze security trends, identify and prioritize critical security issues, and automate responses to those issues. It achieves this by aggregating and correlating security findings from different AWS services and third-party partners. All of these services that we have mentioned in the previous chapters are located in this service as a service group or hub that provides you with unified services and facilitates the work and security of your resources. So the Security Center provides a single place to view and manage security alerts and findings from various AWS services such as Amazon Guard Duty, Amazon Inspector, Amazon Macy, as well as from integrated third-party security products. It automatically performs security audit based on AWS best practices and industry standards, such as CIC AWS Foundation Benchmark, and provides findings based on the result. The Security Center helps prioritize critical security issues by correlating and enriching security signals into actionable insight. It also supports automated response workflow to streamline remediation and reduce risk. The Security Center can integrate with AWS organization to automatically enable security audits and residency on all member accounts, providing a comprehensive view of the organization's security posture. Also, it helps identify and remediate security vulnerabilities and help monitor your compliance with security standards. Security Center supports multi-AWS accounts and can aggregate findings across different AWS regions. AWS Security Hub, which is still in preview, prioritizes your critical security concern and helps you respond at scale. It detects critical problem by correlating and enriching signals, for example, from threat detection and vulnerability management. This allows you to detect and prioritize active risk in your cloud environment. Security Hub transforms security signals into actionable insight and offers intuitive visualization and natural language summaries so you can quickly make more informed security decisions. For example, it can identify when a publicly exposed resource with a highly exploited vulnerability also has access to a repository with sensitive data. Security Hub also provides automated response workflows to streamline remediation at scale, so you can reduce security risk, improve your team's productivity, and minimize potential operational disruption. Security Hub provides a more comprehensive view of your security posture to protect your cloud environment. Security Hub also correlates and enriches security findings to prioritize critical security issues across your accounts and AWS regions. And the integrated dashboard provides clear visualization through customizable widgets that display exposure summaries, threat trends, and security coverage. Through automated analysis and risk-based prioritization, you can more quickly understand which issues require urgent attention, helping you make informed decisions about how to mitigate risk in your cloud environment. The Security Center connects security findings to prioritize critical issues in your cloud environment. By analyzing signal from services such as Amazon Inspector and Amazon Macy, the Security Center connects associated vulnerabilities and misconfigurations to help you understand potential exposures. Through this correlation, you can quickly assess security issues and understand how different findings combine to threat potential attack paths. You can gain a clear view of potentially exploitable resources and make confident decisions about which issues need to be addressed first, helping you identify complex security scenarios that can be missed when viewed in isolation. The Security Center connects and enriches security findings to prioritize critical security issues across your accounts and all AWS regions. The integrated dashboard provides clear visualization through customizable widgets that display exposure summaries, threat trends, and security coverage. Through automated analysis and risk-based prioritization, you can more quickly understand which issues require urgent attention, helping you make informed decisions about how to mitigate risk in your cloud environment. And in the next chapter, we will talk about AWS. Misuse of AWS refers to any use of Amazon Web Services that violates the AWS term of service or the acceptable use policy. This includes a wide range of activities that are considered malicious or harmful, such as spamming, phishing, denial of service, DDoS or DOS, attacks, copyright infringement, and intrusion attempts. AWS Abuse Report are notifications sent to users when their resources are suspected or engaging in such prohibited activities. Example of AWS abuse. So we have email abuse, sending spam or hosting offensive mail content on AWS resources, misuse of network activities, engaging in activities such as port scanning, intrusion attempts or DDoS attacks from AWS resources, phishing, using AWS resources to create fraudulent websites, or send emails designed to trick users into revealing sensitive information, copyright infringement, hosting or distributed copyrighted material without permission, intrusion attempts, an attempt to gain unauthorized access to system or data on AWS or other networks. How AWS handle this abuse? So, AWS actively monitors and investigates report of abuse. When abuse is detected, AWS can send a report of abuse to the user with details of the suspected breach. Users are expected to take action to address the issue, such as removing malicious content or securing their resources. AWS may suspend or terminate accounts that are found to be involved in repeated or severe abuse. Then, AWS abuse reporting. If you suspect of any kind of misuse of AWS service, you can report it to AWS Trust and Safety by sending an email to trustandsafety@support.aws.com or using the AWS abuse reporting form. When logging in, you need to provide your account ID and details of the suspected abuse. You can also report abuse in connection with AWS Data Exchange using the form provided. Keeping up with security. So, the first thing you need to do, you need to familiarize yourself with AWS acceptable use policy and term of service. You can implement best security practices such as strong password, multi-factor authentication, and least privileged access control. All of this we'll learn during this course. You can also monitor your AWS environment regularly for suspicious activity. Keep your software and system up to date to prevent vulnerabilities. If you receive a report of AWS abuse, respond immediately and take the necessary corrective action. When we start this course, I created my AWS account. If you remember, we talked a lot about root user. What are the privileges, what are the security options, and how can you work if you are AWS root user. So in this chapter, I want to talk about AWS root user privileges. If you are a root user, then this lesson is very important. When you first create an Amazon Web Service or AWS account, you start with a unique sign-in identity that has full access to all AWS services and resources in the account. This identity is called the root user of the AWS account. The email address and password you use to create your AWS account are the credentials you use to log in as the root user. You can use the root user only to perform tasks that require root level permissions. The AWS root user is the first cloud service identity that is created by default when you create a cloud service provider account. It is important to note that all cloud service providers have some form of root account. Depending on the provider, you may be allowed to have more than one such account. The more root accounts you have, the greater the risk area. Because of its omnipotence, the AWS root account is a prime target for threat actors because it can control everything in your instance and in your account profile. While you can log in to AWS as a root user using the email address and password you use to create account, as a security best practice, it shouldn't. This principle of safety is especially true in the production environment. As a security best practice, the default root account should be disabled or even deleted, and should never be used unless absolutely necessary. So, if you are a root user, then you must consider this. The root user identity has full access to all resources in the account and associated instances. This explains the risk they pose if they are compromised. The only way to restrict root permissions to a user is to apply the service control policy to your account, but even this control has its limitations. With above considerations in mind, avoid using your root user to perform everyday tasks, even administrator tasks. To mitigate the risk of the default root account, organizations should create an IAM user with administrator privileges to manage their AWS environment according to the principle of least privilege. Regardless of the type of the account, the cloud presents unique challenge for all identities. Consider these best practices for AWS root users when managing identities in the cloud. Do not use root access key for anything except those rare use cases where it is absolutely unavoidable. If your cloud service provider allows it, consider disabling root access or even deleting the root account. If you can overcome the potential issues listed above, enable multi-factor authentication or MFA for all your root users as well as all IAM users. Single-factor authentication should never be used to access the cloud. Never share the credentials of your root user or IAM user with anyone for anything at any time. Create separate IAM users for anyone who needs to access your account. Accounts should never be shared, not even for machine identities. Always implement least privileged access for your IAM users. Consider this identity completely closed, as most cloud service providers do not grant any privileges when creating an account. Have a robust password policy for all users and consider a privileged access management or PAM solution to protect them and perform management. The widespread use of highly privileged super user accounts such as root or administrator, even with MFA enabled, can introduce an unnecessary risk. Limiting exposure to privileged account or access key is to mitigating risk for all identities in the cloud. Anyone who has root user credential for your AWS account has unlimited access to all resources in your account, including payment information. You can change or reset the password for the root user and create or delete access key, IDs and secret access key for your root user. Then, although we have learned a lot about the root user so far, the intention of this chapter was to remind you once again of the importance of this feature. So if you follow these tips that I have written for you, your account and all users will be in a great position compared to those who do not follow certain rules and instructions. That is why it is very important to understand security in the cloud as one of the 5 basic concepts when starting to work with account and services in any cloud environment, or provider that are available to us, AWS, GCP, or Azure. Now that we know the process, let's learn what is a model in machine learning. So in machine learning, a model is a representation of data that is trained to recognize patterns and make predictions or decisions. It is essentially a learned set of rules or parameters that allow a machine to understand data and make informed conclusions about it. Think of it as a trained expert who can quickly identify patterns and make accurate predictions based on past data. A machine learning model is just an object stored in a file locally on our laptop that is trained to recognize certain types of patterns. You train the model over a set of data, giving it an algorithm it can use to reason and learn from that data. Once you train a model, you can use it to think about data it hasn't been seen before and make predictions about that data. For example, let's say you build an app that recognizes a user's emotion based on their facial expressions. You can train a model by providing it with images of faces, each tagged with a specific emotion. And you can use that model in an application that can recognize any user's emotion. Machine learning models are very powerful resources that automate multiple tasks and make them more accurate and efficient. Machine learning processes new data and scales the growing demand for technology with valuable insight. It improves performance over time. This state-of-the-art technology has various advantages such as faster processing or response, improved decision-making, and specialized services. Also, a machine learning model is a set of programs that can be used to find patterns and make decisions from an unseen set of data. These days, NLP, or natural language processing, using a machine learning model to turn unstructured text into actionable data and insight. You may have heard of image recognition, which is used to identify objects such as a boy, a girl, a mirror, a car, a dog, etc. The model always requires a set of data to perform various tasks during training. During the training, we use a machine learning algorithm for the optimization process to find certain patterns or outputs from the data set based on the task. Well, in the next chapter, we will learn what is machine learning in the Azure cloud. Welcome back. Before we start this section, it is time to learn more about what is machine learning or ML and what is artificial intelligence or AI. So, in these couple of chapters, we will first see and I will introduce you to the basic terms. So let's get started with machine learning. Machine learning is a branch of artificial intelligence that allows algorithms to detect hidden patterns within data sets. It allows them to predict new, similar data without explicitly programming for each task. Machine learning finds application in various areas, such as image and speech recognition, natural language processing or NLP, recommendation systems, fraud detection, portfolio optimization, and task automation. The impact of machine learning extends to autonomous vehicles, drones, and robots, improving their adaptability in dynamic environments. This approach marks an advancement in which machine learn from data examples to generate accurate results, closely intertwined with data mining and data science. The ability of neural networks to take an additional layer and thus work on more complex problems increased in 2026 with the invention of the technique of greedy layer pre-training, in which it was discovered that it was easier to train each layer of the neural network individually than to train the entire network from input to output. This improvement in neural network training has led to a type of machine learning called deep learning, in which neural networks have 4 or more layers, including an initial input and a final output. Moreover, such as networks are able to learn unsupervised, that is, to detect features in data without any initial query. Among the advances in deep learning has been advanced in image classification, in which specialized neural networks called convolutional neural networks or CNNs are trained for features found in an image set of different types of objects. CNN can take the input image, compare it to the characteristics of the image in its pre-training set, and classify the image as an image of, for example, a cat or an apple. One such network, PRELU net by Kaming, he and collaborator at Microsoft Research classified images even better than human did. Deep Blue's achievement in defeating world chess champion Garry Kasparov surpassed DeepMind's AlphaGo, which mastered Go, a much more complicated game than chess. AlphaGo's neural networks learn to play from human players and by playing alone. He defeated the best player, Lee Sedol, 4-1 in 2016. AlphaGo, in turn, outperformed AlphaGo Zero, who, starting only from the rules of the game, eventually managed to beat AlphaGo 100-0. A more general neural network called AlphaZero was able to use the same technique to master chess and shogi. Machine learning has found applications in many fields besides games and image classification. The pharmaceutical company Pfizer used this technique to quickly search for millions of possible compounds in the development of a drug called COVID-19, Paxlovid. Google used machine learning to filter spam from a Gmail user inbox. Banks and credit card companies use historical data to train models to detect fraudulent transactions. Deepfakes are AI-generated media that is produced using two different deep learning algorithms, one that creates the best possible replica of a real image or video and another that detects whether a replica is fake and, if so, reports the difference between it and this original. The first algorithm produces a synthetic image and receives feedback on it from the second algorithm, then adjust it to make it look more real. The process is repeated until another algorithm detects fake images. Deepfake media, images that do not exist in reality or events that never happened. Widespread deepfakes include an image of a Pope Francis in a puffer jacket, a picture of former and current US President Donald Trump arguing with a police officer, and a video of the Facebook CEO Mark Zuckerberg giving a speech about his company nefarious power. Such event did not happen in real life. Machine learning is important because it allows computers to learn from data and improve their performance on specific tasks without explicit programming. This ability to learn from data and adapt to the new situation makes machine learning particularly useful for tasks involving large amounts of data, complex decision making, and dynamic environments. Here are some specific areas where machine learning is used. Predictive modeling. Machine learning can be used to build predictive models that can help businesses make better decisions. For example, machine learning can be used to predict which customers are most likely to buy a particular product or which patients are most likely to develop a particular disease. Then we have natural language processing. Machine learning is used to build systems that understand and interpret human language. This is important for applications such as voice recognition, chatbots, and language translation. Then we have computer vision. Machine learning is used to build systems that can recognize and interpret images and videos. This is important for applications such as self-driving cars, surveillance systems, and medical imaging. Then it is used for fraud detection. Machine learning can be used to detect a fraudulent behavior in financial transactions, online advertising, and other areas. Machine learning can be used to build recommendation systems that suggest products, services, or content to users based on their past behavior and preferences. Overall, machine learning has become an essential tool for many businesses and any industries as it allows them to make better use of data, improve their decision-making processes, and deliver more personalized experiences to their customers. Well, on the other hand, artificial intelligence, or AI, is the ability of a digital computer or computer-controlled robot to perform tasks commonly associated with intelligent beings. The term is often applied to the project or developing system endowed with intellectual processes characteristics of human, such as the ability to reason, discover a meaning, generalize, or learn from past experiences. Since their development in 1940s, digital computers have been programmed to perform highly complex tasks, such as discovering evidence of mathematical theorems or playing chess with great expertise. Despite constant advances in processing speed and memory capacity, there are still no programs that can match full human flexibility in broader domains or in tasks that require a lot of day-to-day knowledge. On the other hand, some programs have reached the performance level of human experts and professionals in performing certain specific tasks, so that artificial intelligence is, in this limited sense, is found in various applications such as medical diagnosis, computer search engines, voice or handwriting recognition, and chatbots. All but the simplest human behavior is attributed to intelligence, while even the most complicated insect behavior is not usually taken as an indicator of intelligence. Psychologists generally characterize human intelligence not just by one trait, but by a combination of many different abilities. Research in the field of artificial intelligence was mainly focused on the following components of the intelligence: learning, reasoning, problem solving, perception, and language use. There are many different forms of learning that are applied to artificial intelligence. The simple way to learn is through trial and error. For example, a simple computer program for solving checkmate to one chess problems may try to move randomly until checkmate is found. The program could then store the solution with the position so that the next time that the computer encounters the same position, it can remember the solution. This simple memorization of individual items and procedures, known as rote learning, is relatively easy to implement on a computer. More challenging is the problem of implementing what is called generalization. Generalization involves the application of previous experience to analogous new situation. For example, a program that learns the past tense of regular English verbs by heart will not be able to produce the past tense of a word such as jump unless the program is previously represented with jumped, while a program that is able to generalize can learn the add or edit rule for regular verbs ending in a consonant, and thus from a past tense or of experience with a similar verb or verb jump on a similar verb. Reasoning means drawing conclusions that correspond to the situation. Conclusions are classified as deductive or inductive. An example of the first is Fred has to be either in a museum or in a cafe. He's not in the cafe, therefore he's in the museum. And another is previous accident of this kind have been caused by the failure of the instrument. This accident is of the same kind, so it is probably caused by a malfunction of the instrument. The most significant difference between these forms of reasoning is that in the deductive case, the truth of the premises guarantees the truth of the conclusion, while in the inductive case, the truth of the premises provides support for the conclusion without giving absolute certainty. Inductive reasoning is common in science, where data is collected and temporary models are developed to describe and predict future behavior, until the occurrence of anomalous data forces the model to be revised. Deductive reasoning is common in mathematics and logic, where elaborate structures of irrefutable theorems are built from a small set of basic axioms and rules. Significant success has been achieved in programming computers to derive interference. However, true reasoning involves more than just drawing conclusions. It involves drawing conclusions that are relevant to the solution of a particular problem. This is one of the most difficult problems that AI faces. Problem solving, especially in artificial intelligence, can be characterized as a systematic search for a series of possible actions in order to achieve a predefined goal or solution. Methods of solving the problem are divided into special purposes and general purposes. A special purpose method is tailored to a specific problems and often uses very specific characteristics of the situation in which the problem is embedded. In contrast, the general purpose method is applicable to a wide range of problems. One general purpose technique used in artificial intelligence is means and analysis step by step, or incrementally, reducing the difference between the current state and the final goal. The program selects action from a list of assets in a case of simple robot. Many different problems can be solved by artificial intelligence programs. Some examples are finding a winning move or a series of moves in a board game, devising mathematical proofs, and manipulating virtual objects in a computer-generated world. Finally, many different problems have been solved by artificial intelligence of these programs. Some examples are finding a winning move, as I already said. In perception, the environment is scanned by various sensory organs, real or artificial, and the scene is decomposed into separate objects in different spatial relationship. Analysis is complicated by the fact that an object can look different depending on the angle from which it is viewed, the direction and intensity of lighting in the scene, and how much the object contrasts with the surrounding field. Currently, artificial perception is advanced enough to allow optical sensors to identify individuals and allow autonomous vehicles to drive at moderate speed on the open road. In a continuation of this part of the course, we will get acquainted with some of the ML and AI services offered by Azure and AWS. But before that, let's learn why it is important to be informed about artificial intelligence. In today's world, when checking information or the truthfulness of the news we receive in real time is one of the important facts that we must adhere to when it comes to use of artificial intelligence. Until a few years ago, it was almost unimaginable that one day we would be able to talk and receive information from bots, programs that we often ask for certain solutions. Now these programs, or bots, as it is often heard in our country or our world, have become so necessary every day in finding answers, solutions, or questions that we rarely pay attention to the truth, the accuracy of the information due to the speed of life, or rather everyday life. The question we ask someone out there, and then that someone who gives us the answer is simply just a trained model made by human, and the information it gives us is also provided by man or human. In the next few minutes of this course, we will get to know in detail how it works, but the point of this lesson is that although it is a huge amount of information, artificial intelligence, as we like to call it, it is not omnipotent, and the answers we get often vary from what is correct. If you ask a question, you will get an answer. Whether that answer will be true or not depends on many factors, so the answer should be checked. It is a great importance for us as individuals, but also for the community, that the received answer is true. Artificial intelligence and machine learning are increasingly used in healthcare, economics, education, sport, and other areas of life. Imagine that an agreement or information about the health condition of a patient is not correct or has been not checked, or you can take any other example, the consequences are unfathomable. Guided by these previous examples, certain principles related to artificial intelligence has been adopted, and we will deal them in individual part of this course. Of course, I will not talk about them. You can find it at official pages on Azure and AWS, but these concern each of us and generally affect the behavior when we use these extremely advanced functions available to us. Once again, for the end of this chapter, to repeat, it is very important to stick to certain principles when it comes to artificial intelligence, and the answers we get are not always correct, so we should check the information we get. Just like everything in our life, there is a process in machine learning. So let's go step by step and explain every step of this process. So the machine learning process includes several key stages: data collection and preparation, model selection, training, evaluation, and deployment. It is a systematic approach to building predictive models that learn from data without explicit programming. A machine learning algorithms work by learning patterns and relationships from data to make predictions or decisions without explicitly programming for each task. Here's a simplified overview of how a typical machine learning algorithm works. First, there is data collection. First, relevant data is collected or curated. This data may include examples, features, or attributes that are relevant to the task at hand, such as images, text, numerical data, etc. Then we have something called data pre-processing. Before entering the data into the algorithm, it often needs to be pre-processed. This step may include cleaning the data, like handling missing values, outliers, transforming the data, normalization or scaling, and splitting it into training and testing sets. The third step is the choice of our model. Depending on the task, we have 3 types of model: classification, regression, and clustering. The appropriate machine learning model is chosen. Examples include decision trees, neural networks, support vector machines, and more advanced models like deep learning architectures. Then we have model training. Here, the selected model is trained using the trainer data. During training, the algorithms learn patterns and a relationship in the data. This involves iteratively adjusting the model parameters to minimize the difference between the predicted results and the actual result labels or targets in the training data. Then we have model evaluation. Once trained, the model is evaluated using test data to evaluate its performance. Metrics such as accuracy, precision, recall, or root mean square error are used to assess how well a model generalizes to new unseen data. Then we have something called fine-tuning. Here, models can be fine-tuned by adjusting parameters that are not learned directly during training, such as learning rate or the number of hidden layers in a neural network to improve performance. Then the 7th step is prediction or interference. Finally, the trained model is used to make predictions or make decisions about new data. This process involves applying learned patterns to new inputs to generate output such as class labels in classification task or numerical values in regression task. Now that we know how to work with Azure AI and ML services, let's see what services are offered to users in AWS Cloud. First service that I want to introduce is AWS Recognition Service. This service is available and it uses as text detection and recognition. It can locate and organize text in images, making it useful for applications such as OCR, optical characters recognition. Content moderation. Recognition can automatically detect inappropriate or unsafe content in images and videos, helping to maintain a safe online environment. Also, this service has celebrity recognition. This feature allows us to identify thousands of celebrities in images and videos. You can train recognition to recognize specific object or scene relevant to your app by creating custom tags. We already know how to work with tags and how can we create, if you remember, in Azure of course. And AWS Recognition boasts a robust set of features and allows you to handle a wide range of visual data analysis tasks. These features make it a solution for many businesses. Now let's explore the use cases of recognition. First is security surveillance. AWS Recognition is widely used for security surveillance application. It can identify people of interest, track their movements, and provide real-time alerts about security breaches. It can be used for content moderation. Social media platforms and online marketplaces use recognition to automatically detect and filter out inappropriate content, ensuring a safer user experience. You can use it for personalization. E-commerce websites use recognition to analyze user images and offer personalized product recommendations based on their preferences and style. Also, in a healthcare sector, recognition can help identify and verify patient and detect anomalies in medical images such as X-rays and MRI. You can use for retail. Retailers use recognition to manage inventory, analyze pedestrian traffic in stores, and improve their customer experience through checkout-free stores. You can use it for public safety. Law enforcement agencies can use recognition for criminal investigations by identifying suspects from surveillance camera footage. And you can use it in media and entertainment sector. Media companies can enhance their content by automatically generating highlights, thumbnails, and subtitles with recognition. Amazon website recognition is a powerful tool that brings the capabilities of artificial intelligence and computer vision to developers, businesses, and organizations around the world. Its ability to analyze images and videos, recognize faces, objects, and text, and perform content moderation opens up numerous opportunities for innovation in various industries. However, ethical considerations should always guide to its use to ensure responsible and transparent implementation in our increasingly AI-driven world. AWS recognition remains at the forefront of the artificial intelligence revolution as technology advanced enable new opportunities for businesses and societies. As part of the AWS offer, this free tier offer, you can get started with Amazon image recognition for free. The free tier period lasts for 12 months from the date of account creation. Image analysis during the free tier period, you can analyze 1000 images per month for free in the Group 1 and Group 2 APIs. If you go to our console and go to all services, you can see that there is a various service that we already locked, but all services are impossible to show, of course. And if you see in the machine learning part, there is a large set of services that can be used, of course. There is a lot of different services, and most of them we already know, but now I want to go to Amazon recognition and let's see how can we work with this service. So as you can see, there is a lot of option that is available, and you can try this demo, download SDK, or simply use custom label. In the demos blade, if I go to label detection, you can use label detection to automatically label object, components, or concepts, scene, and action in our images. As you can see, this is some sample image, and there is some random person on skateboard. So as you can see, this recognition is now available, and you can see all your results and score of confidence or confidence score. So in the result, we have neighborhood, city, road, street, urban. It's almost 100% our score result, score of confidence. So this recognition service or label detection working with unbelievable precise. Here you can see all other results of our label detection. So also you can see that we have transportation, vehicle, metropolis, clothing, footwear, shoe, machine, and all of these are above 90% of score of confidence. So for example, you can upload your own image or use some different image if you want, but the result will be the same. Recognition service will always provide you with unbelievable precise, and as you can see, this service is very easy to use, and you can see all different services. Now let's try another sample image, and as you can see, there is sometimes that these images need to be detected, or specific objects, of course, but these results are 100% accurate. As you can see, score of confidence or confidence score is 100%. It is almost impossible to imagine that some service can work with 100% of accuracy. Of course, there is some other options, but for example, 88.1 for the tower here on the picture is unbelievable number. 88.1. Imagine what can you do with 100% of accuracy. And also skyscraper 55.3% is low. It seems to be a little low now when you see all these other metrics. Of course, you can upload or drag your own image. So let me, for example, find my image that we use in some of the previous chapter, let me find the appropriate picture. We can use our dogs or Matthew Stafford, for example. Here, when you upload your image, you can see that Amazon Recognition already detect all labels in this picture. So we have, for example, this result. We have ball, person, ball, rugby. This is not a rugby ball, this is NFL ball, and it knows that it is a sport. 98.8% is the score of confidence. You can see that helmet comes with 96.4, and this recognition service knows that it is American football, and football person who plays American football is 94.6%. You can see that all persons behind Matthew Stafford in the crowd, like boy, child, male, can be detected. Here you can see hat, for example, can be detected with unbelievable sharpness. And that's it. This is how can you detect a specific objects and scenes that is unique to your business. And if you have, for example, you can add a label name. Let's add ball, for example, and then you can see that we have this is supported labels. So you can check is that some label that is supported or unsupported, and you can download the full list of this label. For example, for this picture, this is our request and this is our response. So you can see, just like in Azure, we are getting some JSON files and with detailed information, and now you can use this JSON file for your other things like apps and so on. So this is how can you use label detection in Amazon Recognition. We have also image properties. For example, you can see that we are automatically using our sample image, and in the result you can see what is the dominant colors in these images, and it can read image properties. Of course, you can see what is the image quality, is this foreground or background properties, what is the contrast, sharpness, and so on. Also in this request you can find all this in JSON files. You can also add or upload your own picture. We have image moderation, automatically can detect explicit content in your images. So for example, you can analyze up to 10,000 images at once with recognition image moderation, and here you can also use recognition to automatically detect explicit scenes or explicit content on your, or violent content in your images. For example, as you can see, we are using this image with some girl in swimwear and moderation labels. In the result, you can see what are these labels: swim or underwear, female swimwear or underwear, non-explicit nudity in intimate parts and kissing, and so on. As you can see, the confidence score is very, very high, and image moderation is also fantastic for this use. So you can use this image moderation and see what is the confidence score. Partially exposed female breast, for example, you can get this also label and response. Also we have facial analysis. Here you can get a complete analysis or facial attributes including confidence score. As you can see, looks like a face, 99.9%. It appears to be female, 98.7 confidence score, age range, smiling, appears to be happy, wearing glasses, 100%, and so on. So you can use this facial analytics for more options, and here you can also check your score. Also, this request and result can be then exported to JSON files. Also, just like in other demos, in other detection or moderation, you can use to upload or drag and drop your images. So this is another option that is available to you as a user, of course. And you can see all other results and what is the score. You can also use this Amazon recognition, for example, to store video analysis for streaming video events. There is option to check your metrics. You can even use all these services if you have some image URL, for example. Let me upload one of our dog. You can see that there is no face that is detected because it only works with human faces, facial attributes. If you go to face comparison, you can see that we have these sample images, and you can choose a sample image, and then this is a reference face, and this is comparison face. Sorry. Similarity is 99.9%, as you can see. So it compares faces to see how closely they match based on similar percentage. As you can see, there is no match. And of course, you can use this service just like any other. Well, you can see you need to enable your camera to use this face liveness. There is also celebrity recognition. This recognition automatically recognizes celebrities in images and provides confidence score. You can see that this is Jeff Bezos, and match confidence is 99.9%, of course. And here you can see that this is Andy Jassy, 99.9%. So there is also an option. You can also check this image. This is not a Brenton Burson, this is Matthew Stafford, and match confidence is 98.7, for example. But nobody is perfect, as you can see, so our recognition service isn't perfect. And you can also use this recognition to automatically detect and extract text from our image. As you can see, this is just a simple image. It's Monday, but keep smiling. This is our result. Of course, you can see it in JSON files, and this is our response. Of course, you can use and upload your image, and this is personal protective equipment or PPA detection. It automatically detects this PPA, such as covers, for example. If you have covered face, then you can use this option in Amazon recognition service, of course. As I already mentioned, you can stream video analysis. You can, for example, choose this one, or you can choose to stream metrics here, and there is a lot of information, and you can see additional details on CloudWatch, for example. But here you can see what is the detected label count, face count, for example, client errors, successful call, because all these services using SDK and API. If you go to custom recognition, you can use this custom recognition, for example, to build your own object and scene, and that's it. There is also a custom moderation. You can use this for pre-trained model, and you can use it for bulk analysis. Here, how does it work? You can upload, for example, 10K images to process with supported recognition features. Then you will wait for bulk analysis to complete. It takes for 5 to 60 minutes, depending on the number of images processed. Then you will review your result, and you can also download the result. And finally, the fourth step is to verify the model prediction, to assess model performance and trade a custom adapter or enhanced accuracy. So you can use this start bulk analysis, but if you want to try this service, simply go to demos and play around with this label detection, image properties, image moderation, facial analysis, face comparison, celebrity recognition, text in image, PPA detection, and that's it. This is the whole offer of this service that is available. Also, you can see additional resources and pricing, of course. But we are using a free tier, so there will be no charge for us. So that's it. Thank you for watching, and I will see you in the next chapter where we will see Amazon Transcribe is a fully managed automatic speech recognition or ASR service offered by AWS that converts audio to text. It uses machine learning to accurately transcribe audio files either in batch or streaming mode. This allows developers to easily integrate speech-to-text capabilities into their applications or use it as a standalone transcription service. So, if you go and see more detailed overview, you can see that its core functionality is to receive audio input and produce text transcriptions, including timestamps and reliability ratings for each word. Mode can handle both batch transcription, processing pre-recorded audio files, and real-time transcription streaming, converting audio while recording. Also, users can improve accuracy by customizing the service for specific domain or languages. Amazon Transcribe offers features such as speaker identification, content filtering for privacy or content control, and the ability to analyze multi-channel audio. It can be integrated with other AWS services such as Amazon S3 for storage and Amazon Comprehend for text analytics. We have common applications include generating subtitles for videos, transcribing customer service calls, and analyzing audio content for insight. Also, there is a special feature, Amazon Transcribe Call Analytics, focuses on extracting conversation insight from customer service calls to improve customer experience and agent performance. Amazon Transcribe Medical is designed for voice-enabled applications in healthcare, allowing clinical conversation to be efficiently documented into electronic health records. With Amazon Transcribe, you can improve accuracy for your specific use case by customizing the language, filter content to ensure customer privacy, or audience-friendly language. It analyzes content in multi-channel audio, split the speech of individual speakers, and more. You can transcribe media in real-time streaming, or you can transcribe media files that are in the S3 bucket. Amazon Transcribe is pay-per-use service. The price is based on seconds of transcribed audio and is charged monthly, and it is offered a free tier for the first 20 months if you use this first offer. If you open your account before July the 15th, and new AWS users get 60 minutes of free transcription per month after the free trial expires, or if usage exceeded this limit, it becomes a pay-per-use service which is charged per second of transcribed audio. Once again, if you go to our console and click on all services, you can see, if you scroll down, that we have our machine learning, and we already know how to work with our recognition service. Let's click on Amazon Transcribe. Here you can see that you can use this automation or automatic speech recognition, and finally there is an option, for example, real-time subscription, and you can see sample use cases, and of course this is the top feature of these services and related links to this service. If I go, for example, to and use real-time transcription, we can begin this transcription if we speak in our microphone. So you can select here language settings, as you can see, and then you can use language settings. For example, you can see that we can use specific language. So if you know the language spoken in your source audio, choose this option to get the most accurate results. You can use automatic language detection. If you don't know the language spoken in your audio files, you can choose this option. So there is a lot of options that we can choose from, and here we can, for example, choose my native language, or we can choose different English language. This is Great Britain English, and of course you can add more than one language. You need to choose minimum 2 languages, and finally we have this preferred language. I will choose my English UK, and you can use this speaker partition, and this will be some kind of stereo sound. If you want, there is content removal. You can use this vocabulary filtering that removes mask or tags word that you specified in our vocabulary filter. So you can use this vocabulary filtering blade, and finally you can choose your file filter selection, sorry. And in this is audio settings, and finally we have this customization. Here you can use custom vocabulary if you want, and there is a separate blade from the left side of your screen, and you can use it. Here you can see that we have our example API request and API response, and you can use this to transcribe audio and video in real time with your application using HTTP calls. And now if I scroll up, you can see that we can use this 15 minutes audio stream. And let's start streaming. Ukoliko kliknemo na start streaming, možemo probati da vidimo da li će se ovo snimiti. I want to speak on English and I want to see if this is working. As I already said, new AWS users will get 60 minutes of free transcribe on a month. Što znači ukoliko
Insurance office, Carlo Finkelstein Insurance. This is Carl. May I help you?
Yeah, I'm calling about my insurance policy. I just received a notice that my insurance has been canceled, but I paid the bill.
Oh, okay. If you feel this is an emergency, my manager is available.
Yes, it is an emergency.
Okay, I can...
And as you can see, if we scroll down, we can see that we are getting our transcription output, and also you can see that our application integration is ready. And now you can copy this example API request. Also, you can download the full transcript. Let me open this file. In this file is open in my Visual Studio Code. As you can see, this is our JSON file, and this is our streaming transcript result. So you can use this JSON file or this API calls. As you can see, this is all our items, and this is how can you work with this service. It's very, very easy. And then you can see all other options. So current language is Serbian and confidence is 100. Of course, you can download the full transcript if you want. I will leave this page. In the transcription job, you can create one job if you want. Just click on create job. Something isn't working, but if you go to custom language model, we can upload our data to Amazon S3, then we can train custom language model, and we can run transcription job with that custom language model to transcribe our audio files. Here there is an option to train this model, and it is very, very simple. First you will upload data as a plain text to your S3 bucket, and then continue to work. Then this is the custom vocabulary and vocabulary filtering. If you remember when we talked about how can we create this, then in the content removal settings you will simply use this for filtering. And here you can use Amazon Transcribe for, if I for example go to real-time transcription, you can also use this Amazon Transcribe Medical that provides accurate speech to text, for example. You can first add this conversation and use this or dictaphone to start transcribing, of course. And then we have Medical Insight. This is a demo. You can choose this and listen for different input audio support, and here we can also...
Good morning. I'm Dr. Parker. What brings you in today? Hi, Dr. Parker. So I've just been feeling really tired lately, like just having a hard time. I've been sleeping really well, but like even when I'm sleeping through the night, 8 or 9 hours a night, I just still feel really tired throughout the day.
And finally, this is the last thing that I want to show you. Here is some medical insight, but with Amazon Transcribe you can do a lot of things. This was just a simple demonstration and that's it. Thank you for watching. The next service is Amazon Poly. There is a mistake, it's not policy, it's Poly. This is a cloud service provided by Amazon website and that converts text into realistic speech. It allows developers or users to create apps that can speak, making them more engaging and accessible. Poly supports multi-languages and offers a variety of voices to choose from. AWS Poly is a cloud-based text-to-speech service that converts written text into realistic speech by offering a variety of voices in multiple language and accent. Poly allows developers to customize their application with realistic speech synthesis. The service is powered by deep learning models and generate high-quality speech and support various functions such as lexicons, SSML or speech synthesis, annotation language, and neural TTS or neural text-to-speech for more natural voices. AWS Poly is a part of Amazon Web Services suite and easily integrates with other AWS services, making it a great tool for creating scalable, affordable, and engaging user experiences. The process of converting entered text into realistic speech using advanced deep learning technologies, Poly offers many types of voices. Voices have different accent, languages, and way of speaking. Each voice has a name such as John or Matthew. They are categorized based on gender, language, and region. Also, this service has something that we already said, SSML or speech synthesis markup language, and it allows users to control the way Poly speaks, such as pronunciation, tone of voice, and speech rate. It allows you to make small changes to the way Poly converts text to speech. You can use lexicons, custom pronunciation dictionaries that allow users to accurately determine the pronunciation of certain words or phrases, especially if the words are not pronounced correctly by default. Amazon Poly receives the text you enter and converts it into audio output, essentially spoken the text. Also, Poly uses advanced technologies, including deep learning, to generate natural sound speech. You can use multiple languages and speeches, so it supports a wide range of languages that provides different voice options, including different genders and speaking styles for each language. Poly can be easily integrated into application through its API, allowing developers to quickly add text-to-speech functionality. Also, with the support of SSML, it will allow you for precise control over speech attributes such as speech, speed, and volume. Poly can also provide speech tags, which are metadata that indicate the timing of each word or sentence. This is useful for synchronizing speech with other media, such as animations or text highlighting. Setting up Amazon Poly to enable text-to-speech synthesis is a process that allows developers to enhance their application with speech. As a part of free usage service, but at least for me, because I'm using this free service, free tier, this is by the old rules, and you can get started with Poly for free. After registering, new Amazon Poly users can synthesize millions of characters every month for free for the first 12 months. For current pricing information, you must check out Amazon Poly's pricing page. The name of the service is perhaps the most fun of all the services in AWS. Once again, if you go to our console and go to all services, you can find Amazon Poly, and let's click on that link. As you can see, we are now in our Poly service, and you can use this great service to turn this text to speech. For example, you can use generative, long form, neural, or standard option. As you can see, there is for example, a lot of options that you can choose from. For example, you can listen this save to S3 or download this text or this audio text, and finally we can use this neural. This produces more natural and human-like speeches. And here is standard, and then if you use generative, you will be able to choose this language. For example, you can choose between English and some other available languages.
Hi, I'm Ruth. I can read any text for you. Test it out.
If you scroll down, as you can see, we can listen different text to speech. We can see what is Ruth saying, and here there is also SSML for this input text, and if you scroll down there is also additional settings. So here you can use this speech file format settings. If you turn this on, you can choose your sample rate and you can choose your file format. It can be in MP3, OGG Vorbis or PCM format. So you can download this output on your local machine in that file format. Also you can use this customized pronunciation and add your own vocabulary. Here you can also add some of your text. So I will add some different language. Let me add some different sentences, sorry. And here we can add, for example, test it out. I am AWS administrator and I love cloud. And then when you click on listen, it will say just like that. But for now we don't have option to hear this because I guess I made a mistake by typing this, and I must change this to I love cloud. And you can choose a different voice. For example, you can choose Daniel, Joanna.
Hi, I'm Ruth. I can read any text for you. Test it out. I'm AWS administrator and I love cloud.
Ruth, I can read any text for you. Test it out. I'm AWS administrator and I love cloud.
I can read any text for you. Test it out. I'm AWS administrator and I love cloud.
And one of the great thing about this service is that you can save this to S3 service. So you need to have some S3 output bucket. First you need to create this bucket or S3 key prefix, and you can use also SNS service for this notification. So it is very important to know everything about this, and now we can even download this speech to text file, and you can see that we can also reproduce this file in our media player. So I didn't enable audio, but here it is. We can see that we have our audio file. So this is how you can use AWS Poly. The next service is AWS Translate. So Amazon Translate is a neural machine translation service offered by Amazon Web Services that provide fast, high quality and affordable language translation. It allows users to translate text between different languages using real-time translation methods or group methods. It supports a wide range of languages and can handle a variety of documents format such as HTML, TXT and docs. Amazon Translate uses neural networks that are explicitly trained to translate languages. This tool allows you to translate between the source and target languages. All you need to do is to enter the original text in UTF-8 format. The tool then translates the text and provides output in UTF-8 format. And AWS Translate also uses attention mechanism to understand the text it is translating. Attention mechanism helps the tool determine more accurate translation from the source to our target language. Moreover, AWS Translate also offers automatic language detection. When the text is entered, the tool automatically detects the source language. AWS Translate is a part of Amazon Web Service and Amazon Cloud Computing Service, of course. An individual or company who want to use AWS Translate must first register for an AWS account. As you all know, it is possible to register for a free account, and the service offers a free tier allowing users to try this service. So we have something called neural machine translation. Let's take a deep look at this. What does this mean? So Amazon Translate uses deep learning models to provide more accurate and natural translation compared to traditional methods. You can use real-time and group translation, supported for both real-time translation for current needs and group translation for large volumes of text. The service supports a large number of languages and support pairs, making it suitable for a variety of translation requirements. Also, there is option for customization, and Amazon Translate offers customization option, including custom terminology and profanity masking to tailor translation to specific needs. As already mentioned, you can translate documents in a variety of formats, including HTML, TXT, or docx, while preserving the original formatting format. Amazon Translate can be easily integrated into apps and services through its API, allowing developers to add multilingual or multilingual support. It is a cost-effective service, so you can use millions per characters with a free tier for new users. Amazon Translate integration into apps allow users to communicate in their preferred languages, so this is great for multilingual app support. You can use for content translation, translating company documents, knowledge base articles, and other content to reach a wider audience. You can use it for document automation. You can automate the process of storing, managing, and extracting insight from documents in multiple languages. There is a real-time translation, so you can enable real-time translation for live chat, video conferencing, and other interactive application. Also, there is voice translation, so combining Amazon Translate with other AWS services such as Amazon Connect to enable voice translation capabilities. With Amazon Translate, you pay per use based on the number of the text characters, including spaces, that are translated per month. It's easy to get started with Amazon Translate for free, or as I already mentioned, when you have this account or you're a registered member of AWS, you can translate up to 2 million characters per month for free, up to 12 months. Once again, we are in console. Let's go to all services, and if I scroll down, you can see that we have our Amazon Translate service. And here, you can use this real-time translation to deliver on-demand translation for text that you enter, or simply you can add your document. There is a two tab. In the first tab, you can use text. Let's choose some different language. This is our source language, for example. And here, I can find my native language, and I want something to be translated to English, for example. Let me add some text. So we had our source language and we have our target language. So I'm writing on my main language. This is my native language. This is my Serbian language. And finally, as you can see, the text is automatically translated to in English. So this is how you can use real-time translation. Very, very interesting. And we already saw how can we use this in Azure. So this is just a simple example to see if this service can work, can generally work as we presented in our theory section of this course. And it really works great. As you can see, there is some theory word that is not automatically translated, but you can change this and make it, as you can see now into your theoretical part. Now is everything is okay, and you can add 10,000 bytes, or this is used. And here in the additional section, you can add some custom terminology. To specify custom terminology, you must use this option. There is a brevity, formality, and profanity masking. The great choice about this that you can choose to ban profanity, and if you go to application integration, simply copy JSON request and your JSON response that is automatically, as you can see, added here. And if we go to document, we can choose our source language. You can use to upload some file in plain text, HTML, or docx, as you can see, as you already learned. And when you upload your file, let me simply go to my desktop, I will click on right click on my desktop and let's create a new txt file. We will use Notepad, of course. Let me open this notepad, and this will be, for example, some text document. You can add a name, whatever name you want. I will choose to write on Serbian. So this is just a simple example to see if this really works, for example. If this translation works from our document. You can write on any language that you want. And finally, we will save this file and then we will upload this file. Let me click on save. Here it is. And finally, you can click on save as if you didn't specify it. You can see that we are using our txt file. I will now simply click to override this text, so we are now sure that we are using our txt file. And here, let's go to our console. I will click on choose file. This is file that we want to upload, that we just created. Here, for the source language, I will choose Serbian because this is written in Serbian. And for the target language, I will choose my English. And let's click on translate and download. Here it is. As you can see, I will now open this file, and here it is, a new file. This is a simple test to see if the translation or our document work. Hopefully it works as described. And that's it. This is how can you use complete document. Now imagine if you have some 10,000 pages, you can use this to choose here and upload this file, and that's it. Also, you can go to metrics and choose all other metrics, or simply go to CloudWatch, and we have all this. So how can we work with our real-time translation? There is also a character count, and you can choose a time range for this. For this metrics, for example, we are using our 30 minutes period, that is by default. Here you can use batch translation. You can create a job if you want, and you can also add some custom terminology or parallel data. So if you have some more job for this translation, you can use this batch job for, and also here you can add your custom terminology, or you can use parallel data that contain example of source phrases and so on. So there is a lot of options that you can choose, and this is our Amazon Translate service, and this is a very, very great service powered by AWS. Amazon Lex is an AWS service that allows developers to create conversational interfaces for application using both voice and text. Essentially, it allows to create chatbots and voice assistants that can understand natural language and respond in a conversational way. Lex is powered by the same technology that powers Amazon Alexa, natural language understanding, or NLU, and automatic speech recognition, or ASR. Lex combines ASR, which converts spoken language into text, with NLU, which interprets the meaning of text. This allows your app to understand what the user is saying or typing and to respond appropriately. You can create chatbots and voice assistants, so you can use Lex to create chatbots for various applications such as customer service, information search, or even smart device control. You can also create voice assistant that can interact with users through voice commands. There is also great integration with other AWS services, so Lex integrates seamlessly with other AWS services such as AWS Lambda for backend logic, Amazon Cognito for authentication, and Amazon DynamoDB for storage. This makes it easy to create complex conversational application, and also Lex allows you to deploy your chatbot or voice assistant across multiple platforms, including mobile apps, messaging platforms such as Facebook Messenger and Slack, and even IoT devices. It is cost-effective, so Amazon Lex offers a free tier for the first year, allowing you to process a certain number of text and voice requests per month at no charge. Also, the key components of this service are bots that is used for a whole conversation app. Intents define the goals or action of the user they want to approach to accomplish. And slots, for example, it represents certain information necessary to fulfill an intention. And we have something called testimonials. This is just an example of how users can interpret intent. So Amazon Lex version 2 is an AWS service for building conversational interfaces for applications that use voice and text. Amazon Lex version 2 provides deep functionality and flexible in natural language understanding and automatic speech recognition, so you can build highly engaged customer experiences with realistic conversational interactions and create new product categories. Amazon Lex v2 allows any developer to quickly build conversational bots. With this service, you can use no deep learning expertise is required. You can create a bot. You specify just a simple basic conversation flow in the Amazon Lex v2 console. Amazon Lex v2 manages the dialogue and dynamically adjusts the responses in this conversation. You can use the console. You can create a test and publish your own text, voice, or chatbot. I already told you that you can add this, for example, to Facebook Messenger, so you can add the conversational interfaces to bots on mobile devices, web apps, and chat platforms. Amazon Lex v2 provides integration with AWS Lambda, and you can also integrate with many other services on the AWS platform, including Amazon Connect, Amazon Comprehend, Amazon Kendra. Integration with Lambda allows bots to access pre-built serverless businesses connectors to connect to data in SaaS applications such as a Salesforce, for example, or any other. Amazon Lex v2 only charges for your text or voice request you make. This model provides you with a variable cost service that can grow with your businesses while also giving you the cost advantages of AWS infrastructure. Amazon Comprehend is a natural language processing or NLP service offered by Amazon Web Services that uses machine learning to analyze text and extract insights. It helps users understand the content, feelings, and relationship within textual data without the need to be an expert in machine learning. The service stands out for its ability to perform real-time and group analysis, making it versatile for a variety of applications. It also detects the language in which the text is written, extracts and categorizes entities, and identifies personally identifiable information or PII to ensure data privacy. Amazon Comprehend Sentiment Analysis is robust and provides insight into 4 categories: positive, neutral, negative, and mixed, each with a reliability source or score. This is especially useful for analyzing customer feedback and reviews. The source of this text can be social media feeds, websites, emails, or some kind of articles. You can also give Comprehend a set of text documents, and it will find the topics or group of words that best represent the information of the collection. Amazon Comprehend also excels of annotating speech types and model topics, allowing you to assign documents to predefined groups and classify text into specific categories. It uses a JSON-based API for real-time processing, which facilitates seamless integration into existing systems. Also, Comprehend output can be analyzed to understand customer feedback, provides a better search experience through search filters, and use DEMS to classify documents. The price is calculated based on units of 100 characters, with a fee of $1 per million characters parsed for basic operations. More complex features such as DEM modeling or custom classifications have a sophisticated pricing model, offering flexibility depending on your needs. Also, you can consider using Amazon Compass to analyze the sentiment of customer reviews or classify customer complaints into predefined categories. These applications can significantly improve the effectiveness of customer service and product development strategies. In summary, Amazon Comprehend offers a complete NLP and text analysis service with a range of features that cater to both basic and advanced word processing needs. Its comprehensive capabilities make it a valuable tool for businesses looking to extract actionable insight for textual data. What it does, you can determine the general mood, positive, negative, neutral, or mixed expressed in the text. You have option for entity recognition, so it identifies and categorizes name entities in text such as people, places, organization, and dates. key phrase extraction extracts the most important phrases from the text. You can use this to identify the language of the text, discover topics within a document collection, and it allows users to train custom models for specific tasks such as recognizing and classifying custom entities. Let me go to all services, and I will now find our next service. This is our Amazon Comprehend. And here you can see that we can use this service for natural language processing and text. Of course, you can see all other benefits of this service, use cases and related services, so you can use this with the combination of this text. Let me click to real-time analysis. Here you can see what can you do. First, there is input data, and you can use this built-in or custom analytics. So here is just a simple input text, as you can see, and we can see that we are using our real-time insight based on AWS built-in models. So you can use these built-in models, and finally, if I click on analyze, you can see our result from this text and what is the type of entity and what is the confidence, for example. Here you can see person, organization, other, some kind of quantity, and finally we have this address and of course date, organization, and some kind of location. And you can also see entity type and confidence score in this table. So this is our result of how can you use this comprehend option for real-time analysis with AWS built-in model. So as you can see, confidence is nearly 100%, and the other results are almost there. So you can use this with confidence. Of course, if I scroll down, we can also have this API call and API response, so we can use this for our application. Simply copy this and paste it into your app if you are a developer. If you are a simple user, you can try more of this. You can use, for example, custom. You can choose your model, custom classification or custom entity recognition, and you can view this real-time insight based on custom models from endpoint that we create. So we can clear our text and add some different text here. So you can type some random text in language that you want. I will use English this time. Hello, my name is and I am on vacation, for example. Some random name, some random city, and random sentences, you can see. And now we can click on analyzed, and let's see what are we getting. So we need to choose our, let me use this. We can use this custom, but we must use this built-in model. We don't have any endpoint created, so we will use built-in type for analysis. Let me click on analyze, and after some time you can see that we have our result. We have our person, date, location, and organization. And the confidence, it is different than last time, but we are using our own sentence, and sometimes there is a little different various confidence score or result. You can also click on these tabs, for example, for key phrases. You can set up language. You can see that our result is in English. This is almost 0.99 confidence percent. We have PII, personal identifiable information. As you can see, result is Elena and Belgrade. This is identify the location of PII in our text, and labels. You can see what is our name. We have sentiment. There is only positive comment sentiment, and it is almost 100%. And targeted sentiment is our next tab. As you can see, so there is no negative option. And here you can analyze your text and see what is the primary sentiment and syntax. As you can see, is there some part of speech, and what is the part of speech, what is the word, and confidence almost high enough. So this is how can you use your Amazon Comprehend, and between these tabs you can see different insight, as I already told you. Here you can use your analysis job. For example, we can click on that tab. You can create your own job to analyze documents that you stored previously in Amazon S3 service, and you can find entities like events, phrases, primary language, sentiment, target sentiment, or personally identifiable information. So, for example, if you create some S3 bucket and you have, for example, 100 pages of some document, you can create this job and simply add all of these documents that you previously stored in your Amazon S3 and create this job. Also, there is a custom classification. You can classify documents using custom categories, custom entity recognition, flywheels. You can train your own models for custom models. Here you can first create your flywheel, provide your data, evaluate the model, train new model, and promote this model, and this model will, then you can use this custom built model, as you remember from our previous real-time analysis. It's very easy to create this model, but we won't create this model. I already showed you in Azure how can you work with ML model, how can you train your own model, and finally in the endpoints you can create your custom models that is available for real-time classification, and here you will add your name and simply create this endpoint. So this is Amazon Comprehend, a very useful service. Thank you for watching. One of the most popular service in AWS in machine learning is AWS SageMaker. So let's first learn what is a SageMaker. This is a fully managed AWS service designed to streamline the process of building, training, and deploying machine learning or ML models. It provides a comprehensive set of tools and infrastructure to handle the entire ML lifecycle, from data preparation to model deployment and monitoring. Essentially, SageMaker aims to make ML more accessible and efficient for developers and data scientists. Key feature of these services and capabilities. So, SageMaker Studio provides a web-based interface for all steps of machine learning development, including data preparation, model building, training, and deployment. You can also use SageMaker Autopilot that automates the process of building and training your ML models, allowing users to experiment with different algorithms and identify the most accurate one. Also, there is a SageMaker Data Wrangler that helps users explore, clean, and transform data, simplifying the data preparation process. Then there is a model training, and SageMaker offers a variety of model training tools, including support for popular deep learning frameworks and algorithms. SageMaker provides tools to deploy models as an API for real-time forecast or as group predictions for large data sets. Also, SageMaker Model Monitor helps detect deviations in model performance, ensuring that models continue to produce accurate predictions. SageMaker Neo optimizes models for deployment on a variety of hardware, including devices at the edge network. Also, SageMaker Studio facilitates collaboration between teams by providing shared workspaces and project management tools. If you use this service, there is a lot of advantages. For example, first is reduced complexity. So SageMaker automates many of the complex tasks involved in machine learning development, making it easier for users to build and deploy models. By automating tasks and providing a streamlined workflow, SageMaker help users speed up machine learning development process. SageMaker offer a variety of cost management features, allowing users to optimize their spending on machine learning resources. Also, SageMaker is designed to scale to meet the needs of any project, from small experiments to large-scale implementations. Also, SageMaker supports a wide range of machine learning frameworks, algorithms, and hardware platforms, giving users the flexibility to choose the tool the best to suit their needs. Amazon SageMaker AI is available for free for 2 months as a part of AWS free tier program. Users can get access to up to 250 hours per month. AWS Lambda is a serverless computing service, and the cost depends on the duration. From time to time, the code starts executing until it is returned or finished, and the memory allocated for execution. Amazon SageMaker has a fixed price for each instance per hour, and it is independent of runtime or memory allocation for execution. Also, AWS SageMaker is one of the most important service in AWS if you want to deal with machine learning. So the advice is to familiarize yourself with it in more detail using the AWS official documentation. And as you can see, this is the whole infrastructure, how it works. So for example, you will use this Python PI mirror. First, you will use these Python packages. You will use Amazon S3, as you can see, or VPC endpoint. Then you will share this services in VPC. Then you will use this PI mirror private endpoint. Finally, you will use your project VPC with Jupyter Notebook. Then again, Amazon S3 VPC endpoint. And finally, this is our project models and project data. Of course, you will use AWS Service Catalog and AWS Identity and Access Management to add some different roles and permissions. Thank you for watching. AWS Forecast is a fully managed machine learning service offered by Amazon Web Service that provides accurate forecasting of time series for a variety of business needs. It uses machine learning to analyze historical data and predict future trends, helping businesses optimize operations, improve planning, and make better informed decisions. So, let's take a more detailed explanation. AWS Forecast is designed to predict future values of time-dependent data, such as sale figures, website traffic, or resource usage, based on historical trends. How it works? First, the service takes your historical data as input and uses machine learning algorithms to identify patterns and relationship within the data to generate accurate forecast. Key feature of this service is it is very easy to use. AWS Forecast is a fully managed service, which means it addresses the complexity of training and deploying machine learning models, requiring no prior experience with machine learning. It allows for customization, allowing users to specify forecasting horizon and include additional data sets and even manually select algorithms if needed. AWS Forecast is designed to provide high accurate forecast using a variety of algorithms, including statistical methods and neural networks. Integration with other services are very, very good. So you will use services and application through API and SDK, making it easy to incorporate forecast into your existing workflows. Advantages of this service is improved decision making. So with accurate forecast, you can enable businesses to make better informed decisions regarding inventory management, resource allocation, and strategy planning. By anticipating future usage, businesses can optimize their spending on AWS and avoid unexpected cost. You can use forecasting, allow for better resource planning, leading to improved operational efficiency, and also it is accurate forecast of product demand can help minimize waste by optimizing inventory levels. So if you're using AWS Forecast, you can then use this service for retail, forecasting demand for products to optimize inventory and reduce waste. Financial planning, you can predicting future financial performance to improve budgeting and resource allocation. Supply chain command, optimize supply chain operations by forecasting demand and resource needs. Healthcare, forecasting patient demand to optimize resource allocation and employment. workforce planning, anticipating future labor needs to optimize hiring levels and resource allocation, and also Amazon Forecast offers a free tier for new AWS users. This allows them to explore the possibilities of this service and test it suitably for their needs at no immediate cost. The free tier includes a monthly allowance for training hours, forecast generation, and data storage. Amazon Kendra is an intelligence service from AWS based on machine learning. It helps users find the information they need even when it's scattered across different locations and content repositories within the organization. Essentially, it's an enterprise search solution that use natural language processing and semantic understanding to provide more accurate and relevant search for results compared to traditional keywords-based systems. Here are more detailed overview of this service. Kendra goes beyond simply matching keywords by using machine learning to understand the meaning and content of your queries, allowing her to find the most relevant information, even if the search terms do not exactly match the content. Kendra can connect to a variety of data sources, including databases, web pages, document repositories such as SharePoint, Confluence, and S3, and more, allowing you to create a unique search experience for all of your organization information. Kendra uses NLP, or natural language processing techniques, to understand the intent behind your search queries, allowing her to provide more accurate and useful results. Instead of relying solely on keywords matching, Kendra uses semantic understanding to identify documents that are similar in meaning to your query, even if the keywords do not match directly. Also, Kendra can be used with large language models, or LLM, to run generative artificial intelligence AI applications such as chatbots. So it uses extended data generation, allowing users to get answers based on their own business data. Kendra offers Gen AI, or Generative AI Index, specially designed for RAG or RAG and enterprise search, allowing you to build conversational AI experiences based on your data. And it also has improved productivity and customer satisfaction. By providing quick and accurate access to information, Kendra can improve employees' productivity and increase customer satisfaction. It is a cost-effective service for intelligent ranking, of course, and there are different pricing options based on usage and capacity. Amazon Kendra is a managed information retrieval and intelligent search service that uses natural language processing and an advanced deep learning model. Unlike traditional keyword-based search, Amazon Kendra uses semantic and contextual similarity and ranking capabilities to decide whether a piece of text or document is relevant to a search query. With Amazon Kendra, you can create a unified search experience by connecting multiple data repositories to the index and document entry and listing. You can use your document metadata to create a rich and custom search experience for your users, helping them to find the right answers to their query efficiently. Amazon Kendra offers a Gen AI index that is highly accurate for generating extended search, as well as for searching businesses on your data. You can use Kendra Gen AI indexes in the Amazon Q business and Amazon Bedrock knowledge bases to build generative AI applications using your proprietary data. Well, you can ask Amazon Kendra the following types of queries. First one is factoid questions, simple questions about who, what, when, or where, such as where is the nearest service center in Seattle, for example. Factoid questions have answers based on facts that can be returned as a single word or phrase. The answer is taken for frequently asked questions or for your extended or indexed document. Also, descriptive questions, questions where the answer can be sentence, a paragraph, or an entire document. For example, how do I connect to my Echo Plus to the network? How do I get the tax benefits for low-income families? And the third one is keyword and natural language questions, questions that involve complex conversational content whose meaning may not be clear. For example, the keynote. When Amazon Kendra encounters a word like address, which has multiple contextual meanings, it correctly infers the meaning behind the search query and returns relevant information. You can get started with Amazon Kendra Intelligent Ranking for free. AWS Free Tier provides free use for up to 750 hours during the first 30 days for base capacity users or one capacity unit. And the last service that I want to present here is Amazon Personalize. This is a fully managed machine learning service that allows developers or users to create apps with personalized recommendation and user segmentation. It uses your data to generate personal recommendations for users and can also be used to identify segments of users based on their behavior and preferences. Key features and functionality of Amazon Personalize: you can provide a range of recommendations, algorithms, and recipe tailored to different use cases such as product recommendations, personal search result, and more. It can analyze user behavior and preferences to create different segments of user, enabling targeted marketing and content delivery. Also, it is great for real-time personalization. Amazon Personalize supports real-time recommendation, allowing you to provide personal experience as users interact with your app. It also uses data-driven approach, so uses your data, user interaction, item catalogs, etc. to train custom models that generate highly relevant recommendations. Also, no machine learning expertise required. This service simplifies the process of building, training, and deploying machine learning model, making it available to developers with no prior experience in machine learning. Integration with existing systems, so it can be integrated with various platforms such as website, apps, SMS, and email marketing systems. Also, let's see how this service works. First, you must provide Amazon Personalize with information about your users, the items in your catalog, and how users interact with those items. Then we have model training. Amazon Personalize uses this data to train custom ML models based on select recipes, recommendations or use cases. And finally, the third step is personal recommendations. So you can then use the private API to request personalized recommendations for users in real time or through group workloads. Here, this service can be used, for example, e-commerce, recommending products to users based on their browsing history and purchasing behavior, content platforms, suggested articles, videos, or other based content or on user preferences and browser history. For marketing, targeting specific user segments with customized marketing campaigns and promotions. Then customer service, providing personalized support based on their customer history and past interactions. And that's it. Essentially, our service or Amazon Personalize enables businesses to provide more relevant and engaging experiences to their users by leveraging the power of machine learning without the need for extensive machine learning expertise. During the first 2 months by using Amazon Personalize, you are offered the following: data processing and storage up to 20 gigabytes. Welcome back. In the previous hours, I really wanted to show you how can you work with different programming languages. In this time, for automation, we used first Azure PowerShell. Then we learned about Azure CLI, and we learned how to work with Bicep, which is work exclusively on Azure platform. And now, as you can see, we are in our AWS console, and I want to show you how can you work with CLI. Of course, just as you expected, we have AWS CLI. So before we take a closer look with what can we do with with AWS CLI, I want to talk about PowerShell. Yes, you can work with PowerShell in AWS, but I don't want to confuse you. Here we'll just take a quick look on how can we set up our environment, and let's learn how can we provision some different resources in our AWS. So let's get started. But before that, before we learn anything about AWS CLI, first we need to set up our environment. As you already know, exactly the same thing we did when we work with the different languages in Azure. So here, as you can see, I'm in my AWS, and finally we will get our environment ready. As you can see, we will use different sources, and one of the most important one is our Visual Studio Code. We already looked at how can we install our AWS. Then we need to set up some different options. If you can see, if I go to my Cloud Shell, there is, let me click again, there is my Cloud Shell, and we already worked with Cloud Shell, if you remember. And of course, you can add your commands and work with AWS CLI right from here. But there is also another way, and you can also work from your own computer or your own laptop. As I already mentioned, first we must set up our environment. If I go to Microsoft Bing or Google and type Visual Studio Code download, you will get this link, and if you open this in a new window, new browser, you will get option to download Visual Studio Code. And I expect that you know already what is VSC. And finally, I will download my user installer for my Windows 11. If you're working with some kind of Ubuntu, then you will download for this, or for Mac, of course. If I click on Windows, you can see that we have successfully downloading our VSC file. And now, simple, when you download your exe file to your machine, simply go and double click this Visual Studio Code, click on Run, agree, or accept the term or agreement, click on Next, and then you can go to Next. Simple, straightforward installation, nothing special. Of course, I already have installed VSC code on my laptop, so this is the first step. The second step, I will run my command prompt. Let's run as administrator, and finally, as you can see, I'm logged in as my admin in command prompt. You can go to startup menu, go to search, type command prompt on your laptop, and here you can also work from here, of course. And now everything that you want, you can create with AWS CLI. If I, for example, type AWS -- version, you can see that I already have installed my AWS CLI, because when we started this course, we already installed this program. And now if I type AWS configure, you can see that I need to add my AWS access key ID. So if you remember, when we learn about IAM service, there is something called AWS access key. So if I go to my console and go to my security credentials in my, as you can see, security credentials, then here we can see all our information about this account, of course, and about my multi-factor authentication. And as you can see, this is my access key. I already create my access key. Let's create a new one. Simply click on understand and simply click on create access key. Of course, I won't create a new access key because I already have one. So this is how can you do it. Then simply copy this access key ID, and we need to paste this key into our command prompt. And this is my secret access key. I downloaded my access key and my secret access key. Of course, in the moment when you will watch this video, this access key and secret key will be deleted. So just do it for the precaution. And finally, as you can see, we successfully copied our AWS access key ID. And finally, I will copy my secret access key. And this secret is created when you create your access key. We already know that. So nothing new. We're just implementing already what we learned so far. I will paste this, and finally you can add your default region name, or simply you can type, for example, East US 1 or something like that, or if you don't want to use region name and output format, simply type enter 2 times, and here it is. We are now connected to our AWS account, and right from here, from our command prompt, we can run commands against AWS. So let me now minimize this. As I already told you, we installed our Visual Studio Code. Here I have some examples that I used in previous chapters or in previous working with some testing something. I don't know, I don't remember right now. But if you open your Explorer, simply go to Drive C, go to New and create a new folder. This folder I will name AWS, for example, script. All the script that I make will be added here. So I will go to File, go to Open Folder, and finally double click on my AWS script folder. And simply click on Select Folder. So we have now selected our folder. Yes, I trust the authors. This is my script that I open in Visual Studio Code. The next thing we need to do is to go to my extensions and let's find AWS Toolkit. Here I will install this extension on my Visual Studio Code. This is a Visual Studio Code extension, and when you install this extension, you will be able to work with your AWS CLI right from Visual Studio Code. Of course, you can choose what is the best option for you if you want AWS or command prompt. Then we will run, as you can see, this is installed, and if I go to AWS, here you can see that we can now install some different option or simply choose our gateway, and that's it. We are now connected. Sorry, we are now installed our AWS CLI toolkit, and here you can also refresh this, run something, connect. You can add new connection or simply sign out from this account. Let's click on add new connection. I will choose my, you can sign up with Workforce or use some AWS credential. Then you will add your profile name, the identifier of this is my, I'm logging in with my root user. I will add my account ID. As you can see, then we can go to our VSC and paste it here. And of course, I can add my access key. This is exactly access key that we are using for command prompt. And finally, I will copy my secret key. This is our secret key. So let me just copy this secret key. Sometimes when you want to work with, here it is, this is our secret key, and finally let's hit on continue. And after some time, we will be able to connect to our Workforce. Let me just go to terminal, and here, as you can see, I can run my, for example, AWS -- version command, and you can see I already have installed my AWS, so we can see that exactly the same command we are getting from our, or response we are getting from our VSC. And of course I can write some different, for example, AWS configure. So exactly the same step we can use from our from our Visual Studio Code. I will now copy my access key this is exactly the same access key that we already used to connect with command prompt, but this time, as you can see, we are using our Visual Studio Code. So there is a different option. How can you set up your environment? And I'm showing you the two most useful option. So you can choose whatever suits your needs, and of course we can now provide our AWS access key. I don't want to use default region or output format, so 2 times on enter, hit enter, and that's it. We are now ready to work from our Visual Studio Code. So as you can see, we successfully sign up our environment. Let's see how can we create S3 bucket, for example. As you can see, I'm in my Visual Studio Code, and right from here I can write my command. Of course, just to remind you, I can run this command from my command prompt. So here is the first command, AWS S3 MB, then S3, the name of your bucket, and the name -- region. And I'm using my US1 region, and that's it. As you can see, we executed this command. Let me go to my portal. We can now add some different name for this bucket, and I will now try to create bucket once again, but this time we will use our command prompt. As you can see, our bucket is created, and if I go now to my Visual Studio Code and try to refresh this, let's see S3, and you can see we have our buckets that we created. Of course, you can add your name after this S3 name. And finally, if I go to my console, let me go to my S3 service, and if you go here, you can see we have our buckets. So this is how can you create your bucket, and it is really easy, as you can see, and you can work from both environment, Visual Studio Code, or command prompt from your laptop. So you can see what is our region, what is the date of creation, and finally here we can also go here, and let me go and create a new file. I don't have anything. I will create a new file and or script. So let me just copy my local file. So I want to now try something else. First, I will add my local. Let me just see how local dash file .txt. So this is the name of our file, and as you can see, this is our some random text. And now let's see how can we upload our object in S3 bucket. I will use AWS S3 CP for copy, the name of our file and the name of our bucket. So let's see if this works, and let's see if this file is uploaded to our EC3, sorry, S3. Let's go to my first bucket, and here you can see I have my local file, and this is the file. If I open this file, you can see that we have our name, some random name that we added here in this local file. So your local file must be in exactly the same folder with your script in our AWS script. So by mistake I deleted the previous video, and you didn't see how can we upload object in our bucket. Thank you for watching, and I hope this was helpful. Welcome back, and if you want to create a new user, simply type AWS IAM create -user -user -name and the name of your IAM user, of course. You can add whatever name you want after -username -name, and this is our script number 2. So right from here we can run this command and the new user will be created. So this is another useful information and useful command, as you can see, and I'm trying to get this and make this more simple just for you to understand. So let me now copy this command. So with this command we will create our new user. I can run my command. So let me copy here and we can hit on enter. As you can see, we are getting our JSON response, and this is our path in the root. As you can see, we are using what is the username, what is user ID, what is the Azure resource name, and the date of creation. Of course, exactly the same we can do with our command prompt. I will now add just number 1 after new user, and finally when I save all, I will now copy my command and let's go to our command prompt. I will hit on enter, and after some time we are getting the same response in JSON, but this time for new user 1. So just to remind you, I'm taping this or recording this exactly in the Serbian language, so I'm using exactly the same script. Just follow my instructions and you will be good. If I go to console and go to my IAM service, I need to first log in with my username and password. Of course, I'm using root credentials just for this course, and of course I'm using MFA to protect my account, and now I will add my MFA code from my phone. We already know everything, and we talked a lot about this secrets and how to use and when to use your when to use your root account, of course. And this is my MFA code. This is a one-time code, and finally, as you can see, if I go to users, we are now in our identity and access management. Here you can see that we have our new user and new user 1. So you can see that with AWS CLI it's really easy to create a new user. Now if I go back to my Visual Studio Code, I want to attach a user policy. As you can see, with command AWS IAM attach -user -policy -username. So I will add one of the name that we used in our first step for our user, and then -policy -arn. You need to copy Azure resource name for this user. Sorry, for this policy. We are adding a policy that this user will have Amazon S3 read-only access. So we are attaching policy to this user. Let me save this command, and I will now paste this, copy this, and let's see if this really works. So we are attaching our policy to our newly created user. This policy is only for Amazon S3 read-only access. And let's see if this really works. Let me now go to my console, and if I go to new user, you can see that we have our Amazon S3 read-only access. So this is how can you add your permission or policy to this user, and this user now has this read-only access to all buckets via the AWS console. Of course, we can add this policy for our new user 1, or you can also check or change your policy. And let's see if this works in our, let me first save this. Let me check if this works from our command prompt. So we are adding exactly the same policy, but for our second user, for user number 1, new user 1, and after some time you can see that we successfully added another policy or same policy for different user. If you go to our permissions, you can see that our new user 1 has exactly the same permission or policy that I want to add. This is Amazon S3 read-only access. So, as you can see, it's very easy to create a new user and add a policy for this user. Now, if you go to policies, you can add whatever policy you want for your user, and you can see that it's very easy to do this. If I, for example, go to AWS job function, we can add administrative access to our user. The one thing you need to do is to copy this Azure resource name. Copy and simply go to our Visual Studio Code and change this policy. Change this R, sorry. Let me change this for our new user. And simply I will copy the first part of this policy. Let me try again. That's it. I will copy this and paste before our administrator access. And now we can save this. You must save all the time if you're working from Visual Studio Code. And now we can copy this and paste it for our new user. So we are adding another policy. This is administrator access. And let me go to our console. I will now go to users, to new user, and if we refresh this page, you can see that now we have another policy or permission policy. So this user 1 or this new user has Amazon S3 read-only access and administrator access, AWS manage job function, and AWS manage. So as you can see, this we directly attach this. So you can see how can you create a user. So in this chapter, I want to show you how can you create a simple DynamoDB table. With command AWS DynamoDB create dash table, dash table name. So you will add the name of your table, and dash attribute dash definitions. You can use attribute name equal ID. Then we have attribute type is S, key schema is attribute name ID, and key type hash, as you can see. And provision throughput is read capacity unit 5 and write capacity unit is 5. Our region is US East 1. So this is the whole command. I already create a new script. This is our script number 3. Let me click on save all, and finally we will copy this long command and I will paste this in my in my command, as you can see. So we're getting our response in JSON, and you can see if I scroll down, we successfully created our DynamoDB. If I go to my, let me first search in our console DynamoDB, and if we check is there any new table, if we go to tables, you can see that we have my table and it is active, and as you can see what is our read and what is our write capacity, it is set to 5. So now in your table you can also create your comment. So we already learned how can we work with our tables. Exactly the same thing we can do in our command prompt. Of course, if I only change the name of my table, I will add simple 1 after that name. So we can also save this, copy, command. Let me copy the whole command. And of course, we can copy this command to our command prompt, and we will get our JSON response, as you can see. And we successfully created our DynamoDB new table. I will now go to my console and let me refresh this page. As you can see, we have our new table and status is active. So this is how can you create your tables with the help of AWS CLI command. So I will delete my tables because we don't need them anymore. And first let's click on select them, click on delete, and I must confirm this. And as you can see, we are deleting this, and after some time there will be no tables. Thank you for watching. So if you want to use simple notification service, you can create your topic with command AWS SNS create -topic -name, and you can add your topic name. You can add whatever name you want. I'm adding some random names just for all resources that we created with the help of our AWS CLI. So let me add I will change my name for this topic. For example, I will type pumping or something like that. And let me create this topic. I will first save this and let me copy whole command, and we will try to create this SNS topic. So I'm showing just a simple one, and as you can see, we must configure or add our region. I will simply go to our script number 3 and copy this --region US-east-1, and simply we can paste it after the name here, and we will now save this again, and let's try once again. Is this command really work? So let's copy this whole command once again. I will paste it here, and finally we are getting our earned response back, as you can see. And let's go to our console. I will now type SNS. This is our simple notification service. And let's go to topics. As you can see, we already have one topic resources for this region, and this is our pumping, some random name for our topic. And now you can publish message and play around, create some subscription if you want, and that's it. This is how can you create your topic. Let's now see, is this possible to work with our command prompt. I will just add a different name, as you usually know. As you already know, I usually add this number 1 after the name of our resource. So let's copy this once again, and we will go to our command prompt, and we're getting exactly the same response, but this time for pumping number 1. And if I refresh our page or simply refresh the whole page in our console, you can see that we have both pumpings and type is standard, and we can see what is Azure resource name. So I will now delete these two topics because we don't need them. Just wanted to show you how can you create this simple resource with simple notification service. Thank you for watching. One of the most used commands are how can you create your VPC. So if you want to create a VPC with CIDR block, for example 10.0.0/16, and you want to add a tag name equals my lab VPC, you will use AWS EC2 create -VPC -CIDR block, then 10.0.0/16 -tag -specification, and in the quote you will add the resource type equal VPC, then comma, text equal, and you will use this brackets and curly brackets with key name value my lab VPC. So let me just save this command, and finally I will now copy this command, paste it here, hit on enter, and we must specify our region, of course. I will now add my region. I will go to script number 4 and copy this --region US-east-1, and let me add it here in the middle of this command. Once again we will save this command, and I will now copy the whole command once again, paste it into our terminal, and hit on enter. As you can see, we are getting our response in JSON format again, so it usually means that we successfully created our VPC. Let me go to our VPC service in our console, and if you go to my VPC or your VPC or VPCs, we have our my lab VPC. As you can see, just what we want. And it is available, so you can run or work with this lab. Of course, we can change, for example, the CIDR block and change this tag name, and we can use this with command prompt. If I go inside, go to tags of this new VPC, you can see that key is name and value is my lab VPC, just what we wanted. If you want to create a subnet, you can use AWS EC2 create subnet, then --VPC -ID. We will add the ID of our VPC. We will add our CIDR block. This is 10.0.1.0/24. Then you will add your availability zone with --availability-zone US-east-1A. As you can see, this is the ID of VPC that we created in previous chapter. And after you add your availability zone, you will add your tag specification. We are using exactly the same tag just in the previous chapter. So that's the unique key, and I didn't forget to add my region. So as you can see, this is our tag. This is our script number 6. Let me save this, and I will copy this command, and let's paste it in our terminal. And let me see why our region isn't. So there is availability zone, but we must add our region once again, and I will paste it in the middle of this command. Let me, before CIDR block, for example, and now we can save this and try again. And let's hit on enter. And finally, as you can see, we are getting our response again. So once again, that usually means that this was successfully provisioned. And if we go to our terminal, and if we go to subnets, let me refresh this page, and we have our subnet, as you can see, and this is my subnet. And this is our subnet ID. It is attached to our VPC, and this is our IPv4 side range, as you can see, 10.0.1.0/24, and that's it. Thank you for watching. If you want to create internet gateway, you will use a simple command. This is our script number 7. AWS EC2 create -internet -gateway. Then we need to add our region, and we are specifying our tag specification. So as you can see, it is very easy to create this internet gateway, but it is necessary because we are building the whole infrastructure of VPC, of course. Let me copy this command and I will simply paste it here. As you can see, we created our gateway, and if we go to internet gateways, you can see that now we have both gateway, and this is not attached to our VPC. So as you can see, it's very easy to create internet gateway right from AWS CLI. And our tags are here, of course. If you want to attach this gateway to your existing VPC, you can use this command in script number 8, AWS EC2 attach -internet -gateway, then --internet -gateway -ID. So you need to provide your ID for your newly created internet gateway, and then you will add your VPC ID. And of course, our region is US East 1. So here, as you can see, we will add our, let's go to our portal, we will add our ID from here. This is our my gateway, internet gateway ID. Let me go back to my Visual Studio Code, and I will simply paste it here. And finally, we will do exactly the same thing for our VPC ID from, if you remember, we already created this VPC. Let's go to our VPC, and this is my lab VPC. I will copy this VPC ID and simply paste it here. We will simply delete this VPC with access and add our VPC ID. So I will now save this, and finally let me copy the whole command, and I will paste this to our terminal, and just like that, as you can see, we paste it 2 times. But let's now try to attach this to this gateway. Let me now go, or simply refresh this page. If we go to internet gateway, you can see that now our gateway is attached to our VPC, and this is our VPC. So by mistake, I copied this command twice. The next step is how can you create a route table. So there is a different, as you can see, commands. We will first create our route table, then we will add a route to our internet, and you can associate this route table with your subnet. So this is just a simple commands, and we need to change our IDs, and let's go step by step. In the first command, you can see that we will create our route table. You will run AWS EC2 create -route -table, then --VPC ID. So we need to change this and add our appropriate VPC, and we will use this tag specification. This tag specification isn't, this is an optional, but I want to show you how can you work with tags, of course. I will now copy the VPC ID from our console and simply change this VPC ID and then of course we need first to create our route table. I will save this. Let me paste this command and we will do not forget to copy our region. So you must specify also a region in this command. So let me save this once again. And now I will copy this and command and paste in our terminal to create our route table. As you can see, our response is already here in JSON file, so we successfully created our route table. Let's go to our VPC. If we go to route table, this is our route table, and you can see what is our VPC. Then I'll go to my Visual Studio Code. Here we need to add a route to the internet. We will use AWS EC2 create route --route table -id, and then we need to add our route table ID. Of course, destination CIDR block will be 0.0.0/0 because this is the route that lead us to internet. This is an outbound rule, of course. And finally, you can copy this route table ID and we will paste it here. And of course, we need to add or specify our gateway ID. Let me go once again back to our console. I will go to our internet gateway and finally we will use this internet gateway ID and simply swap with this command. Finally, let me click on save. We will copy this command, but before that, of course, we need to add our region. Let's save this once again and I will paste this to our terminal. And return is true. So we successfully added our route, and then we need to associate this route table with our subnet. We will use AWS EC2 associate -route -table, then --subnet ID. So we need to change and add our subnet ID here, and after that we need to add our route table ID. I will go to my console. First, we need to add our subnet ID. So let's go to subnets or route table if you want. This is our route. As you can see, we are successfully created our route. Let me add first my route table ID. And finally, we will add our subnet ID. And we will add this here, of course. Finally, I will copy my region. And we will add this at the end of our line or our command line. Let's save it all, and finally I will copy this whole command, and once again we will paste it to our terminal. Let's hit on enter, and it is associated, as you can see. So this is how you can run with multiple commands, and we created the whole VPC infrastructure. As you can see, this is our route table, and we can see that we successfully connected our destination and target with our internet gateway. And that's it. Thank you for watching, and I hope this was helpful. And this was a little longer demonstration, but we now know how to work with different VPC services, and that's it. But before we go, I will now go to route table, as you can see, and I will delete all these. Let me type confirm delete. I will delete all of these services that we created. First, we will delete our gateway. We must first detach this gateway from our VPC, or simply we can go to our VPC and delete VPC, and all of these resources will be deleted, my RGV, subnet, and so on. Now we don't have any resource that we created through this demonstration, and that's it. Thank you for watching. And finally, in this last chapter, or script number 10, I want to create EC2 instance. So if you want to create EC2 instance, you need to specify some different options, of course. We will run AWS EC2 run -instances -image ID. This will be AMI ID. As you can see, --count 1. I want to create one instance, and as you can see, our instance type is t2.micro. If I go to our EC2 service in our console, and as you can see, we are using North Virginia region, and if I choose Amazon Linux, you can see that this is our AMI ID. So you can copy this AMI ID for Amazon Linux and paste it here. So that's it. So we have one count, instance type is t2.micro. This is our instance type. As you can see, you can choose whatever you want. We have this from family T2. We will create keeper name. We will create a security group. You can add your security group here, and we can create our subnet or subnet ID. Of course, if you go back to our instances, let's go to our security group. This is our default security group, or you can add this one that we have. I will copy this security group ID, and let me paste it here. Then, so we are using our default options, default subnet, default security group. I will now go to our subnets. We must go to our VPC service. Let's go to subnets, and I will use one of these subnet. Let me just find what is our availability zone. So we are using US East 1A, if I remember correctly. So we will copy this subnet ID for this availability zone. This is also default subnet, and I will simply replace this with our new subnet. And finally, we have this subnet, this resource tag specification, and I already provided my region. I didn't forget this time. Let me click on Save All, and I will now copy this whole command This is a really long command. Let me check this once again. So we are creating our image, our instance, sorry. We are using our Amazon image, and we need to have our key pair name. So this key pair does not exist, so I can also delete this key pair, and finally we will run this command without our key pair, so we will create our VM without key pair. Let's try once again. Let me hit on enter. And we need to wait. Sometimes, as you can see, our VM or instance is created and we are getting our response back in JSON format, of course. When you see this in JSON format, it usually means that your resources are successfully created. So this is another sign that you doing everything right. So you can see what is our, you can see all these commands in our JSON file, sorry, all these values in JSON files. So if you want, you can even learn this more about JSON files, and you can simply go and see what are we creating. If I go back to our console, and if we go to our EC2 service, let's go to our instances, and here is our key pair. So our key pair was VMKP. So if you want, you can provide this in your command. Now if you go to our instances, you can see that my EC2 lab is up and running, but this machine is still in the phase of initializing. You can check all these tabs and you will see that we created exactly the same VM. And this is our key and value in tags. If I now go to connect and click on connect, you can see that we are failed to connect to our instance because our machine is still in the phase of provisioning, but you can simply connect to your EC2 just like machines that you created in our console. If we go to our key pair, you can see that we have our key pair. So let me copy the name of this key pair, and if we go to our Visual Studio Code, of course you can do this everything, this command from command prompt. I will now add my key pair type, and we will add the name of our key pair. Let me now save this. I will copy the whole command and paste it in our terminal. Let me just check this once again, this command. Everything looks fine, but we need to add our my EC2 lab 1, for example. So we are creating different VM, so the name must be different, of course. And finally we will save everything and copy this command, paste it in our terminal, and let's see what is key pair. Key name. This is the right command, of course. And now we can, it is always good to troubleshoot your commands, because one little mistake can cause a very much problem and headache. And finally, as you can see, we are now creating our VM with our key pair, and everything looks fine. we're getting our JSON response back. And finally, if I go to my console, let's go to our instances, and I will refresh this page. And finally, as you can see, my EC2 Lab 1 is up and running, and we can now see that we have our key pair name and it is located in the same location. Of course, you can add this count to 2, and if you save this once again, it will create 2 virtual machines, exactly the same virtual machine. Let's try this once again, and as you can see, just like that, we're getting our response back in JSON once again. And now with this one command, we create 2 virtual machines. Let me go back to my console. If I refresh this page, you can see that we have our 2 new virtual machines based on the same image and instance type. So with the help of this command, you can create dozens of virtual machines. And that's it. This was the last demonstration of how can you work with AWS CLI commands and how can you create different resources. Of course, there is a lot of commands that you can find on official AWS portal or pages, documentation, and you can also exercise with different resources. How can you create them and so on. So this was just a little exercise just to take you some of this process of how can we work. And of course, I will now delete all of this lab that we created. Let's go to actions, to instance state and delete these resources. I will now terminate these resources, and that's it. Thank you for watching, and I will see you in the next section. AWS Organizations is a service that allows users to centrally manage multiple AWS accounts as a group. It allows you to consolidate accounts, apply control policies, and streamline billing on those accounts. Essentially, it provides a way to organize and manage your AWS environment while scaling your workloads. AWS Organization is a free management tool that allows users to create and manage multiple AWS accounts. It helps you manage multiple user accounts from a single site or account instead of moving from one account to another each time. It is a tool for centralizing and managing all users' AWS accounts. With the help of AWS Organizations, users can create a new AWS account, link existing accounts, and share resources between accounts. AWS users can also centralize their logs and set policies on how their AWS account will be managed. An AWS user can assign a single AWS account to keep their logs by integrating with AWS CloudTrail. Billing can easily be consolidated into a single payment order for all orders. Reserved instances can be shared between multiple accounts. These help users pay for reserved instances through a centralized system. The maximum number of user accounts within an AWS organization is 10. This can also be changed by contacting AWS support. Setting up AWS organization is free, so users will be only charged for the resources used in each of these accounts. Well, there is some components of the AWS organization. First, you must have manager or master account. This is a master account in AWS organization that helps all administrator rights for all accounts within the particular AWS organization. It is used to centrally manage all orders and handle billing and records of all orders in the organization. Then you have membership accounts. This is account in an AWS organization that, other than the master account, these are called membership accounts. These can be existing accounts or new accounts added to this organization. Then we have something called organizational units, or OU. The unit in which all orders are grouped is called organizational unit. Multiple organizational unit can be created in an organization and can be nested within each other. Then we have policies. The AWS organization provides a variety of policies to help limit or set boundaries for each order. The most important policy provided is the Central Control Policy, or CSP. And now I want to talk more about this. So when you have an AWS organization, you have option to add policy. Then you will choose AI services to opt or out policies. If enable, they allow AI services to store and use your content. You have backup policies. These are used to enable organization-wide backup plans to help with compliance. They help you maintain consistency. And we have service control policies. This is the most important policy of AWS organization. They help restrict account with the organization access control policies. Of course, there is tag policy. These are used to set standard for resources that are tagged in AWS. So users can define tag keys and their allowed values in this policy. Now let's talk about service control policy. These policies are already used, as already said, are used in our AWS organizations to create specific policies. It is a simple document that you will use to manage or create permissions or policies for users or resources within this AWS account. This can set limits on what users can do within an AWS account. Once implemented, they are applied to each resource within that account. They are best way to restrict user or resource permissions. They can also be applied to the root account. You can find it under AWS organization, policies, service control policies. So, here are more detailed overview. Organization allow you to manage multiple AWS accounts from a single management policy. This eliminates the need to switch between orders for different tasks. You can group accounts into organizational unit or OU based on your needs, such as business units, environment, development, test, production, or security requirements. You can implement policies, so you can apply policies to your organizational unit or individual accounts, controlling access, resource usage, and compliance across your organization. You can set up consolidated billing, where all orders in your organization are billed under a single billing account, which simplifies payment and potentially offer cost savings. Organizations make it easy to share resources between different accounts, which can be useful for certain workloads and services. It will integrate with other AWS services if you want, and this can ensure consistent configuration, security mechanism, and resource management across your organization. Essentially, AWS organization provides a framework for managing the complexity of multiple AWS accounts, allowing you to scale your business securely and efficiently. This organizational unit is a container within an AWS organization that is used to group these accounts. These groupings help you organize and manage accounts more efficiently, especially when applying policies or control to multiple accounts. This organizational unit can be nested, of course, for a hierarchical structure that reflects the structure of organization. So, account grouping or OU logically groups AWS account, make it easier to manage them collectively. Then you can create nested OUs, enable a hierarchical structure that reflects the structure of your organization. For example, you can have different OUs that we already learned, like development, and then into that you can create a new one, for example, for front end and back end. The policies of AWS organization can be applied of organizational unit. This means that any account with organizational unit will automatically inherit these policies, simplify policy and management. If you remember, when we talk about Azure Management Group, this is something like that. And then AWS organization provides a central location for managing multiple accounts, and this organizational unit can play a key role in this by allowing you to apply policies and control the logical groups of this account. You can have, for example, organizational unit for production account and another for development account, each with its own set of policies for access control, security, and other configurations. So here it is, as you can see, we have our root organizational unit. Then you can add this account. Let me just grab my pen for a second. And here, as you can see, this is our root organizational unit. For this root organizational unit, you can set up your policy. Then in that, sorry, this is our root organization. Then you can create 3 different, for example, OU. This is the first organization unit, and this is the second one. In that units, you can set up a member account or another organizational unit, and that on another level, you can go even more granular, and you can add different account members in that organizational unit. Exactly the same on the other side. And also, when you add a policy, for example, for this organizational unit, all this member group will inherit those policies, for example. Exactly just like here. If you add your organizational policy to this organizational unit, all of these member accounts and this organizational unit will inherit this policy. Simple as that, nothing special here, and that's it. What do you need to know about AWS organization? AWS Control Tower is a service that simplifies the setup and management of a secure multi-account AWS environment based on best practices. It provides a centralized way to manage and monitor your AWS account, automating the enforcement of governance rules for security operations and compliance. Essentially, it acts as an orchestration framework built on top of AWS organization, helping you establish and maintain a landing zone for your AWS accounts. It offers a simple method to set up and manage AWS by setting up multiple accounts while following prescribed best practices. It combines the capability of a number of those of other AWS services, including AWS Organization, AWS Service Catalog, and IAM Identity Center replacement for AWS Single Sign-On to quickly create a landing zone. It uses a preventive investigative controls to help prevent your organization and orders from deviating from recommended practices or guardrails. For example, guardrails can be used to ensure that security logs are required, access rights for multiple accounts are created and maintained. So, why would you use this AWS Control Tower? First, because it's built on the backbone of AWS organization, so you can automatically control access and permissions for child accounts. You can define service control policies in AWS organizations to limit services available to different accounts within your organization. To ensure that your organization has safeguards in place to maintain a secure environment, you can apply policies to account users and define permissions for multiple accounts. Then, this is especially useful for limiting power roles in child accounts. The child account does not have any ability to override the restriction imposed by the master order. It is more difficult to assign the chosen administrative access without the controls available within the AWS organizational structure. Then, the third step is that AWS Control Tower and AWS organization are most appealing to enterprises with a diverse set of IT roles and requirements. It's also useful if you want to separate compliance standards while maintaining the default functionality in different environments. As you can see, orders are assigned to different organizational units, and now AWS organizations are used to provide with these roles. The security has 2 orders, a log archive order and audit order. The log archive order acts as a central repository for all CloudTrail and AWS config logs throughout the landing zone. So, our control tower looks like this, as you can see. With this AWS control tower, you can use this AWS organization and AWS single sign-on, and you can add some federation service via a third-party provider. Here, you can see that in organization, you have some organizational units, and in that organizational unit, you have some different log archive account, audit account. For example, this is security organizational unit. Then you have sandbox organizational unit. For example, another account is here. Then you have production. You have here your production account here. Non-production organizational unit is stored here, some different account. And then you have shared services, for example. Then you have shared service account, network account, security service account. You have, for example, suspended organizational unit, and you will add your account number 2 here. So with this AWS Control Tower, you can centralize monitor all of these organizational unit. And of course, if you go back to our services, you can see that there is a different explanation. That, for example, this sandbox organizational unit, it is configured to host test accounts that are securely separate from any other production workload. Then you have our production organizational unit. This OU is responsible for hosting all your production orders and workloads. Then you have non-production OU. This OU can be used as a pre-production environment for additional testing and development. Then in this suspended organizational unit, this is just some kind of secure container, for example, where you can move any deleted, reused, or compromised account. Permissions in this organizational unit are strictly restricted with Azure, that is a safe location. And then you have these shared services, and you can add all services that you want to share by a number of different accounts. So it really depends of what do you want to use. As I already told you, AWS Central Tower is a service that simplifies the setup of management of a secure multi-account AWS environment based on best practices. Simply go to this service and try this if you have more than one account and if you use AWS organizations. So what is included in this standard AWS Control Tower? We have basic organization unit with 3 tasks. As I already told you, we have master account. It allows you to create and financially manage members account. It is also used for securing and reporting factory orders, managing organizational unit, and guardrails. We have a log archive account. This includes a central Amazon S3 bucket to keep all logs of our API activity and resource configuration from all solution accounts. And we have something called audit order. This is a limited account that provides security and compliance team with read and write access to all orders in the landing zone. So you can programmatically view orders from a revised account thanks to a role that is only available to our Lambda functions. A revised account does not allow you to manually log into other accounts. Then we have initial security foundation, which includes AWS Cloud Trail data is sent to the centrally managed S3 bucket of logging orders. In addition, the AWS configuration is sent to a centrally managed S3 bucket in the logging order. AWS configuration policies are enabled to monitor encryption, IAM password policies, MFA, and security group policies. In AWS IAM roles, possibly you can include the limitation imposed by master order, and you have option to see preliminary Amazon VPC network. Finally, we have account factory. Essentially all an AWS service catalog products that allows you to automatically create new child account and for this existing organization while maintaining all predefined security bases. And we have control tower control panel. The user interface was limited to the basic structure of the control tower. The dashboard display only the components that are arranged and managed by the control tower. The use of AWS Control Tower is free of charge. However, once that you set up this control tower, you will begin to incur the cost of the AWS services configured to set up your landing zone and mandatory guardrails. You only pay for what you use and only when you use it. For example, if you enable public subnet in the factory configuration of an AWS Control Tower account, when creating a new account, the factory account will configure Amazon VPC to create, for example, a NAT gateway, and Amazon VPC will charge you for that usage. If you are running ephemeral workloads for an AWS Control Tower account, you may see an increase in cost from AWS config, as it records configuration changes associated with creating and deleting these temporary resources. Spot instances of Amazon Elastic Cloud or EC2, Amazon EMR jobs, and AWS autoscaling are some of these examples. Well, when we talk about pricing in AWS Cloud, AWS Cloud pricing follows as you pay per use model, which means you only pay for the services you use, with no long-term contracts or upfront commitments. Prices vary depending on the specific services that you use, the amount of resources consumed, such as calculation time, storage, space, data transfer, and the region in which these resources are located. Also, AWS also offers a free tier for certain services and discount for reserved instances. Here are some of the key pricing aspects of AWS. First, we have pay-as-you-go model. This is the most AWS services operate on this kind of model, which means that you pay for what you use when you use it. This eliminates the need for large upfront investment and allows you to scale flexibly as your needs change. Then we have free tier account. AWS offers a free tier for many of these services, allowing users to explore and experiment with a limited amount of usage at no charge. The free tier usually include both always free services and free trials for a limited period. Now, this free tier is changed and you are already aware about these services. For example, you can get 5 gigabytes of storage on Amazon S3 and 750 hours on Amazon EC2 usage per month as a part of free tier or Amazon Web Services. Then we have number 3 variable prices. For the compute storage, prices for EC2 instances vary depending on the instance type, region, operating system, and purchase option, on-demand, reserved, or spot. Then for the storage prices for the Amazon S3, depending on the storage class, standard, AA, Glacier, and region. Data transfer costs vary depending on the direction of transmission, inbound versus outbound, destination, and region. And when we talk about other services, prices for other services such as database, networking, and machine learning vary depending on usage metrics. And then we have discount and reserve instances. AWS offers significant discount for reserve instances, where you commit to using a certain amount of computing capacity for a certain period of time, for 1 to 3 years, for example. Reserve instances can provide significant cost savings compared to on-demand pricing. We have something called AWS calculator price. AWS offers a pricing calculator that helps you estimate potential costs based on your specific usage scenario and resource requirements. This tool allows you to select services, regions, and configure resources usage to get a detailed overview of cost. And we have support plan or plans. So there is a variety of supported plans with different levels of support and associated cost. Mainstream support is included with all accounts, but you can upgrade to more comprehensive plan for faster response times and more productive support. By understanding these key aspects of pricing on AWS, you can effectively plan and manage cloud cost and optimize the cost of AWS resources. In the previous chapter, I mentioned something called AWS pricing calculator. So, with AWS pricing calculator, you can check all these resources. This is a free web-based tool that helps users to estimate the cost of using Amazon Web Services. It allows users to model different AWS services configuration and usage scenarios to obtain detailed cost estimates before deploying resources. This helps customers to plan their expenses on AWS, research service pricing, and potentially identify cost-saving opportunities. Here, some features and benefits, like cost optimization. The primary function is to provide cost estimates for various AWS services based on user-defined configurations and usage patterns. Users can create different scenarios by varying service configuration, instance type, storage options, etc. to understand the impact of different choices on costs. The calculator allows users to explore the prices of different AWS services and understand how they are determined. Also, you can use this for discount and obligation planning. You can also take into account potential discount for reserved instances or saving plans when estimating costs. Also, by using the calculator, users can better understand the potential AWS cost and plan their cloud deployments accordingly. The tool can help identify potential cost-saving opportunities by allowing users to compare different services configuration and pricing option. Essentially, AWS pricing calculator is a valuable tool for pre-deployment planning. It helps customers to understand the potential cost of their AWS deployment before actually providing resources. For cost optimization, allow customers to identify opportunities to reduce their AWS cost by making informed decisions about service configuration and usage patterns. For budgeting and financial planning, helps customers accurately estimate their AWS expenses and plan their budget accordingly. If you go to calculator.aws, you can see that we can create or work without AWS pricing calculator. Here you can configure a cost estimate that fits your business or personal needs with AWS products and services. You can start this calculator without any cost. So let's click on create estimate, and as you can see, we can add our service. There is currently 154 services that is available, and you can select this by location type, so you can set the services that are available in your region or some local zone or waveland zone, or you can search all services and configure this as an estimate. By default, as you can see, it is selected to search by location type, and here you can set this up and choose your location type or choose your region, for example, and then you can search for a service. Also, you can see there is a different option. So in the first step you will add your service, and in the second step you will be able to configure your service. And you can see, if I click here, you can choose your location type, region, local zone. If you choose a local zone, there is, for example, some cities beyond this region, and you can choose a local zone. If you choose, for example, wavelet zone, you can choose different wavelet zone, of course. Again, you can choose a region or by, for example, cities. It really depends where are you live. And finally, you can simply choose between this location type and between this wavelet zone, local zone, and regions. This is if you want to use search by location type. So you will use this Verizon, for example, providers, different providers for 5G network. If you remember, this is our wavelet zone. Then we have, as you can see, different providers. Then if you go back to our region, we can check our different region. As you can see, I will choose my US North Virginia region, and finally I can go to find service, and I will find my EC2 service, as you can see, and there is a detailed explanation what is this service used for. If I click on configure, I can add a description for my for my instances. I can choose my tenancy, shared instances, dedicated instances, or dedicated hosts. So here you can choose the tenancy type that it will run your EC2 instances on. Then you can choose between Linux, between operating system. We have different distribution of Linux. We have Windows Server, and you can also use Ubuntu Pro if you want. I can choose my Linux or Windows. So it really depends of what do you want to move from your on-premises to your cloud. And here you can choose the best graph that represents your monthly workload. You can choose between constant usage, daily spike traffic, weekly spike traffic, or monthly spike traffic. Then you will specify the number of instances that is available and that you need for each month. For example, if you choose, for example, daily spike, if you have some spike between some hours, for example, from 1 to 5, you will use that daily spike. And finally, you need to enter your number of instances. Then you can choose your search for instance type. For example, I can check different instances. Let me find our t2.micro or some different instances, and it really depends on the size of this instance. Your monthly price will be then, as you can see, I can check my instance type family T2, then I want to 4 vCPU, and I can add my 2 gigabytes of memory, and you can set up your network performance, and you can choose between these various options or offers, of course. And after that, you can see that this is our instance type, and if I choose one of them, you can see that our payment option is now 269.22 USD, and we don't have any total upfront cost. And in the payment option, I can choose my savings, as you can see. So you can select one of these options to find your best price. You can choose compute savings, reservation between 1 or 3 years, and you can choose your payment option, upfront, no upfront, partial, or all upfront. Then EC2 instance savings, we already know about the savings plan. As you can see, from one reservation for 1 to 2 years, you can save up to 72%. And finally, we have some different prices, and that's it. Of course, you can check other purchasing options like standard reserve instances, then convertible instances. Then here is our calculation. You can add some elastic block storage if you want. You can choose between general purpose SSD 3, and here you can add some IOPS input output, for example. You can add some different throughput, how much megabytes per second per volume, then storage amount, snapshot frequently, and so on. So there is a really granular option that you can set up with this pricing calculator and see how much it will cost you monthly. And of course, this bill will depend of what are you setting up, or here, of course. So here is our calculation, and finally you can see this monitoring option if you want. You can check your data transfer. This will also increase your monthly cost. You can add more inbound data transfer, inter-region data transfer, and so on. So anything new that you add for this EC2, for example, it raising your price accordingly. And finally, you're good to go. As you can see, this is our monthly cost. And if I go to save and view summary, or you can simply go to save and add service. So this is my estimation summary. My cost for 12 months, as you can see, is 4,376.88 USD, and you can see what is my monthly price, and my estimation is for my Amazon EC2 machine. You can contact sale, get started for free, or add this service, and finally, when you're happy, when you're satisfied, you can add a new service if you want. You can search for all services here, and that's it. This is how you can use AWS pricing calculator almost exactly like in our Azure. So you can add some EBS, for example, choose number of volumes, average duration of time, unit hours per month, and so on and so forth. I hope now that you have a clear picture of what is AWS pricing calculator and why it is important to learn more about pricing calculator. And That's it. Now we have our Amazon EC2 and our Amazon Elastic Block, as you can see, and our monthly price is up. You can also choose your language, and that's it. Thank you for watching. In AWS, tags are only key and value pairs that act as a metadata for your resources, helping you organize, manage, and identify them. These are tags that you can apply to resources such as EC2 instances, S3 buckets, or databases, allowing you to categorize them based on various criteria such as purpose, owner, environment, or cost center. Key features of AWS tags. This is just a key value pair. Labels consist of a key, for example environment, and a value production. This provides metadata. This provides information about the resource, allowing you to track and filter resources based on your needs. User-defined, so you will define the key and value that best fit your organization labeling strategy. Also, tags are key to cost allocation, allowing you to track and analyze your cloud expenses across different categories. Tags can be used in IAM policies to control access to resources. Also, you can use it for automation. This facilitates automation by allowing you to target specific resources based on their tags for tasks like patches or backups. So, with AWS tags, you have some advantages like improved resource management. You can easily identify and manage resources based on your tags, efficient cost allocation. You can gain insight your AWS cost by labeling resources by center or project. It has simplified access control, so you can implement granular tag-based access control using IAM policies. Then you can use for automate tasks such as patching instances or backing up based off resource tags. It can help you to have better organization of your AWS environment, so you can keep this organization organized and consistent. And tagging allows you to assign metadata to AWS resources in form of tags. Each label is a simple label consisting of a user-defined key and an optional value that can make it easier for manage, search, and filter resources. You can use AWS resource tagging to apply business and organizational information to your usage and cost, providing additional insight into optimization from an organizational perspective. AWS resource tagging allows you to create a general purpose automation script based on tags rather than individual resources. Once again, we are in our Azure portal, in our AWS console, and finally we can go to our EC2 service. And here, if I go to my instances, you can see that I don't have any instance. So if, for example, if I go to launch any instance, I can set up a name for my instance. This will be simple VM Linux instance. I can choose my image. This is Amazon Linux image. We will use our instance type t2.micro because this is a free tier eligible, and here I can select my key pair, and in the networking settings I can choose my existing default resource group. So we are using our default network and security groups for our North Virginia region, and here you can see that we have our storage. Let me create this instance. We successfully created our instance, and if I go to instances, you can see that after I refresh my page, we have our Linux here machine. And then if you create another machine, based exactly on the same image and instance type, we are using exactly the same key pair and exactly the same networking and VPC, and default security group. in the advanced details, I can add my tags and metadata. Let me add this enable tags in metadata. So we are enabling this in advanced section of this VM or instance. And I will now click on launch instance. Our instance, second instance is completed. Let's go to our instances and let me refresh another. Let me once again refresh this page and we have VM Linux and VM Linux 1. If you remember, in our VM Linux 1, we are enabling our tags. If I go to tags for my VM Linux, you can see that we have our tag here. So this is our name and our VM Linux. If I go to manage, we can simply add a new tag if we want, and you can add up to 48 more tags. So 50 is default for all, for one instance if you want. So if you have two instances, you can add 100 tags for both of them. So I will add new key, this is production, and for the value I will add my VM underscore Linux. Let me hit on save. And now if I go to tags, you can see that I have two tags. One is production and the second one is name. If I go to the tags on other VM1 Linux, if I manage these tags, I can add a new tag also. So first we need to enter our key. This will be test, and value will be, for example, VM1 underscore Linux. Let me once again hit on save. So we are adding another tag for the second VM. As you can see, we have both tags here, and we still wait for our VM1 to be initialized. And if I refresh this page once again, finally both of our machines are initialized. Then I will open a new tab, go to our search bar and type AWS Resource Explorer, as you can see. Resource group and tag editor. And that's it. When I talk about resource group, here is our resource group. We have this tagging. If you go to tag editor, you can use this for search to your resources by using tags. If I go to tag policy console, you can see that this is a service that can be used only for AWS organization. So it requires to create this organization. I won't create any organization, but I won't go to my tag editor. Here I can find my region. My region is North Virginia, as you can see, or US East 1. Let me find my US East 1. This is our US East 1. And here I need to choose my resource type. Our resource type is EC2 service. This is our instance. And you need to type our key or tag key, for example, production. And let me add this VM Linux. And finally, when you add another tag key, we will add test from our VM1 and we will add our second value. Let me hit on add. And now when I click on search, both of our machines should be listed here. But for some reason I don't get my machine here because, as you can see, we're using our North Virginia region. Let me once again check this, our US East 1. If you have some different regions, you will add this, you will select your region here, of course. US East 1 is our region. Let me check this once again. I will now check my resource type, for example, and let me once again type EC2 instance, so everything is good, everything is working, and I can add, for example, VPC. If I type on search, we still don't get our virtual machine based on these tags. So let me once again add this all supported types, and sometimes AWS can be really annoying, but as you can see, we can use our Resource Explorer to quickly manage our resource tag. I will simply delete this and type search once again. And we need to wait for AWS to load our resources. As you can see, we are getting our instance in with all resources. So this is just an optional. If you don't want to see all of this, simply just don't add this optional tags. Here you can see that we have our two instances, and if I click select the resources, you can see that now we can see our instances, and now we can edit of all selected resources. So with this option, you can remove your tag, you can edit your tag, add a new tag to these editable resources that we selected. So here in this tag editor, you can, for example, add a new tag or remove this tag from these virtual machines that we edit, or simply you can add your tag. After you finish with editing this tag, simply click on review and apply these tags, and that's it. I will now, for example, add my new tag, and let me add this tag value. And if I click on review and apply, this EC2 tag will be added to our VMs. Now if I go back to our VM Linux and go to tags, you can see that we have our value name, and the value is now EC2, not VM_Linux. So this is how can you edit your tags and select all VMs based on these tags. Our second machine still has this, but as you can see, we add another key pair for both of our resources, so both of our resources has this tag. Now, if I go to create resource group in AWS resource group option in our saved resource group, you can select a group to define the group based resource types and tags, or create a group based on existing cloud formation stack. As you can see, first I need to choose my resource, and then I can add my tag. Here I can see all my group resources, and for example, if I choose my tags for these VMs, let me go to tags and let's add, for example, name and EC2. If I click on preview group resources, you can see that we are getting our two VMs or two instances that we created based on tags, of course. Now if I want to group them together, I can add a name for this resource group, for example RG1, and I can add a description for this group. This is an optional. And finally, when I click on create group, these virtual machines or instances will be added to this resource group based on tags, of course. And you can see that in the resources page we can save this resource group. This is also optional. I can add my tags, for example production, and add some different value. Let me click on create group. So this is how can you create a group in AWS. So this group can only group your resources based on tags, as you can see. And now I can see my group. This is EC2 instances and I'm the owner. And if I go to settings, you can turn on this group lifecycle events. You can create an event bridge or receive group lifecycle notification. If we go to save group, you can see that we can edit our group or delete this group. So anytime you can create this group based on tags, and you can add or remove a new resources. Not only instances, you can add different resources. Of course, as you can see, resource group in AWS has some different functions than in Azure. If I now go to billing and cost management, and if I scroll down, let me just find my cost allocation tags. You can see that when I go to my cost allocation tags, we have AWS generated cost allocation tags and we have our user defined cost allocation tags. So using these tags, you can use this to generate all your, for example, resources. We can add our key, and now we can, for example, search all this based on key. So there is a no match because we don't have this cost allocation tags. We are using only tags for our resources. But this is how can you use tags to group some resources or check some other information. So in this chapter we looked how can we edit a tag, how can we simply remove or add a new tag, and how can we group both of these machines based on resources. As you can see, if I choose the name, this is inactive, and I can activate my tag by choosing this machine and click on activate. And now I want to activate tag for my machine. As you can see, this name is activated, and finally you can now allocate your machine or check your user defined cost allocation tags for that virtual machine, of course. And you can undo your allocation tag and so on. So as you can see, tags are very, very useful, and you can activate them, deactivate them, use for different purposes, and so on. Simply go in your console and you can play around with this. Let me go to my resource group and tags. I will now go inside my group, and we will now delete this group because we don't need this group anymore. And of course you can create a new group if you want, but it is always good to delete everything that we created in this demonstration. I will now go to instance state and terminate both of my instances. Let me hit on terminate, and that's it. The machines are now shutting down, and very soon it will be terminated. Thank you for watching. AWS Trusted Advisor is a web-based real-time recommendation service that helps customers optimize their AWS infrastructure. It provides guidance based on AWS best practices in 5 key areas: cost optimization, performance, security, fault tolerance or resiliency, and service limitations. Trusted Advisor analyzes your AWS environment and offers special practical recommendations to improve your cloud environment in these areas. AWS Trusted Advisor helps you get a near-perfect cloud providing recommendations based on the well-architected framework. If you're familiar with the AWS well-architected model, you know that the cloud needs to be secure, reliable, fault-tolerant, and cost-optimized. While there are hundreds of best practices in each pillar, it's challenging to become well-architected by hand. AWS Trusted Advisor saves time by automating WAFR processes. AWS Cost Explorer takes an in-depth look at cost-related metrics and makes recommendations based on previous usage. Trusted Advisor provides recommendations that outweigh the cost from best practices. On the other hand, an AWS inspector checks for security vulnerabilities in your AWS infrastructure. AWS Trusted Advisor has a built-in design principles and best practices of the AWS well-architected infrastructure. When you subscribe to a support plan, Trusted Advisor analyzes your infrastructure against these best practices. Trusted Advisor provides actionable items and useful links to help you optimize your cloud, so you can use Trusted Advisor to detect issues with service quotas, performance, and security. So, here in this table, you can see that Trusted Advisor identifies the opportunities to reduce your AWS costs, suggesting action such as optimizing instances, identifying underutilized resources, or using reserved instances. So it is good for cost optimization. Also, it can help you with the performance. It helps improve the performance of your application by recommending actions such as optimizing Amazon S3 storage classes, enable Amazon CloudFront for faster content delivery, and improving database performance. It is good for security. It identifies potential security vulnerabilities such as open security groups, exposed S3 bucket, and unencrypted EBS volume, and suggests actions to improve your security posture. Then, as we already mentioned, it is great for fault tolerance or resilience, so it can help improve the reliability and availability of your application by recommending actions such as using multiple availability zones, enabling replication between your region for critical data, and implementing appropriate backup strategy. And it also monitors the usage of your resources and alerts you when you are approaching service quotas, allowing you to manage resources efficiently and avoid potential outages. Trusted Advisor uses a set of best practice checks to assess your AWS environment. These audits are based on AWS well-architected framework and insight gained from serving thousands of AWS customers. When a Trusted Advisor identifies areas for improvement, it provides recommendations with clear explanations and steps that can be taken. So, if you want to use Trusted Advisor, there is a lot of advantages. First is cost saving. By optimizing resource usage and identifying areas to reduce cost, Trusted Advisor can help you save money on your AWS account. Recommendations can be used to improve performance and can lead to faster application response time and better user experience. By addressing potential security vulnerabilities, Trusted Advisor helps you protect your AWS environment from threats. Then we have fault resilience or fault tolerance, and resiliency recommends can help you that your application remain available even during unexpected events. Also, a Trusted Advisor helps you adhere for the latest AWS best practices, ensuring that you use AWS services efficiently and securely. A Trusted Advisor provides real-time guidance, allowing you to resolve issues quickly and proactively, and having an AWS Trusted Advisor can go a long way in securing your cloud resources, improving operational efficiency, performance, and more. Ideally, a Trusted Advisor should help cloud users to optimally secure their resources. Some of the main ones include compliance with AWS best practices. A Trusted Advisor ensures that your AWS environment adheres to the latest AWS best practices, helping you to get the most out of AWS services to their full potential while maintaining an efficient, secure, and reliable infrastructure. The AWS Security Token Service, or STS, is just a web-based service that allows you to request temporary credentials with limited privileges for AWS resources. It is primarily used to grant temporary access to IAM roles or to manage access for federated users. These credentials, including the access key, secret access key, and token, have a limited lifespan, typically from 50 minutes to 36 hours, and expires automatically, which improves security. Key functions of this service is that you can set up to get temporary credentials, so STS issues temporary security credentials as opposed to permanent IAM credentials, reducing the risk of unauthorized access. STS makes it easy to use external identity providers, such as corporate directories or social media logins, to AWS resources without the need to create a separate AWS accounts or identities. So you can use for identity federation. And for multiple account access, organizations can use STC to grant access on one AWS account, temporary access to resources on another account, simplifying resource sharing. And finally, you can use it for EC2 instance access. STS can be used to provide temporary credentials to applications running on EC2 instances, allowing them to access other AWS services. How it works? First, we have something called requirement. An authorized user or application requires temporary credentials for STS. Then STS verifies the identity of the applicant, like I'm user, a federal user, or an application on an EC2 instance. This is authentication. And then when it comes to authorization, the STS verifies the applicant permissions based on the associated IAM role or policy. Then it will issue a credential. If you're authorized, the STS provides temporary security credential, access key, secret key, and token with a defined expiration time. Then the next step is the usage. So the applicant uses these credentials to interact with AWS services. And we have expiration. After the expiration time, the credentials are no longer valid and you need to require a new access request. Advantages of this service is improved security. So by using temporary credentials, STS reduces the risk of long-term exposure of permanent credential. It simplifies access management. STS simplified the process of managing access to AWS resources for different users and applications, and it had improved flexibility. So STS provides flexibility in granting temporary access for various scenarios such as multi-account access, federal login, or application login. AWS Security Token Service, or STS, provides a mechanism for issuing a temporary credential to users that allow them to access additional resources. Credentials are generated dynamically and not stored for the user and have a short lifespan. After the expiration of the issued set of credentials, the user must again request STS to regain their privileges if they still need them. So, using these temporary credentials issued by a Security Token Service helps you increase the protection of your AWS account. You can assign users a reduced set of permission and then allow them to gain short-term access to sensitive resources individually. STS and IAM roles complement each other. So STS credentials are typically used to delegate access to IAM roles in your AWS account. A role is an AWS identity that includes one or more permission policies that allow access to specified AWS function. You can assign roles directly to your AWS user, but this creates the risk of having too many privileged accounts. For example, clearing an S3 bucket can be a sensitive but rare operation for your organization. If a role is directly assigned with the permission to delete the bucket or bin, it means that anyone who has access to the credential can always delete the bucket. STS allow unauthorized users to take on these privileges roles on occasions when they really need them. Instead of permanently holding the role of clearing the bucket, users can temporarily gain the necessary privileges and then have them automatically expire. This maintains security by allowing a minimum set of privileges to be retained on the user's account. When do you want to use AWS STS? So STS is crucial for several different AWS authorization streams. Here are 4 common use cases that make it easier. So it is good for short-term access to privileged AWS resources, access to AWS within applications, identity federation scenarios, and multi-accounts access and delegated access. STS is suitable for any situation where you need short-term access to privileged AWS resources or functions. It allows your existing users to take on a sensitive role without having to set up a separate IAM identity or risk forgetting to revoke credential later. You can use STS to improve the security posture of your AWS account by preventing these roles from being directly assigned to your users. Instead of configuring STS policies for your users so that you can request a role when they need it, STS helps you manage the credentials needed by the application and tools that integrate with your AWS account. It is the best to avoid distributing regular IAM credentials as they provide long-term access to the privilege granted to them. So, with AWS Security Token Service, you can assign your application locked credentials that it can use to take on additional privileges. If you need to change or revoke those privileges, you can do so without having to provide the app with the new credentials. Although we have already been introduced to the AWS Cognito service in one of the chapters, it is time to dedicate a separate chapter to this part of the cloud provider. Amazon Cognito is an AWS service that provides user authentication and authorization for web and mobile applications. It acts as a user directory, authentication server, and authorization service, allowing developers to easily integrate user registration, login, and access control into their applications. Key features of this service and functionality. We have something called user pools. So Cognito user pools are user directories that store information about user profiles, such as email, username, and password. They handle user registration, authentication, username, password, social media logins, etc., and user management. We have identity pools. This is nothing but federated identities. Cognito identity pools allow users to access AWS resources. They provide temporary AWS credentials to users regardless of whether they are authenticated or not, allowing them to interact with several, such as S3, DynamoDB, etc. Cognito handles the process of authentication. This is the verification of user identity, and authorization, control access to resources. Also, Cognito supports social media logins from providers such as Google and Facebook, simplifying the sign-up process for users. Cognito allows for custom authentication flows, including passwordless authentication using web password or SMS email OTPs. Then, Cognito integrates seamlessly with other AWS services such as AP Gateway, Lambda, and AppSync, allowing developers to create robust and scalable applications. Cognito prioritizes security using industry standard protocols and supporting features such as multi-factor authentication or MFA and encryption. It also helps to meet compliance requirements. Essentially, Cognito simplifies the complex task of managing user identities and access in web and mobile applications, allowing developers to focus on building the underlying logic of their application. The Amazon Cognito Identity Pool is a directory of federated identities that you can exchange for AWS credentials. Identity pools generate temporary AWS credentials for users of your applications, regardless of whether they have signed in or have not yet been identified. With AWS Identity and Access Management, or IAM roles and policies, you can choose the level of permission you want to assign to your users. Users can start as guests and claim the funds you hold in AWS services. They can log in with a third-party identity provider to unlock access to the funds you make available to registered members. A third-party identity vendor can be a consumer, social for OAuth 2.0 vendor, such as Apple or Google, a custom SAML or OIDC identity provider, or a custom authentication scheme, also called a developer vendor, of your own design. Cognito is a part of AWS Customer Identity and Access Management, or CIAM solution, which means it's designed to manage customer identities at scale with high security. It offers features such as multi-factor authentication, risk-based adaptive authentication, and out-of-the-box compliance-focused capabilities. Cognito is also cost-effective for large use bases, with a generous free tier and low pay-per-use prices that can be much cheaper than any competing identify services. In the section below, we will see how Cognito works. We already know what is the key components, use cases, security features, integration, pricing, and more. And as you can see, this is our Cognito. So simply by watching this scheme, you can simply see that first, as a user, we will sign in to our Amazon Cognito user pool. From that Amazon Cognito user pool, we are getting a response or return access and ID tokens. Then with that ID tokens, we will be able to go to our Cognito identity pools. Then we will get our AWS scoped credentials, and finally with that credentials we will be able to access, for example, some resource. In this case, this is our DynamoDB. As you can see, we can access to AWS different services with this access or ID tokens. So this is the whole purpose of Cognito. AWS IAM Identity Center, formerly known as AWS Single Sign-On or SSO, is a service that allows organization to manage access to multiple AWS accounts and applications for a single central location. It simplifies user management and access control for AWS resources and integrated applications, providing a unique experience for workforce users. AWS IAM Identity Center is an AWS solution for connecting your workforce users to the AWS application it manages, such as Amazon Q Developer and Amazon QuickSight, and other AWS resources. You can also connect your existing identity provider and synchronize users and groups from your directory, or create and manage your users directly in the IAM Identity Center. You can then use IAM Identity Center for both following, like user access to application or user access to AWS account. IAM Identity Center acts as a central hub for managing user identities and their access to various AWS accounts and applications. So you can say that it has centralized access management. It is also simplified user management. It allows you to create, or this service allows you to create or connect the identities of your workforce, like users and groups, in one place and manage their access in your AWS environment. Also, IAM Identity Center allows users to access multiple AWS accounts and applications with a single set of credentials, simplifying sign-in process with single sign-on. It integrates with various AWS services, including Amazon Q, Amazon SageMaker, Studio, and Amazon QuickSight, providing a consistent user experience across all of these services. You can connect IAM Identity Center to existing identity provider, such as Microsoft Entra ID, Okta, or Active Directory, to synchronize users and group, eliminating the need for separate identity management. Also, you can use some different permission sets, which are essentially IAM policy packages, to define the level of access that user or groups have in each AWS account. IAM Identity Center is free to use, making it a cost-effective access management solution in your AWS environment. Also, there is some security improvements. So with this service, security is trusted. You can enable, this security with trusted identity propagation, allowing applications to access data on behalf of users without sharing their credentials. The AWS IAM Identity Center, formerly AWS SSO, provides a central place where you can create or connect the identities to your workforce in AWS once and centrally manage access to multiple AWS accounts and applications. Amazon Workspace or Workspaces is a fully managed, secure cloud computing service that allows users to access virtual machines from a variety of devices. It provides a way to provision and manage virtual machines running on Windows or Linux, eliminating the need for local hardware and infrastructure management. This service is especially useful for enabling remote work, or BYOD, or bring your own device initiatives, and rapidly scaling PC environments for teams. Amazon Workspace provides virtual desktop that run in the AWS cloud, allowing users to access their work environment from anywhere with an internet connection. Users can choose between Windows or Linux, Amazon Linux 2, Ubuntu, Rocky Linux, or Red Hat Enterprise Linux desktops. It has simplified management, so Amazon Workspaces manage the underlying infrastructure, including hardware, provisioning, operating system updates, and security patches, reducing the burden on IT departments. Users can only pay for the workspaces they use, either on a monthly or hourly basis, which can be more cost-effective than traditional desktop setups or on-premise VDI solution. Workspaces use AWS security features and can be integrated with AWS Identity and Access Management for granular access control. Amazon Workspace allows you to quickly and easily scale virtual desktops to accommodate changing business needs. Workspaces is suitable for a variety of scenarios, including remote work, BYOD programs, educational institutions, and software development and testing. Essentially, Amazon Workspace simplifies the process of provisioning and managing virtual desktops, offering flexibility, security, and cost effectiveness for organizations and their users. For example, you can work with there is some difference between Amazon EC2. So despite these similarities, Workspaces and EC2 have significant differences that makes them suitable for different use cases. The main difference lies in their purpose. Workspaces is designed specially for virtual desktops, while EC2 is general purpose computing service. With a defined workplace, it is much easier to focus on the task at hand. This helps to put employees in the right schedule to work. A quiet, relaxed office environment can support this, and this can be achieved by changing the office layout, for example. The biggest advantage of using Amazon Workspaces is that employees have access to their computer no matter where they work. You don't have to email yourself a file to transfer something from your office computer to your home computer. This ensures that someone can be as productive as possible, no matter where they work. An AWS resource group is just a collection of AWS resources in the same region that are grouped together based on common characteristics, user-defined by tags or CloudFormation stacks, as we already saw in some of the previous chapters when we learn and when I demonstrate you how can you work with tags. These groups allow users to manage and automate tasks on a set of related resources, such as a single unit. So, what is a resource group? Or simple, what is a definition for a resource group? Well, a resource group is built around a query that determines which resources should be included. This query can be based on tags, resource types, or CloudFormation stacks. Tags-based resource groups, these groups are defined by tags, which are a key value pair attached to resources. Resources that share the same key value pair labels can be grouped together. CloudFormation stack-based resource group, these groups are defined based on the resource created with a specific CloudFormation stack. Purpose of resource group is that they allow users to perform group operations on related resources, apply consistent configurations, and simplify access control. Some of the example. For example, a group of EC2 instances that represent the application layer, a group of resources belonging to a particular environment, development, preparation, production, or testing, a group of resources associated with a particular application. Advantages of using this resource or Amazon resource group: it has centralized management. You can simplify the management of a large number of resources by grouping them logically. You can automate tasks such as applying updates, security patches, or configurations to all resources within a group. By understanding the use of resources within groups, you can identify areas for cost savings, so it has cost optimization advantages. And enhance security, implements consistent security policies, and access control across all resource groups. And finally, it's very easy to monitor and troubleshoot resources that are part of a logical group. AWS Resource Group is just a service that allows you to manage and automate tasks on a large number of resources simultaneously. Also, we already see our tutorial how can we create and manage a resource group in AWS Resource Group. The task you can perform on a resource, it varies depending on the AWS service you're using and the list of resources that support a resource group and a brief description of what each service allows you to work with the resource group. You can simply go to official AWS documentation and check the resources. In AWS, a resource is an entity that you can work with. Examples include EC2 instance, CloudFormation stack, and S3 bucket. If you're working with multiple resources, you may find it very helpful to manage them as a group, rather than moving from one AWS service to another for each task. If you manage a large number of related resources, such as EC2 instances that make up the application layer, you probably need to perform group action on this application at the same time. Resource group function permissions are at the account level. As long as IAM principals such as role and users who share your account have the correct IAM permissions, they can work with the resource group that you create. Tags are properties of resources, so they're shared across your entire account. Users in a department or specialized groups can draw from a common vocabulary labels to create group of resources that are relevant to their roles and responsibilities. Having a shared set of tags also means that when a user shares the group of resources, they do not have to worry about missing or conflicting tag information. Amazon AppStream 2.0 is a fully managed service that allows you to stream desktop apps to users from the AWS cloud. It allows users to access their apps through a web browser or the AppStream 2.0 client without having to install or manage the apps on their local devices. This service is especially useful for delivering applications that require high processing power or specific hardware configurations, as the application runs on virtual machine in the AWS cloud. Of course, you can stream, and this service allows you to stream desktop apps, including those that require significant computing resources, to any computer, including Chromebooks, Macs, and PCs. You can centrally manage your app on AppStream 2.0, eliminating the need for individual installation and updates on user devices. AppStream 2.0 ensures secure application delivery, as applications and data are not stored on the user device. AppStream 2.0 automatically scales to meet the needs of your users, ensuring a fast and fluid user experience. It is cost-effective, so you will pay only for the resource you consume. Also, you can use this service, AppStream 2.0, for a variety of scenarios, including providing remote access to software for students, providing access to specialized software for engineering and design teams, and delivering applications to remote workers. Amazon AppStream 2.0 allows you to quickly and easily install, test, and update your apps using the central image creation tool. Any application that runs on Windows Server 2.16, Windows Server 2.19 and 2022, Amazon Linux 2, Rocky Linux, or Red Hat Enterprise Linux 8 system is supported, and you don't need to make any changes. Once testing is complete, you can set up startup configuration, configure default user settings, and publish an image that users can access. Using AppStream 2.0 Manage Image Updates, you can keep your images up to date with the latest operating system updates. Drivers and AppStream 2.0 agent software. We already said that you can support multiple operating systems, Windows, and different kinds of Linux distribution, and of course Amazon Linux too. And the multi-session capability in AppStream 2.0 allows multiple users to share computing resources, memory, storage, and system software associated with a given instance, while also enjoying the ability to automatically scale resources based on actual usage. This helps to reduce the cost of the solution and maximize the use of resources. The multi-session capabilities gives IT administrators the ability to adjust the number of user sessions per instance based on their individual user requirements, allowing support for a wide range of user types without over-provisioning. For multi-session fleets, IT administrators can use ready-to-use AppStream 2.0 Amazon CloudWatch consoles to monitor the performance of user sessions and the utilization of core resources. In an on-demand fleet, the multi-session capability in AppStream 2.0 reduced the average time it takes for users to separate their sessions on a given multi-session instance. Multi-session functionality is only supported for Windows Always On and on-demand fleet configurations, so multi-session instances are built on an hourly basis, regardless of the number of user sessions that run per instance. Amazon AppStream 2.0 is now available in multiple AWS regions around the world, so you can host your AppStream 2.0 resources in multiple AWS regions and route users to the nearest AWS region for the best user experience. While the two AWS services are somewhat similar, it's important to remember that Amazon AppStream 2.0 is focused on hosting individual applications on AWS, while Amazon Workspace creates virtual desktop that can be used to create complete work environment for you and your teams. And finally, you can see how this AppStream work. For example, you have option to create some isolated VPC. In that VPC, you will create your resource based on AppStream 2.0. Here, you will set OpenOffice or some Adobe resource. Then you can use your SageMaker notebook. And of course, all of this will be guided for Redshift Spectrum. And finally, you will create gateway interface that will be integrated with your SageMaker, and you will create S3 VPC endpoint, and it will be added to our secure data lake. This is our S3 buckets. And finally, as you can see, you as a data scientist or data analyst, you will use multi-factor authentication, and then you will be able to log into your AppStream application. AWS IoT Core is a managed cloud service that enables connected devices to easily and securely interact with cloud applications and other devices. It facilitates communication between devices and the AWS cloud, supporting billions of devices and trillions of messages. AWS IoT Core addresses the complexity of connecting and managing devices, allowing developers to focus on building IoT applications. Some basic functionality of this service. So you can create, or this service provides a secure and reliable way to connect devices to the AWS cloud using protocols such as MQTT, HTTPS, and LoRaWAN. Also, it acts as a message broker, routing messaging between devices and application, ensuring reliable and timely delivery. AWS IoT Core maintains a shadow for each device, which is a permanent virtual representation of the state of the device in the cloud. This allows apps to access device information even when the device is offline. It is also designed to handle a large number of connected devices and messages, making it suitable for a large-scale IoT deployment. IoT Core provides robust security features, including device authentication, authorization, and encryption to protect data and devices. Key features. First, you must register your device. So it has a central location for managing and monitoring all registered devices. Then something called device shadow. This is a permanent display of the status of the device for offline access. Then it allows you as a user, developer, administrator to define rules for processing and route message based on specific criteria. Also, there is a lot of connectivity options. As I already told you, it supports various protocols like MQTT, HTTP, and LoRaWAN for different types of devices and connectivity needs. And integration is excellent, so you can seamlessly integrate with other AWS services such as AWS Lambda, Amazon S3, and Amazon DynamoDB for data processing, storage, and analytics. Some example of use case: industrial IoT, monitoring and managing of industrial operations, including predictive maintenance and remote operations; smart homes, building connected applications for home automation, security and tracking; automotive, development of solutions for connected autonomous and electric vehicles; public safety, designing applications for traffic monitoring and health monitoring; and essentially, AWS IoT Core simplifies the process of connecting, managing and interacting with devices in the IoT ecosystem, providing a secure and scalable platform for building connected solutions. As you can see, this is our cloud service, and we have a different option with our IoT core. So for example, you can use your IoT or Internet of Things devices at home. So you can, on your local network, you can add some different apps, to say, at least. So you can add, for example, your fridge, your TV, your cameras, anything that is now available of this that you can access to your local network. Of course, you can add your IoT devices at work and all devices in the community. For example, some different devices that you can see, there is some different, I don't know, vehicles or so on. And you can see we have our app and cloud service. And all of these signals from all of these devices at your home, at your work, at your community will send all that signals and messages to one centralized place in our cloud service. And this is IoT core that is used for. So you can see this is our AWS IoT architecture. We have some data services like Amazon Kinesis video streams, AWS IoT events, and AWS Sitewise, IoT Analytics, Fleetwise, and TwinMaker. We have control services, IoT Core, IoT Device Defender, IoT Device Advisor, and IoT Device Management. And we have device software like IoT Device SDK, IoT Express Link, IoT Device Tester, and IoT Greengrass, and of course free RTOs. The main point of this site, of this core architecture, of this core service, is that this is just one of the, as you can see, 10 services that makes this IoT architecture great if you want to use Internet of Things in AWS. AWS Device Farm is a testing service provided by Amazon Web Service that allows developers to test their Android, iOS, and web applications on real-world physical devices hosted in AWS Cloud. It enables automated testing using a variety of frameworks and also provides remote access for interactive debugging and troubleshooting. Here are more detailed overview of this service. So, Device Farm offers to a wide range of real physical devices like phone and tablets for testing rather than emulators or simulators. You can upload your own test or use a built-in compatibility test with a script to run automated tests on multiple devices at the same time. Device Farm allows you to remotely access and interact with devices in real time, allowing you to debug, reproduce customer scenarios, and conduct usability testing. You can see your all-comprehensive report once the tests are running. Device Farm provides detailed report including logs, screenshot, videos, and performance data, helping you identify and resolve issues. By using Farm or Device Farm, developers can avoid the additional cost of managing and maintaining their own device infrastructure, leading to cost savings. Device Farm supports testing on Android, iOS, and Fire OS apps. Device Farms allow you to upload your own test or use built-in compatibility test without scripts. Since testing is performed in parallel, tests on multiple devices begin in a matter of minutes. As the tests are completed, the test report is updated to include high-level result, low-level logs, pixel-by-pixel screenshot, and performance data. Device Farm supports testing of native and hybrid iOS and Android apps, including those created by using PhoneGap, Titanium, Xamarin, Unity, and other frameworks. It supports remote access to Android and iOS apps for interactive testing. Remote access allows you to swipe, gesture, and interact with the device through your web browser in real time. There are a number of situations in which real-time interaction with the device is beneficial. For example, customer service representatives can guide customers through the use of a setup of their device. They can also guide customers to the use of the apps that run on a particular device. You can install app or apps on a device running in a remote access session and then reproduce customer issue on reported bugs. During a remote access session, device farm collects details about actions that occur while you interact with the device. At the end of the session, records are created with these details and a video recording of the session. There are limits to the duration of the automated test of 150 minutes. The maximum number of tasks in progress, including tasks in the queue in your account, is 250. This is a soft restriction. There is no limit to the number of devices that you can conclude in the test. A mobile device is a farm is a cloud based on premise testing environment that provides access to a wide range of real-world devices, operating system, and network condition. It helps ensure compatibility, performance, and reliability before deployment. AWS KMS or AWS Key Management Service is a cloud-based service that allows users to create, manage, and control encryption keys that are used to protect data within AWS services and different applications. It provides a secure and scalable way to encrypt, decrypt, and manage cryptographic keys, ensuring the confidentiality and integrity of data. Key management of this service are AWS KMS allows users to create and manage and control the life cycle of cryptographic keys, including their creation, rotation, disablement, and deletion. Allow users to encrypt data using this key, protecting sensitive information stored in AWS services such as S3, EBS, and others. Also, AWS KMS is deeply integrated with various AWS services, allowing them to take advantage of encryption and key management capabilities without the need for users to manage the underlying infrastructure. KMS keys are protected by FIPS 100-2 validated hardware security modules, or HSM, which provides a high level of security for your encryption keys. AWS KMS provides granular control over who can access and use key through the key policies, and integrates with AWS Cloud Trail to audit and record all key uses. First, you need to know that KMS is used for a variety of purposes, including data protection and rest in transit within AWS services, signing and verifying data to ensure its integrity. You can generate random numbers for cryptographic operations, integration with custom encryption and key management applications, CM key or user master key. There are the primary key that are managed in KMS. They can be AWS managed, user managed, or AWS owned. Key material, the actual cryptographic material used for encryption decryption. In KMS, this is securely generated and managed within the HSM. And then we have something called Cloud HSM. AWS Cloud HSM is another service that provides dedicated HSM for users who need more control over their cryptographic keys and hardware. The AWS Key Management Service gives you control over the cryptographic key used to protect the data. It also gives you centralized control over the life cycle and permissions of your keys. You can create new key whenever you want, and you can control who can manage the key separately from who can use them. The service is integrated with other AWS services, making it easy to encrypt the data you store in these services and control access to the keys that decrypt it. AWS KMS is also integrated with AWS Cloud Trail, which help you see who used which key, on what resources, and when. AWS KMS helps developers more easily add encryption or digital signature functionality to their application code, either directly or by using the AWS SDK. The AWS Encryption SDK supports AWS KMS as a key provider for developers who need to encrypt or decrypt data locally within their application. AWS KMS is a fully managed service. As your use for encryption grows, when you work on some different resources or services in AWS, we already saw in the KMS that we have a dozen of different free keys. So this service automatically scales to meet your needs. It helps you manage tens of thousands of KMS keys in your account and use them whenever you want. It also defines the default limits for the number of keys and request rates, but you can request increased limits if necessary. KMS keys that you create or those created on your behalf by other AWS services cannot be exported from the service. Therefore, AWS KMS takes responsibility for their durability. To confirm the high availability of your keys and your data, AWS KMS stores multiple copies of encrypted versions of your keys in systems that are designed for 99 point, you can see how many 9% of durability, for encrypted data or digital signature workflows that move across regions like disaster recovery, multi-regional high availability architectures, DynamoDB global tables, and globally distributed consistent digital signature. You can create multi-regional KMS. KMS or KMS, multi-regional keys, are a set of interoperable keys with the same key material and key ID that can be replicated across multiple regions. AWS KMS is designed to be a highly available service with a regional API endpoint. Since most AWS services rely on it for encryption and decryption, this service is designed to provide a certain level of availability. And finally, this service is designed so that no one, including AWS employees, can retrieve your plain text key from the service. Your plain text key are never written to disk and are only used in the volatile memory of the HSM for the time it takes to perform your required cryptographic operations. This is true whether you require AWS KMS to create key on your behalf, import them into service, or create them in the AWS Cloud HSM cluster using the custom key storage feature. You can choose whether to create keys for a single region or multiple regions. Keys for a single region are never transferred outside of the AWS region in which they were created and can only be used in the region in which they were created. AWS KMS integrates with other AWS services to encrypt data at rest or to facilitate signing and verification with an AWS KMS key. To protect data at rest, integrated AWS services use envelope encryption, where the data key is used to encrypt the data and is itself encrypted under a KMS key stored in AWS KMS. KMS uses a client-server model to activate client, and it's used to activate volumes. KMS clients connect to a KMS server called a KMS host for activation. The KMS host must be located on your local network, and KMS hosted do not need to be dedicated servers, so this KMS can be co-hosted with other servers. And once again, we are in our console management, AWS console management. As you can see, we learn a lot, but this time we will go once again to our KMS or key management service, and you can, as you already know, create your keys here. Finally, if you want to create your key, we already looked at some different things about this service, and just once again to be sure, now that we know how to use most of these services, you can also create your own key if you want. Of course, there is a different option, and as you already know, Amazon creates some managed key on their behalf when we need to work with some different services, of course. And as you can see, if I go to my AWS management key, and there is also a different customer managed key, we have these AWS Cloud HSM key stores. So, as you can see, we don't have any custom keys in our store, and we don't have any external key store. So we can create an external key store. For example, we need to add a name for our key store. Then you can choose between public endpoint and VPC endpoint. So if you choose public endpoint, you will add the name. You need to add the name for this prefix, and you can simply create your external key stores. If we go to AWS Manage Keys, you can see that we have different keys, and all these keys are available to us. And as you can see, this is created by Amazon when we work with AWS SNS service, FSX, Lambda, Backup, S3 service, RDS, or EBS. If I, for example, go inside one of these aliases, or simply if you looked in key ID, you can see that there is a status enabled, but our ID is different for every key, and that is expected, of course, because all these keys are different for different services. If you go, for example, to our Lambda service, you can see what is or when our creation date is added. This is a single region key, so you can use it only in this United States North Virginia region, and it is enabled and default key that protects my Lambda function when no other key is defined. You can see Azure resource name and current key material ID. If I scroll down, you can see that we have our key policy, and this policy is also in JSON format, of course. It is allow access through AWS Lambda for all principals in the account that are authorized to use AWS Lambda. So all my services or principals can use this service in the behalf of in my account, of course. Here you can encrypt, decrypt, re-encrypt, general data key, create grant, or described key, as you can see. And this is our lambda.us east 1 Amazon AWS.com, and this is my caller ID. This is our account ID, if you remember. And finally, it is located in our North Virginia region, so you can't use this key in any other region except in this North Virginia. And you can see what are the actions, and resources is star. It means it can be used for all other resources. So this is just a key policy, a JSON policy, and we have these cryptographic configurations. The key type is symmetric. You can be asymmetric or symmetric. This time is symmetric. Origin is AWS KMS service. Key specification is symmetric _ default, and key usage is for encrypt and decrypt, of course. Then if we go to some other service, for example, if we go inside S3, you can see that we have date of creation. Again, this key is only for this region. So as you can see, this is some kind of zonal key, and it will allow access through S3 for all principals in the account that are authorized to use S3. So all principals from all resources will now have the option to use this key to describe, get, or list my object in S3, for example. And finally, we have this for EBS, as you can see, and allow access through EBS for all principals in the account that are authorized to use elastic block storage, for example. And that's it. There is a similar policy, as you can see, but there is difference between these services. If you go to customer manage key, you can create your own key if you want. So with customer manage key, you as a customer have the all, let me say, permissions to encrypt or decrypt your data, your keys, your certifications, and so on in your account. If I go to manage key, you can see that we cannot enable or delete neither of this key, but with the customer manage key, you can create your own key. If you click on create key, you can see that we have 6 steps, and step 1, 2, and 6 are obviously we must add some configurations type. You can be symmetric, asymmetric, so you can use this key to encrypt, decrypt, sign and verify, or for key agreement. And of course there is a detailed explanation for all of these options. You can then, for example, add your option to encrypt or decrypt. You can create a simple symmetric key, and if you add asymmetric key, then you have, for example, key agreement. Then you will see that you can choose the type of key material in your signing in key, and you can use one of these specification. And if you don't know how to choose, simply click on this help me to choose, and you will be very aware about all of these options. Finally, you can use the private key for signing and the public key for verification. And finally, this key agreement, this is simply a key pair that derived or share your secret. As you can see, there is more options for key specification if you use this sign and verify, then key agreement. But once again, we are using our asymmetric key encrypt and decrypt. In the option, you can use this KMS recommended, and you can use external by important key material. And finally, here you can choose your key if you want to be for this single region or for multi-region key. If you choose this other option, then you will be able to replicate this key to any region by your choice. So it is very, very easy to understand and create AWS key, customer managed key. And just to repeat once again, with customer managed key, you as a user have all the options to encrypt and decrypt your own keys, certificates, and so on. Passwords, for example. And that's it. This is the whole point and implementation of our key management service. And when you use customer managed key, you will pay some random price for this service. But if you use AWS managed key, they are free for use, and you can delete them. That's the most important thing. So here you need to add your labels. If you want, you can define your key administrative permissions, usage permissions, edit key policy, and finally in the review and create you will be able to create your key. This is optional of course, so you can add, or it really depends what do you want to achieve with these keys. Here you can define your permission for these cryptographic operations, of course, for administrative permissions and for usage permissions. Then you can edit your key policy if you want. You can also add another AWS account. So administrator of that account that you specified from some different account can have access to this key. And here is our key policy. As you can see, we can enable our IAM user permission, and this is our root user. Action is KMS, and finally, when you create a review and create, you will be able to click on finish and to create this key. Of course, I will not create this key because this key can create some more expense on your AWS account. And that's it. Thank you for watching. Amazon Elastic Transcoder is a cloud-based media transcoding service offered by Amazon Web Service. It allows users to convert media files, such as videos and audio, from one format to another, making them compatible with different services and platforms. Essentially, it's a scalable and cost-effective way to make your media accessible on a variety of devices, such as smartphones, tablets, and web browsers. The Elastic Transcoder takes your original media files, for example, high-resolution videos, and convert them into a variety of formats and resolutions suitable for different playback devices. It is designed to handle large volumes of media files, so it will automatically scale to meet your needs. It is very easy to use, and it simplifies the transcoding process by offering a simple pipeline-based approach and predefined settings for common device formats. You only pay for the time of transcoding you use, making it a budget-friendly solution. The Elastic Transcoder integrates seamlessly with other AWS services such as Amazon S3 for storage or Amazon SNS for notification. Some of the key features of this service: it supports a wide format support, handles a variety of input and output formats, resolution, bitrates, and frames per second. They have advanced features, so they offer features such as automatic bitrate optimization, thumbnail generation, watermarking, subtitle support, encryption, and more. Allow you to create and use presets to common transcoding tasks. You can set up pipelines to manage the input and output S3 buckets for your transcoding task, and you can use IAM control rules to control access to your AWS resources. So this is what can you do with Amazon Elastic Transcode. In AWS Backup, a backup vault is a secure centralized storage location that organizes and stores your backups, recovery points, or of various AWS resources. Think of it as a container that contains your backup data, making it easier to manage and access and control access to those backups. Well, this vault provides a single backup storage location for various AWS services such as Amazon EBS, RDS, and DynamoDB, simplifying management and reducing the complexity of individual service configurations. AWS backup vaults are encrypted using AWS Key Management Service keys, ensuring the confidentiality of your backup data. You can choose the encryption key that will be used when creating the vault. Vault allows you to define access policies using AWS identity and access management, controlling who can access and manage backup data within the vault. Also, you can add backup policies so you can link backup plans to your backup vaults, specifying when and how to backup your resources. Vault helps you organize your backups, making it easy to find, restore, or manage your data when needed. AWS also offers logically isolated vaults for increased security and controls, which can be shared with other AWS accounts for faster recovery times. AWS Backup Vault is a secure centralized repository for storing data backups across AWS services. The system integrates with AWS Backup, enabling automated backups management for resources such as Amazon EBS, RDS, and DynamoDB. This allows organizations to manage and access backups without the complexity of configuring individual services. Using Backup Vault, administrators can implement policies that ensure regular backups and optimize storage utilization while meeting compliance and auditing requirements. The platform integration with AWS Identity and Access Management provides control who can access and manage data backups. With lifecycle policies, administrators define how long backups should be kept before they are moved to cold storage or permanently deleted. This automation can reduce cost by optimizing the use of resources over time. Also, these policies simplify administrative cost and guarantees compliance with data retention standards. By implementing lifecycle policies, organizations can automate backup transitions without manual intervention. This encourages consistency in data storage practices and minimizes the potential for human error. In addition, automating the cleanup of outdated backups prevents unnecessary storage cost and reduces the risk of configuration shifts. Inter-regional backups or cross-regional backups allow you to keep copies of data in different AWS regions, mitigating the impact of region-specific disruption. The geographic dispersion of data supports disaster recovery strategies and assures access data to them regardless of location-based disruptions. The functionality of interim backups promotes a collaborative approach to data protection. Organizations can share their backup resources across separate AWS accounts, creating an environment where backup strategies can be centralized or decentralized as needed. This flexibility can benefit larger businesses with numerous subsidiaries or departments. All data stored in the vault is automatically encrypted using AWS KMS. AES-256 encryption ensures data security, preventing unwanted access and meeting compliance standards. This level of encryption secures sensitive data and is compliant with regulations such as GDPR and HIPAA, ensuring that organizations adhere to global data protection standards. AWS Backup Vault integrates with AWS IAM to offer access policy management. Organizations can create custom policies that determine which users or groups can perform operations on backup resources. This capability is necessary to enforce internal security protocols, support compliance, and minimize the risk of unauthorized access to data. Detailed access control ensures that vault operations remain secure. Users can define permissions that restrict actions such as creating, editing, or deleting backups. This hierarchical permission system prevents unauthorized users from making changes, protecting the integrity of backups. AWS Backup Vault is not a free service, so be sure to check the price list on AWS website before you start using it. If you go back to our console, you can see that we really learned a lot. But this time I want to show you the separate service called AWS Backup. So in our search bar, we can go and type AWS Backup. As you can see, this is a centrally managed and automates backups across AWS services. Here, you can create your backup plan, for example. We have our dashboard. This is our job dashboard. We have our vaults. We have our backup vault logs, protected resources. Then in the external resources, we have gateways, hypervisors, virtual machines, and you can also use this as backup policies, frameworks, or see all reports. Here, this is some kind of central platform, and of course, if you use AWS Backup, you will pay only for the amount of backup storage you use and the amount of backup data you restore in that month. As you can see, this is how you can work. You can create, manage, and assign all of this, and this is all supported services in our backup. So you can backup, for example, EC2 machine, RDS service, DynamoDB, EBS, AFS, Storage Gateway, and Amazon FSx. Here are some benefits and features, and you can take this if you go to that service and see for yourself. If you want to create a backup plan, simply click on Create Backup Plan, and here we have some starting options. First, we can start with a template. This will create a backup plan based on template provided by AWS Backup. You can also create a new plan from scratch or define a plan using JSON file or JSON expression. Here, as you can see, there are different options. Then start with a template. And finally, here you can paste your own JSON files, add a backup plan name, and that's it. If you go back to our first option, when you choose Start with a template, you can choose a template, for example, with existing roles. You can use daily, 35-day retention, or daily monthly with 1 year retention, daily weekly monthly with a 5-year retention, and daily monthly weekly with 7-year retention. This retention period is simply allows you how many days or years can you have your backup on this, for example, S3 storage, because AWS uses S3 service to keep all your backups to 35 days, 1 year, 5 year, or 7 year. So that's it. This is all that you need to know. So you can first choose this template. Of course, you will need to create this backup plan, and then you need to choose between this backup plan option. When you use a template, you must use one of these existing template with existing rules. I will choose the first one, daily with 35-day retention. Then I will add my backup plan name. As you can see, I can add even a role for this backup. And if you go to tags, I can add a tag if you want. These backup rules specify the backup schedule, backup window, and lifecycle rules. If I click on backup rules, here I can simply create the name for my backup. This is automated name. And here I can choose my backup vault. You can create a new vault from here or simply use this backup vault, default backup vault. And finally, in this backup frequency, you can choose how much do you want that you backup be taken, for hourly, every 12 hours, daily, weekly, monthly, or custom cron expression. We already know what is a custom cron, so here you will define your hour, day, month, and so on, week on month. I will leave this as a daily, and here we need to specify the start time of this backup. So you will add, for example, your own time, start time, and your, of course, your time zone, of course. Then you need to specify the period of time which the backup plan start. If it doesn't start at a specific time, at specified time, for example, you can choose this, that it needs to start within 8 hours, and then how many days do you want to, or hours that you want to complete this backup. So here you will add this backup window, start time, and that's it. This is very, very simple. Finally, we have something called point-in-time recovery. If you enable this continuous backup for point-in-time recovery, this will help you to restore your AWS backup supported resource by rewinding it back to a specific time when you choose within 1 second of precision. So you can use this for Aurora, RDS, S3, SAP HANA, or Amazon EC2 resources. So you will go back maximum 35 days, and then you can choose your restore point, and you can simply enable from that restore point your backup, and you will be able to create that machine, of course. And that's it. This is the whole point of point in time, or PITR, or PTR as someone would like to say, of your backup. Of course, there is also a life cycle. So when these retention days goes beyond that 35 days, you have option to choose your life cycle. Then after 35 days, you want to specify, for example, that backup move from warm to cold storage. So it is available for CloudFormation, DynamoDB, EFS, SAP HANA, TimeStream, and VMware Virtual Machine. So what does that mean? That means that after 35 days, your retention backup or restore point will move from warm to cold storage, and automatically your cost or expenses will be much lower because we are using now cold storage. And that's it. You can specify the AWS backup, how long to store your backup, and after that day, after expiration of these days, then it will move back to our cold storage. Also, we have some optional backup indexes, copy to destination, and so on. So you have option to, if you want to copy backup in a separate backup vault or logically air-gapped vault, you can choose your region here. And finally, you can click on Save Backup Rule, and this is how can you create your backup plan, and that's it. After that, you will be able to implement this backup rule into your backup plan. And of course, if you are using Windows machine, you will enable this application consistent snapshot for application for supported VSS. So if you want to know more about Windows VSS, go back to Azure Backup and you will find out more about that. Or if I remember correctly, I already explained this in some of my certificate course, so I really can't remember right now. And that's it. We created our backup rules, we created our everything, and here you can also add another rule, and simply you can add this rule to our plan, and if you want, you can create your plan. Also, you can create a new plan, create from scratch, schedule, vault, backup frequency, backup window, start time, complete time, life cycle, and all other settings. And finally, you will be able to create this plan. Or you can also start with this simple template when you choose your 35 days retention, and you can leave everything as it is and simply click on create plan, and this plan is successful. Creation is successful, and now you can add additional schedule rule and assign these resources to this backup plan by selecting your backup plan. Here you can find to protect define resource selection. You can protect all resources or specify resources by your type or some kind of ID. You know that all resources have their own ID in the AWS, and it will protect all resource types, or you can include some specific types. Finally, you can refine selection by using tags, and this is an option. You can also assign resources, and this is the next step that you need to provide. Of course, it really depends of what resource selection do you want to use here. The better thing is to include all resource types, so all resources will be enabled into your account with this protection. So this backup plan will be automatically used, for example, all each instances in your account, as you can see. And finally, you can assign your resources or cancel this, because this is just a simple walkthrough how can you set up your backup in AWS. On the other hand, when we talked about Azure, I showed you how can you backup your VM, for example. And here, if you choose include specific resources, you can select your specific resource, and as you can see, there is a lot of options that you can choose from, and it really depends of what type of resource are you selecting here. And you can use, as you can see, a various type of resources. Even VMware machines. Let me choose my EC2 machines and EBS, for example, and finally I can choose my resources. I will now all volumes or add specific machines here, and of course all instances. And that's it. This is how can you set this up. How can you assign your resources or resource selection. Finally, you need to add your name, resource assignment name, and this is not an optional. And of course, IAM role will assume that you have your role. You can add your role if you have one already created, or if the AWS backup the role is not present, it will create automatically for you. And of course, you can exclude some specific resource if you don't want to be backed up, and so on. You can also filter this by tags, and that's it. We know how can we work with tags now, and simply you will be assigned these resources to this plan. So this is the whole point of our backup, as you can see. And finally, here you can add your tags. I will now cancel this, and as you can see, this is how can you set up your backup. And now I will delete my backup plan because I don't want to create unnecessary costs here, and I will delete my plan. As you can see, we successfully deleted our plan, and there is a lot of different options here, and you can see backup vault locks, for example, how it works. We have our default lock, we can edit this lock, create a new lock, and so on. This is our recovery points, as you can see. And if I go to my dashboard, you can even see how can we create a backup plan, on-demand backup, or some frameworks. Also, there is a lot of new features, as you can see, for Aurora, for EBS snapshot, and so on. And if you go to backup plans, simply you can create your backup plan right from here, or recovery points, and so on. AWS Marketplace is a digital catalog that enables customers to discover, purchase, and deploy third-party software, data products, and professional services that run on Amazon Web Services or AWS. It simplifies procurement by providing a centralized platform where organizations can evaluate solutions, compare offerings, and quickly integrate them into their cloud environments. One of the key advantages of AWS Marketplace is its ability to streamline software acquisition and management. Customers can leverage flexible pricing models, including pay-as-you-go, annual subscriptions, and custom contracts, while consolidating billing through their own AWS account. This reduces administrative overhead and accelerates the adoption of new technologies across the organization. For some software vendors, AWS Marketplace provides a powerful channel to reach a global audience of AWS customers. By listing products on the platform, vendors can simplify deployment, automate licensing and billing processes, and benefit from AWS' extensive ecosystem. This helps businesses expand their market presence while enabling customers to access trusted and validated solutions more efficiently. AWS Marketplace also supports governance and compliance requirements by offering detailed products information, customer reviews, and security documentation. Organizations can make informed purchasing decisions while ensuring that selected solutions align with their internal policies, industry standards, and regulatory obligations. The platform integrates seamlessly with existing AWS services, enabling customers to deploy and manage software solutions within their current cloud infrastructure. These integrations reduce deployment complexity, improves operational efficiency, and allows teams to scale resources according to business needs without significant additional effort. As cloud adoption continues to grow, AWS Marketplace plays a critical role in helping organizations access innovative technologies faster. By providing a trusted environment for software procurement and deployment, it enables businesses to accelerate project delivery, optimize costs, and maintain a competitive advantage in increasingly digital marketplace. And if you go to aws.amazon.com/marketplace, you will see various options that you can choose from. For example, you can choose your perfect match from over 30,000 cloud solutions. For example, you can write here and click on, you can write prompt, here, and click on send message, and then agent will help you to find whatever you need. Of course, the most subscribed products from the last month you will see here by tabs, by AI agent and tools. So we have something called Brave Search API for Brave. We have Document Intelligence AI agent, Asana MCP server, Pokey AI agent. Of course, this is expected because AI now is more popular than anything. Then you can see custom pricing in minutes right in your AWS Marketplace console, for example, and so on and so forth. But you can compare products, for example, create proposal, and so on. Here you can see other options like SaaS. We have Databricks, for example, MongoDB. We have AMI machine image like OpenVPN access server. We have Fortinet and so on. We have containers, machine learning, professional services, data, and something is free. For free, we have Kali Linux. We have AWS Apache Hudi connector for AWS Glue. We have Rocky Linux 9, which is official, and we have Ubuntu 22.4 LTS Jammy, which is extremely popular in AWS. As you can see, if I scroll down, we have these popular categories, and here you can search, for example, operating system, security, networking, storage. You can view all categories. For example, if I click here, you can see your search result. Let me just wait a little bit. And here, as you can see, almost 20,000 professional services, more than 15,000 infrastructure, software, DevOps, almost 8,000 machine learning. And as you can see, there is a lot of options by categories, and these options can help you to get more advanced, to learn more and more, to go even more further with these third-party apps. Of course, these apps are paid apps, and you need to be aware that every service has its own price. Of course, this is just a little presentation of AWS Marketplace. So once again, if you go to aws.amazon.com, you will find exactly everything as I'm showing you here. So you can also sell in AWS Marketplace. For example, if you have some different, if you are some vendor or you have some product, you can sell your solution to AWS customers by committing your product in AWS Marketplace. But first you must be registered, as you can see. Also, AWS Marketplace is hiring, and here you can find even more and more information about anything, as you can see. So you can become a channel partner, you can sell here, as I already told you, and you can choose delivery method, categories. As you can see how much categories we have here. So this was just a simple information about AWS Marketplace. If you click here on this link, you can see for yourself what is AWS Marketplace. So once again, you can even play this little video.
In today's fast-paced cloud environment, quick access to software, data, and professional services is critical to running your business and accelerating innovation. AWS Marketplace is a curated digital storefront helping companies of all sizes find, try, buy, deploy, and manage solutions from thousands of trusted AWS partners. AWS Marketplace helps you discover thousands of software listings across security, DevOps, data and analytics, generative AI, and more, all from leading vendors that run on AWS. Learn how to solve industry-specific use cases by accessing curated industry storefronts and product details. AWS Marketplace sellers offer pricing flexibility with thousands of free trials and pay-as-you-go purchasing, ensuring you only pay for what you need. When ready for a bigger investment, save money with long-term contracts, bring your own license, or negotiate custom pricing and terms with private offers. With AWS Marketplace, you can optimize time to value with standardized contracts and vendor security profiles. Launch products fast with quick launch capabilities. Put controls into place to protect your organization and even create your own private marketplaces of pre-approved products. Consolidate your third-party spend with AWS Billing, helping you simplify invoicing, track spending, and manage budgets. Ready to accelerate your innovation in the cloud? Get the software, data, and services you need with AWS Marketplace.
Of course, the last service in this course is AWS License Manager. This is a service that helps organizations manage and control software licenses across their AWS and on-premises environments. It enables administrators to track license usage, enforce licensing rules, and ensure compliance with vendor agreements without the need for complex manual processes. One of the primary benefits of AWS License Manager is its ability to provide centralized visibility into software license consumption. Organization can monitor the usage of licenses for products such as Microsoft Windows Server, SQL Server, and other enterprise software, helping them avoid over-provisioning and unnecessary licensing cost. Of course, AWS License Manager allows administrators to create custom licensing rules based on specific business requirements. These rules can automatically restrict the deployment of resources when license limits are reached, reducing the risk of non-compliance and helping organizations maintain proper governance over their software assets. By automating license tracking and compliance management, AWS License Manager simplifies operational workflows and reduces administrative overhead. This enables IT teams to focus on strategic initiatives while maintaining better control over software licensing, improving cost optimization, and supporting efficient cloud resource management. When it comes to other AWS services, the number of available offerings is truly vast. Despite my desire to demonstrate and introduce as many services as possible, it is simply not feasible to cover all of them within a single course. First, the course would become excessively long, and second, we have already focused on the most important services that provide the solid foundations for working with AWS. Another important point I would like to highlight is that I did not cover the core principles of the AWS well-architected framework, which is an essential topic for certification exams. However, you can find comprehensive information and learning materials on the official AWS documentation and training resources, where the framework is explained in detail. As time goes on, AWS continues to introduce new services and enhance existing ones. The cloud landscape is constantly evolving, but the fundamental concept, best practices, and learning approach remain largely the same. Once you understand these core principles, adapting to new services becomes much easier. If you are interested in exploring AWS services that were not included in this course, I encourage you to do so independently. After completing everything covered in this training, you will have the knowledge and confidence needed to quickly understand and learn additional AWS services on your own. The skills and concepts you have acquired here will provide the strong foundations for continued growth and specializations within an AWS ecosystem. And finally, the last chapter of this course is my final word about the course itself. Well, as I already told you in the beginning, when I first started planning and recording this course, my goal was to create a training program that would last around 10 hours and give everyone an opportunity to learn the fundamentals of AWS. However, as time went on, I realized that it was impossible to explain one concept properly without covering several related topics as well. As a result, the course gradually grew up to more than 30 hours of content. To be honest, it could have been even longer, as some sections were shortened and others were removed to keep the course manageable. By combining AWS training materials that I had previously developed with new content recorded during my limited free time, I was able to complete this extensive AWS course after several months of work. Its working title is AWS Certified Cloud Practitioner, although it could just as easily be called AWS from zero to hero or something similar. Ultimately, it is up to you to decide which topics are most relevant to your learning goals and which parts of the course you would like to focus on. One important thing to mention is that due to technical limitations, this course could not be uploaded as a single video. Therefore, it has been divided into 3 separate parts. Make sure to check the links to other 2 parts, which will be available in the description, so you can access the complete course content. This has been a long and thoroughly prepared course, with perhaps an occasional mistake and certainly a lot of detailed explanation along the way. After all, anyone who creates something is bound to make mistakes from time to time. What matters most is that you now have access to a comprehensive course that can help you build a strong foundation in AWS and its services. I wish you the very best in your learning journey and future career. Thank you for taking the time to follow this course, and if you find it valuable, please consider liking, sharing and subscribing to my channel. Your support motivates me to continue creating new courses and educational content for the community. Of course, you can check my other courses on my channel and enjoy learning, and hard work pays off.